actual lower letter. So my method takes the self argument as always, and right here it will print calling parent method. Okay, so this is our entire class, parent class. Basically what we want to do right now is define a child class, which is going to inherit its parent's method. So child, and in between the brackets parent. This is nothing really new to us. We saw this in the previous video. So right here, all we're left to do is name the actual method with the same name that we actually named it in the parent class. So right here, it will take the self argument and it will print calling child method. Okay, so simple as that. Right here we have the actual two same classes. Basically they perform the same task. They simply just print a statement, as we can see right here. This one prints calling parent method and this one prints calling child method, which basically this one inherited it from this one. So it basically has two methods that are my method. But if you simply just define the instance of the child class and call the my method, you will notice that the actual statement that it prints out will be calling child method. So that is how you can actually override the actual method from the parent class. Okay? So instead of actually overriding the methods in the classes, you can also overload operators. Now, basically what that means is, let's say there is a good example. Suppose you have created a vector class to represent two-dimensional vectors. Now, what happens when you use the plus sign to actually add those two vectors? Well, Python will actually give you an error because it can't really do that. But you can, however, define the add method in your class to perform vector addition, and then the plus operator would behave as per expectation. So basically it means if you create the add method to your class, which will be specified a certain type of adding two vectors, or doesn't have to be vectors at all. Maybe you want to specify the add class, which is going to add a little bit differently than simply just specifying the addition sign, which is a plus sign. So 4 plus 4 is equal to 8. But let's say you want 4 plus 4 for some reason to be equal to 10. You can simply just add the actual formula to the add method in your class, and it will perform the addition differently once you specify 4 plus 4 next time. So let us see how we can do that with simply vectors. So if you just define class vector right here, whoops, let me just go right here. So class vector, we add the init function in it, and it will take the self argument as well as the vector A and vector B. Okay, so it takes three arguments, which one of them is the self argument. So right now all we're left to do is type self.a equals A and self.b equals B. Right now what we're going to do is we're going to create a string function or str function, which is going to take the self argument, and it is going to return the values of those two vectors. So right here, if we just type here define str, takes the self argument right here, and it will simply just return open single quotes vector, and we know that this is going to be the actual integer value, so therefore we specify %d, comma %d, and then we add the percentage of self.a and self.b, which basically means that we actually return these values of these two vectors that we defined right here. Okay, so simple as that. Right now, what we are going to do in the next function is we are going to perform the addition of these two vectors. And how we're going to do that is we're simply going to type it like this: define add function, which is going to take the arguments of self and then other, as you will see in just a case. Let me just show you right here. Self and other, add the two dots, and we are going to return from here the vector, which is the name of our actual class itself, And then we're going to simply just type self.a plus self, or pardon me, plus other.a, and then comma self.b plus other.b. So this is going to be simply our formula. We press here enter, and this is our entire class. And you will see if you just define the vector 1, for example, to be equal to the vector of, and specify the values of 2 and 10. We defined these a and b variables right now with the specified things right here. And in order to actually add vectors, you need to specify the second vector as well. So right here, v2 equals vector 5 and minus 2. And now if you just print v1 plus v2, you will see that we get the vector 7 and 8. So basically we went to this statement right here, and it printed out the values of this vector. So the a, which is the 7, and the b, which is 8. So basically we added these two vectors, 2 plus 5, 7, 10 plus minus 2 is 8. So therefore our vector is the result of 7 and 8, which is performed in this action right here. As you can see, self A plus other.a, which stands for the second vector, and self B plus other.b. Okay, so basically that would be about it for the overloading operators, and also for the inheritance class and overriding methods from the inherited class. And we will continue coding in the next lecture. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this next section, where we are going to take a look at getting the current date and time in actual Python. Now basically there are multiple modules that you can actually import to perform these different tasks, such as the time module, the calendar, and so on and so on. And we're going to take a look at some of them, and also some of the useful functions that you can use in order to get specific time, or in order to calculate something, which can be basically useful to you in certain programs. So the example one that we're going to take a look at is how we can actually get the current dated time. So simple as that. If you open up your idle, so just go up here, type here idle, and simply just write import date time. You can see that it will import an actual library that will allow us to perform different tasks. In order to actually see what's inside the datetime library, we can use the dir function, which will allow us to see everything that is in this datetime library. So in order to do that, you can just simply print dir, and then you, in between the brackets, specify the name of the library itself. And then you can see right here what it has in it. So we can see time delta, time zone, time, sys, datetime. So you can see the time is actually a part of the datetime library. You have all of these actual doc, file, name, package, spec, date, date time itself, max year, min year, and so on and so on. So that is how you can actually check out what's inside a certain library. And right now, let us see what we can do with this library. So first of all, let us create a datetime object, which we can set to be equal to datetime, and then dot, and then we're going to call the datetime, which is simply calling this part right here. As you can see right here, it also has a datetime inside the datetime. Therefore, we are going to call it, and from there, we're going to call the class, or pardon me, the method now. Now right here, what this method will do is it will simply print the current dated time. So first of all, we define it, and then we print the datetime underscore object. And it will say that today is the 27th of May, 2019, 10:21, 16 seconds, and this is milliseconds, I believe. Okay, so that's how you can do that. Once you actually change it, so datetime underscore object 1 equals datetime time.datetime. So you basically perform it once again, and you print it once again. You will see that the actual value will be different. As we can see right here, it is now 52 seconds, while as here it was 16 seconds. So you can use this statement right here or this line right here in order to get the current time of the execution of that specific statement right there. Okay? So basically what we did right here, if we imported the datetime module using import datetime statement, one of the classes defined in the datetime module is the datetime class, and then we use the method now to create a datetime object containing the current local date and time. Okay, as we can see right here. And right now, let us see how we can simply just get the current date. So also by using the actual datetime function right here. So we can do that by simply creating another data object. Just right now, we're going to call it date object and not datetime, because we only, for example, want to retrieve the date. We don't care about the current time, especially not in milliseconds. So right here, date object will be equal to simply just datetime library. And we're not going to use the datetime class from this library. We're going to use the date class right now. And then we're going to call it and simply just specify the method today. If we press enter right here, you can see everything went without any error. And now if we print the date object, you can see it will print the current date without its time. Okay, so basically we use the today method from the date class to get the date object containing the current local date. Okay, so simple as that. Now, as we can see right here, one of the commonly used classes in this datetime module are the date class, which we use right here, the time class, which we're going to take a look at later on, the date time class, and the time delta class. So those are the most used actual classes in this actual module. So right now what we're going to take a look at is date object to represent a date. Now what I mean by that is we're simply going to specify 3 digits and then we will turn that object into a date. So right here, if you just specify, let me just close this and reopen it, import datetime once again. And right now, if we want to actually convert some 3 values to the actual date, you can simply just specify, for example, A equals, for example, 2019, B equals, let's see, which date is it today? It is 5th, C equals 27. So this is the 27th of May, 2019. But it really isn't right now. It is only 3 integers. And right now, let's say we want to actually convert it to a date. We can simply just do that by specifying a variable name. So we call it date right now. And we're going to convert it by using the date class from the datetime function. So we're going to just type here datetime dot date. And right here, we specify 3 values, which are going to be A, B, C. Press here enter, and if you print date, you will see that it will actually print the date itself. So it will turn it basically into a date. In case you are wondering, the date in the above example is a constructor of the date class. The constructor takes 3 arguments, the year, the month, and day. Now we can only import the date class from the datetime module. Now we already saw some of the examples of how we can do that. You don't really need to import the entire datetime module. You can simply just import only date module by simply specifying from datetime import date. If you press here enter, it will only import the date class from the datetime module, and therefore you can simply just perform all of this stuff you need from the date class without actually importing everything else as well. So you can simply just go right here, today equals, and without specifying the prefix of date time, you can simply just specify only date, because we only import the date. The date time is not even imported. So date dot today. And what this will do is it will set the current date into the today variable. So we can just print right here, current date equals, and then we can comma today. And you can see right here, it will basically print current date equals and then the today's date. Okay, so simple as that. It is very important that you know that you can import it just like this, because let's say you want to use a lot of functions from the datetime library, and most of them are from the date actual class, and therefore you you really don't want to bother by specifying datetime every time you use something from that class. You can simply only just write date and perform all these tasks as well by simply specifying this line at the beginning. So simple as that. Now, you can also get the date from a timestamp by using the date class from the datetime library. So, as I said, the actual timestamp basically means that it will count the seconds from the 1st January 1970, and then it will convert the date using from timestamp method. So you will see, just in case, let me just show you right here. If you just create timestamp to be equal to date dot from timestamp, and in between the brackets you specify this amount of seconds, so simply just specify something like this, and basically just press here enter. We just check out right here from timestamp. Yeah, we are missing an actual letter. We typed from timestamp, we need R somewhere there, so date dot from timestamp, and in between the brackets you specify the amount of seconds, and if you print the date, and then you add the actual timestamp, you will see that the actual date was 14th of April 1974. Now, if we take the same statement right here, and instead of actually specifying 1, you specify 3 right here, and you print timestamp, you can see it was the 14th of August 1980. So basically you can simply just specify the amount of seconds from timestamp, and it will count those seconds from the 1st January 1970, and it will print you which date was at that certain point. Okay, so basically that would be about it from the from timestamp method. Not really that useful, but something funny to do. Now the next example we have is we can print today's year, month and day one by one. So we saw the example of how we can actually print the date itself, but let's say we want to print everything one by one. So all we have to do is simply just select the today variable to be equal to date.today, which we already did right up here, but we're going to select it once again. So right now, if we just simply just print today, you can see it has the current date, which is correct. But in order to actually print, for example, only a year, only a month, only a day, you can simply just do something like this. So print, open single quotes, current year, and then you can simply just add today.year, simply just by specifying the today object, and then adding the .year, .month, and .day. So let us see how that will work. Then we can add the new line character, then plus current month. We simply add today.month. It is rather simple, so nothing really to explain right here. \n for the new line. And the last thing is the actual current day. So just go right here, type here current day, and then plus today.day. Press here enter. Let me just go right here. Can only concatenate string, not integer to string. What do you mean by that? Okay, so I think I know what they mean. Let me just copy all of this. You can't really add strings and integers, therefore we're going to perform the same print statement, just instead of actually adding this, we will add comma. Let me see if that will work. Comma. Comma. We can leave the pluses between the actual strings, but between the integers we need to type here comma and press here enter, and you will see right here it will print out current year 2019, current month is May, and the current day is 27th. So simple as that. Okay, so it is not really anything too advance. Basically, this is something that you will understand right away. And the next example that we're going to take a look at is the time object to represent time. Basically, we took a look at importing datetime. We also took a look at importing from datetime only the date library. And right now, what we're going to look at is importing time library, or pardon me, time class. So let me just restart the idle. So we have everything prettier. Open it up right here, enlarge it, and simply type here the same statement as from datetime import date. Just right now we're going to import time. So from datetime import time. Press here enter, and it will only import the time class. Therefore, you don't really need to use datetime prefix on everything you do. Okay? Now, you can simply just type here something like a equals time. Now, even though you don't really know what you did right here, if you just type here a equals time, open and close brackets, and don't press enter, you will see what arguments does this time function take. And basically you can set the hours, the minutes, the seconds, the microseconds if you want to. But by default, if you just press here enter, it will all be equal to 0. So basically we set the amount of hours to be equal to 0, amount of minutes, amount of seconds to be equal to 0. And let me just show you right here. If you just print a equals and then comma a, you will see that we actually did set that. So all of the amounts of hours, seconds, seconds and minutes are all set to 0. And right now, if we simply just type here b equals, and we use the same function, but for now, right now we specify 11, 34, and 56, and we simply just print b, you can see that it will print a time. So it is 11 hours, 34 minutes, and 56 seconds. So simple as that. Now, if you want to, you can also add the microseconds. If, for example, if you just type here d equals time, and you specify the same time, so 34, 56, and right afterwards you add some microseconds, press here enter, and you print d, you will see that it will also add the dot 364554, which basically is the microseconds. And then once you print all of that, it will print different times. As we can see, this one hasn't set anything, so it is all set to 0. Once we actually specify the values in this function, we actually set the time. And right here, if we also specify the fourth value, we will also specify the microseconds as well. Okay? And as we saw in the previous actual example, you can select the date by year, month, and minute. And right here, you can also select the time by hour, minute, second, and microsecond. And in order to do that, you can simply just print d.hour, print d.minutes, or minute, print d.second, and print d.microsecond. And you can select specific values of a certain time just by specifying it like this. Okay, so simple as that. Now, you can also use the datetime library to perform the same task. Let me just show you right here. If you just use the from datetime and you import the datetime class, which is a part of the datetime library, you import it just like this. You can simply set the year, month, and day just by specifying the datetime method from the datetime library. Now you can also specify everything in a single line, and by everything I mean the date, the time, the seconds, minutes, month, and so on and so on. Let me just show you how that works. We saw the example of something like this. So a equals date time. And then here we specify 2019, for example, 5th, and then 27. And you can see print A will print this current date, but it will also print next to it the amount of hours. So in order to actually select everything you can simply just type here A equals date time, and we go one by one. So first of all, it is year 2019. Then the next thing we need to specify is the actual month, which is May, labeled as 5. the day is 27, and then the hours can be, for example, 14, the minutes 32, and the seconds 55. You can also select the microseconds if you want to, and you will see right here, if you just print A, it will give you the full amount of time. So you have the date and you also have the time. So this is also something useful you can do. Of course, if you want to, once again, you can select each one of them one by one. So print A dot year, print A dot month, print A dot second, print, how did I go from month to second? Doesn't even matter. You can simply just go print A dot day. You can simply just do anything you want. You can also print A dot timestamp if you want to. So let me just show you right here. And it will print the timestamp from this current actual date from the 1970 or the 1st January of 1970. Okay. So basically that is also something you can take a look at. Now another thing, and basically the next example that we're going to take a look at is the time data from the datetime library. Basically, a time data object represents the differences or the difference between two dates or times. Basically, that is something probably the most useful you can have right here. It will basically subtract two different dates and it will give you the amount of days in between those two dates. So let me just restart this. Go right here, open up my idle, and import from datetime. We're going to import datetime class and also the date class. So basically we're going to import two different classes, which we can do by specifying comma between them. So we specify it just like this. And right now let us select the time one, which we are going to label as T1, to be equal to, and use the date function, and we're going to set the year to be equal to 2019, the month to be equal to 5th, and the day to be equal to 27, which is the current date. Just by pressing enter and printing T1, you can see that the current date is correct. So, okay. Now, let's set the actual T2 to be equal to date function. And let's say we have a plan for something in the future and we want to calculate the amount of days it takes for that to actually come. So we can set the year to be equal to 2022, the month to be equal to 11th, and the day to be equal to 7 or 16, for example. Doesn't even matter. Okay. So we have something planned out on this date right here. And we're wondering, for example, how many days does it take for this date to come? You can simply just specify it right like this. So T3 equals T2 minus T1. And then if you just print T3, you can see it will take exactly 1,269 days until this date is reached. So something around 3.5 years. Okay. Now, you can also do it for a date back. So if you have a current date, which is this date right here, and you have a T4 to be equal to date, and then, for example, 1880, or pardon me, year equals 1818, month equals 7th, and the day equals 2nd, okay? And then you want to print T1, which is the current date, minus that specific date in the past. You can see it passed exactly 73,378 days. Now, of course, if you actually wanted to, you can also add the microseconds, the seconds, minutes, and hours the same way we added it previously. So just by simply specifying a time like this. So T5 equals, let's set the current year to be equal to 2019. Month is once again 5th, and the day is 27th. The hours equal to, let's see, what time is it right now? 10 and 42. So hour or pardon me, hour, not hours, hour equal 10, the minutes or minute equals 43, and the seconds or second equal 11. Okay, you just close this, press here enter. Tree function takes the most, oh, okay, yeah, I see the mistake. It is because we actually use the date function and not the date time. So let us make sure to use the date time. The date function can only take the actual year, month, and day as an input, while as the date time can actually take all 6, including the hour, minute, and second. Okay, so right now, once we specify the date time and press here enter, you can see it will execute without any error. And if you want to, you can simply just print T5 minus T1, and then you can see, let me just check it. Yeah, you can't really print that because this one is a part of the date library or date class, which doesn't really have seconds, microseconds, and so on. But you can simply just add the T6 to be equal to date time, and we simply add an actual time in the future, 2025, which is the year. Month will be equal to 11th. Day will be equal to 1st. Hour will be equal to 3 hours in the morning. Minute will be equal to 44. And second will be equal to 0 or 9. Doesn't even matter. And you simply just want to print the differences between these two times. You can simply just type here T6 minus T5. And you can see it will be around 2,349 days and 17 hours and 58 seconds. So simple as that. Okay. So that is also something to take a look at. Now, there is also another way you can do that, or basically another way you can print the differences between two objects by using the time delta. So just like this, let me just show you. If I just restart this, open up my idle, we import the actual time delta right now. So from date time, import time delta. Okay, and then you want to set the time delta to also have weeks and not only month, days, and years. So basically you can do that just by simply specifying T1 to be equal to time delta, and you can set the weeks to be equal to 3, days to be equal to 5, hours to be equal to 3, seconds to be equal to 33. If you just print T1, you can see right here we have 26 days, 3 hours and 33 seconds. Now, if you want to actually, for example, also calculate some time or differences between some times, you can simply just add T2 to be equal to time delta. And right here, let's have only days. So for example, days equal 4, hours equal 11. So you will notice right here that we don't have weeks in both of them. So this one doesn't have weeks and this one does have weeks. And also this one, we will add minutes to it, while as this one only has seconds and hours and we didn't add any minutes. So days equal 4, hours equal 11, minutes equal 5, for example, and seconds equal 60. Or, pardon me, we can do 60, we can do 58. Press here enter. If you just print T2, you can see it is 4 days, 11 hours, 5 minutes, and 58 seconds. And you can simply just print T2 minus T1, or pardon me, T1 minus T2. And the difference is 21 days, 15 hours, 54 minutes, and 35 seconds. So this is also a useful function from the datetime library. But you can also, if you want to, print the negative time delta objects by simply specifying something in reverse. So for example, T2 minus T1 will give you the amount of minus 22 days because actually it is the T1 is bigger amount of time. Therefore, once you subtract these two, you actually get minus 22 days, 8 hours, 5 minutes, and 25 seconds. Okay? Now, the last thing that we're going to take a look at is example of turning the time duration in seconds. So we're also going to use the time delta from the datetime library in order to perform that. So you can simply do it just by specifying something like this. So T equals, This is going to be our universal time, so time delta. And let's set, for example, the duration of days equal 5, hours equal 1, seconds equal 33, microseconds equal 233,423. For example, doesn't even matter. And let's say you want to turn all of this time into seconds. So you don't want to print simply, if you just print t right here, you don't want to have 5 days, 1 hour, 0 minutes, 33 seconds, and this much microseconds. You want to turn all of this into seconds, and you want to see how much seconds does this last. You can simply do that just by specifying print t plus, or we can do plus, so t dot, comma, and then open single quotes, is equal to, and then we are going to comma, t dot total underscore seconds, which is a function from the datetime library, which we can use in order to transform everything into seconds. And then we're going to simply just add seconds. Okay. And if you print this, you can see 5 days, 1 hour, 33 seconds, and this much microseconds is equal to this much seconds. So that is also something useful you can do, basically in your calculations or wherever you want to use it, doesn't even matter. It is something that you can do. Okay. So basically that would be about it for this tutorial, and we're going to continue in the next lecture and basically finish with this format, with this date and time libraries. Okay, so hope you enjoyed this, and I hope I will see you in the next lecture. Bye! Hello everybody, and welcome back to our datetime library explanation. So what we did in the previous video is we took a simple look at basically multiple ways of actually interpreting the actual date and time, also by selecting a certain part of a date and time, such as hours, minutes, seconds, microseconds. We also saw the conversion of the time to seconds. We also saw how we can actually subtract a time from a time in order to get the amount of days that has passed between those two values of time. And right now, we're going to take a look at the Python format date time. Now, the way date and time is represented may be different in different places, organizations. It's more common to use the first month and then day and then year in the US, where the actual day, month, and then year is more common in the Europe. In order for us to actually convert that, Python has two functions, which is the string from time and strip time. Basically, those are methods from the datetime library that allow us to do this. So we're first of all going to take a look at the string from time, or basically strf time, which is in the datetime library. It will turn the datetime object into a string. So let us open up our idle. Now the reason why we are doing so much of this date and time is because it is really important for you to understand this, even though you might not really use it afterwards. But basically, if you don't think that you will need this much of date and time conversion, manipulation, seconds, minutes, hours, microseconds, and so on, feel free to skip this section. Basically, it might, if you really do think that you will not need it. But for those of you that actually do these kind of tasks, such as automatization, such as calculating what has to be done at certain time, you will enjoy this actual time demonstration, and you will also use it later on a lot. So right now, let us see how we can actually convert the datetime object into a string. So first of all, we need to import the datetime. So from datetime, we're going to import datetime, so we don't actually write the datetime twice. And then we're going to select what we did in the previous video, which is the current date and time, which you can do simply just specifying now equals, and then calling the datetime class and the method now from that class. If you just print now, you will see that it will be equal to this current time. Okay? And right now, let's say we actually want to convert this into a string. So we can do something like this. T equals now dot string from time. And in order to convert it, you simply need to specify percent capital H for hours, then 2 dots, percent capital M for months, or pardon me, not for months, for minutes, and then percent capital S for seconds, and that all has to be divided by these 2 dots or by a comma. Okay, and then if you print T, you can see it will print out only the current time in hours, minutes, and seconds. If you want to, for example, print also days, months, and years, you can simply just type here T1 equals now.string from time. Use the smaller percent M for the month, then slash percent T for the day, and slash percent capital Y for the year, then comma, and then we can simply just copy this so we don't type it once again. This will just actually, if we print it out, you will see it will print the same amount of time, just right now it will be a string. And we also converted the actual date right now, which was the 29th, and then 5th, and then 27th, which is stored in this order. We converted it to be in this order. Okay, so we successfully converted it to be equal to the 5th May 1st, 27th of May 2nd, and then 2019 as year to be the last. Okay, in order to actually just flip these two, if you want to have the actual number of days first, so 27th of May 2019, you can simply just copy this. There is not really much we will change right here, except for right here will be M, and right here will be days, as well as this will be T2. And if you just print T2, you will get the desired output of the date. As we can see, 27th of May 2019 is the output of the actual date right now. Okay, so those are the ways you can actually manipulate in order to check the format of a date. Now, we know that the %y, %m, %d, %h are format codes. The string from time method takes one or more format codes and returns unformatted string based on it. So we can see that the %y equals for year, the %m is for month, the %d is for day, the %h is for hour, the %m is for month, and the %s is for second. Now, don't confuse the %d with the integer. Now, this will only work as a day inside this function right here. If you use %d without this function, you will get outputted an integer and then this will not work. So make sure that you know that this %d is referring to a day inside this string from time function, okay? And right now, let us take a look at the Python strip time function, or string to date time. Basically what this strip time method creates is a datetime object from a given string. It is representing date and time at the same basically time. So right here what we're going to do is we're going to create a date string, which we can write something like this. So we can be 27th May 2019. So this is a simple string. We can print it if we want to, just to make sure. As we can see right here, 27th May 2019. And let's see how we can actually convert this to a date time object. So we have a date string, and right now we want to create a date object to be equal to date time, and we use the function strip time or strp time, and in between the brackets we need to specify two things. We need to specify the string that we want to actually convert, and we also need to specify the format for that string that we are converting. So first of all, we are converting the date string, and then comma, and right here we need to specify the format, which is going to be %d for days, then %b, which is basically for the months, just in the actual letters, and you will see just, or pardon me, not in the actual letters, just converting it from the letters to the actual month. That's why we are using %b, and then %y. %y for the actual year. Oops. time data does not match format. Yeah, okay, we need to actually switch this up. Let me just, or do we actually? It doesn't match this format. What do you mean? Yeah, we have an extra comma. Doesn't even matter. Let us delete this. Press here enter. You can see right now we no longer have error. The reason we got error is because of this comma right here, which is not to be found in this actual date string. And right now, if you simply just print date object, it will print out the date object of time. So basically 2019, 5th of May, 27th of May, and the hours, seconds, and minutes are not really set at the moment. So we converted the actual string to the actual datetime object, and we also converted it by the actual format that we need. So that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And what we did in the previous section is we took a look at a module, basically a time and date module, and we took a look at some of the different functions that allow us to manipulate with time and date, as well as calculate different time, calculate date between two different dates, how many time has passed, as well as converting the date into the appropriate look, such as, for example, the European time, the USA time, and, pardon me, the USA date format, and so on and so on. We also saw how we can actually split them into different categories, such as, for example, months, days, years, as well as seconds, hours, and minutes. We also took a look at the microseconds, and basically we converted all of that into strings in order to be able to print that. So we took a look at different functions, and right now what we're going to do is we're going to take a look at the module called regex. Now basically that module, we can import it with a simple re command, so import re, that is the name of the library. And basically what that is a regex, or regular expression, is a sequence of characters that forms a search pattern. Now, for example, let's say you have a huge file, and in that file, what you want to actually get from is a bunch of emails. So there is a bunch of emails in that file, as well as, for example, phone numbers, and you only want to extract emails. So basically, regex library allows us to do that just by specifying a simple pattern, and we're going to take a look at how we can do that. Basically, regex can be used to check if a string contains the specific search pattern. Python has an inbuilt package called re, as I said, which can be used to work with regular expressions. So let us see first of all how we can actually import regex. So open up your idle. Go right here, let me enlarge this, and as I said before, in order to actually import regex, we simply need to type import re, and that is an inbuilt Python library. We don't really need to install it, it will already be there. So right now let us look at the example of creating regex object for, let's say, for a mobile phone number. Now there is a different syntax for this regex. Now you can take a look at the table, or basically the table of characters using or to represent different types of characters, such as, for example, right now we're going to use \d, which is used to represent a number character, or basically just a number. You can take a look at that table of representation different characters online. Basically just type regex table, and you can go to the official Python website in order to check the regex syntax as well. But right now we're going to, as I said, take a look at the extraction of the phone numbers. So make sure to remember that \d is an actual number representation. So right here we will use compile function, which will return everything that matches our pattern specified. Now that compile function belongs to the re library. So right now what we're going to do is we're going to type simply phone number, which is going to be our variable that is going to store the actual number, and we're going to perform the compile function onto that variable. So right here, phone number equals, or pardon me, not going to store this variable right here is not going to store the phone number, it is going to store the pattern, and then we are going to make a string that is going to contain a phone number, and we will see whether this pattern of a phone number can find it. So right here, as I said, we're going to use the compile function, but before we actually use it, we need a prefix of re, because it belongs to that library. And how this compile function works is basically in between the brackets right here. We need to specify letter R, which basically represents that we are going to make a regular expression right now. And in between the quotes, we need to specify the actual regular expression. So before we actually do that, let us see Notepad. We know that the actual format of a number, let's say it is something like this, 555-555-5555. So this is a format of a phone number, and right now we need to make sure that we specify it correctly so our regex library can find it, or regex pattern, as well as we already know that the \d represents a number. So the easy way that we can actually write this would be something like this. So \d, which is going to present the first 3 digits, then we will specify dash, and then once again \d represents the second 3 digits, and right now we need to add another dash and then specify 4 digits, which is going to be represented as 4 \d. So \d, \d, and basically this is our regex pattern. If you just click here enter, you will see there will be no error, and all we will have to do right now is to actually make our own string that is going to contain this phone number. So for example, let's say string equals, and let's define it like this: my phone number is 111-222-3333, and then dot at the end. So this is our string, and we are going to try to find this phone number with this pattern. So let us go right here. The function that we are going to use to perform that action is going to be the search function. Basically what search function does is it will look through the specified string and see whether it can find a match with the regex object that we created right here, which is named phone number. So we need to combine these two in order to perform this task. So right now what we're going to do is we're going to type match equals, so we're going to store our match in a match variable. So match equals phone number, which is our regex object, and then we need to add the search function to that regex object, as well as specify the actual string that we are searching from in between the brackets. So right here we're going to specify string. Basically what this does is it will call a search function to this regex object, which is going to perform the search onto this string. Now this doesn't have to be string, you can also read from a file, which we're going to take a look at in just a moment, but for now on this will be more than enough. Let us press here enter, and if you just simply type here match, you will see that you will get match object and then some information right here, as well as the match right here. So we can see match equals 111-222-333. And if you, for example, only want to print this, so you don't want to actually print all of this, you can simply just type here something like this. So print, and we will use a group function that is also a part of the regex library, and the group function will return the matching object if it is found. So right here we're going to type it like this, so open single quotes to print a string, found a phone number, then we can specify 2 dots, and we can concat to it match.group. As I said, the group function once again will return a match if it is found. So right here you will see that if I print that, it will print found a phone number 111-222-3333. Okay, so we successfully did find a match. If you want to, you can simply just read from a file as well, or you can use a multi-line string. For example, if we have string 1 equals, and then open 3 single and 3 closed quotes, and type here in this string we have a phone number which is 333-333-3333. And we have another phone number Oops, let me just write this properly. So, and we have another phone number, which is, and right now let us specify a wrong one. So for example, 4444-444-4444, and then close 3 single quotes. And if we perform the same search onto this string 1, it will only find this object right here, or this pattern, or pardon me, this phone number right here. So let us check that out. Match2 equals, and then we want to perform the same thing that we did right here. We're going to use the same regex object, or regular expression object, that we coded at the beginning, and we're going to use a search function onto it and specify the string 1. Then if we want to print the actual match, we just type here match2.group, and you will see it will only print out 333-3333-3333. I think I said way too many 3's right there, but doesn't even matter. Now, also one more thing to take a note of is that even if we actually specify this to be a correct syntax for a number, or to match this pattern up here, this will still not find this second phone number. That is because we are using the search function, or pardon me, the search function, which will only find the first match it finds. Basically, if there are multiple matches, the search function will not find it. And we're going to take a look at how we can actually find all of the matches in a string later on. But for now on, let us see another example of, let's say, how to extract emails from a large document. Now, of course, we don't have a large document right here, but what we can do is we can open our notepad file, and we can simply just type here, for example, here is a list of emails, and then let's say aaa@gmail.com, bbb@yahoo.com, and cccc at, for example, com.com. Doesn't even matter, you can make something up, and then you can just type some gibberish right here, which doesn't make any sense. You can also try to manipulate with different actual email syntax, such as, for example, ccc@com.com. It shouldn't really find this one because it is incorrect. And then you can add something else right here. Then we will save this onto the desktop right here, emails.txt. So we save this, and right now let us create a program that will read from this actual file. Okay, so open up your new file right here. Let us save it right away onto our desktop. Make sure to save it the same path that you saved your emails.txt. And right here we're going to name it, for example, email extract.py. Okay, so we named it. If we go right here, you can see that right here is our email extract file as well as our emails file. Okay, now let us code it right here. So what we need to do is, first of all, we need to import RE, and then we need to open and read from our emails.txt file. So we can do that with simply file equals open, and we want to open emails.txt. We want to open it for reading. We can specify RT for reading text if you want to, or you can simply just type here R, doesn't even matter. What matters is that we need to store the actual emails or the documents into a certain variable. So right here we will just specify file_text equals file.read. Okay, then for example, all we have to do right now is actually match with a specific object. Now right here, this might actually be a little bit harder syntax than before. Of course, you will see it right here. So let me just show you. If you just type here match equals RE and then find all, and what find all function basically does is it is the function that will search multiple matches and not just one. Basically, our search function that we used in the previous example, what it does, let me just enlarge this. What it does is it basically, oops, right here, so we can see both of the screens. what this function right here does is it basically searches for the first match. Now it will disregard the second match or third match, or basically if it finds multiple matches, it will only store one. While as the find all function will go through the entire string and see all the matches that match the current specified pattern. Okay? Therefore, we're going to use our e.findAll in order to find all of the emails, which then will be returned in a list. Okay, so right here, all we have to specify in between the brackets is the match itself, which we will specify by beginning with the R. Then in between these single quotes, we'll specify the actual pattern. Now I will just write it right here. Give me just a second. So the square brackets is what we use. Then we specify the backslash. Then we use the W, comma, or pardon me, dot, dash, close square brackets, add a plus, and then we'll specify the @ symbol that is going to be in the email, then open and close square brackets, and then backslash W, backslash dot minus. And at the end, all we need to specify is a plus, and that is our search pattern. Now I know it might look a little bit too harsh, but make sure that you read all of the syntax for regex online, on the official Python pages if you want to, and then you will understand this on a whole nother level. Now, it is very important that you do understand regex because it is used in any field of Python programming. Basically, it is really useful, especially in data extraction, which is an example of what we are doing right now. And enough about that. We'll talk about that later on. What we need to specify at the end of this is comma and then what we want to read from. So we want to read from the file underscore text. Okay. And basically all we want to do afterwards is print the match. Let us save this. Save. Then run it. And you will see that we actually get retrieved all of the emails that we specified. Now, you will notice right here that it actually did find this email, but only a certain part of it. That is because this actual pattern right here works by finding the actual @ symbol and then adding the strings from the left and to the right of that @ symbol, specifying the entire email address, as we can see right here. Okay? Therefore, it did find but only half of this email address. Let me just open the actual file. Here it is, as we can see right here. These are our actual correct emails, and this is our wrongly specified email. Because of this second @ symbol, it didn't manage to actually find the entire email. But don't worry, you will not encounter this kind of email because it doesn't exist. You will not notice if I just delete this, save it, and then run the program once again. Right now, it found all 4 emails with the specification of this com.com that we didn't have in the previous example. Okay? So that is also something to take a look at. Basically, what the actual... let me just close all of this. What the actual plan of using regex is always the same. Basically, there are 4 steps that you need to follow, which is basically just specifying the string where you want to search from, the compilation, and then searching, and then printing basically the matching object. So the regular expression syntax can be a little bit tricky, but as I said before, you can take a look at the regex tables and correct syntax online. So let us go over the standard procedure of using regex once again. So step 1 is to, first of all, import regex, of course. Don't forget to do that. Step 2 is to create regex object with the re.compile function, which we did right here. This step, that is step 2. The step 3 is to use a search to pass a string to search from. So this is right here, the search function. We pass the string to search from, and then the 4th step is to call the group function to see the matches. Now the actual steps in our program that extracts emails is a little bit different, but we're going to see more of the examples of that later on. Okay? Now, you can also group different elements if you want to by putting them in brackets. And what I mean by that, let us take a look at the example. So what I will do is I will restart the actual idle, we're going to take a look at the example of a phone number once again, and how we can group different digits of that phone number using regex. So for example, import RE first of all. Then what we're going to do is we're going to type right here phone number equals, and then we're going to specify the re.compile function, but in between the brackets we're not going to do the same thing as before, just by simply specifying the \d, and right here we're going to simply specify in between the single quotes, we're going to specify open and close brackets, and then once again open and close brackets. And in between those open and close brackets, specify dash. In the first one, you specify \d, \d, and in the second one, you can specify \d, dash, \d, okay? So what we did right here is we actually created the same actual syntax for the previous example, but right here, we actually divided them into different elements. So right here, if I just press here enter, and we perform the same search function as before, so match equals phone number dot search, and in between the brackets let us specify a simple string, and the string can be, for example, his phone number is 444-333-55555, okay, and then dot, press here enter, and right now we can print different groups just by specifying the element we want in between the brackets. So for example, if I just type here match.group, and in between the brackets I specify 1, you will see it will print the first part, which we divided right here. As you can see, the first part is going to be the syntax stored in the first brackets, and the second part is going to be the syntax stored in the second brackets. So if I just type here match.group and specify 2 in between the brackets, you will see we get printed out the rest of the phone number. So you can divide it by your own needs. And of course, if you, for example, want to print the entire number, you can simply just specify match.group as in the previous actual example. And you can also specify match.group and specify the 0 in between the brackets. It will get the same output. Basically, it will print the entire match. Okay? Now, why you might actually need to use this is, for example, you want to split the phone number by the vendor code or the area code and by the phone number. So, for example, you have a phone number that's something like this, 065-999-9 and then 999. So this will be the phone number, and this is going to be the 3-digit number that will actually correspond to the different area code or vendor code or basically something like that. And maybe you want to split that. You could simply do that just by specifying, for example, vendor code, comma, phone number is going to be equal to match.groups. And what this groups function is basically groups function will split them into different variables. Okay? As you can see, vendor code would be variable 1 and the phone number will be variable 2. And that is how you can simply just split them by your own needs. So basically that would be about it for this simple tutorial. We took a look at different functions such as the compile function, the search function, the group function, and the groups function. We also saw how we can actually read different files, read different files and read from them and extract what we need with our regex pattern, such as, for example, we were able to extract different emails from the pattern itself. And what we're going to do in the next video is we're going to take a look at some of the more examples of using regex, so make sure to stick for that. Hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial, and right now we're going to continue with our regular expressions. Now what we did in the previous video is we took a simple look at some of the regular expressions to extract phone numbers, emails, and right now we're going to see our different available options using regex. So open up your idle right here. Make sure to enlarge it. or I should make sure to enlarge it so you can see everything better. And right now we're going to take a look at some of the different characters that we can use in regex. So for example, using this character, which is the upper vertical line, what we can do is we can use it to find one of two specified matches. Now what I mean by that is it will put first thing it finds as a match and not the second thing. Such as, for example, if we have a regex world, first of all, we need to import re. And if we have a regex that is, for example, equal to re.compile, and what we're searching for in this regex is, let's say, one of the two words. So, for example, we have, first of all, specify r for the regular expression, and in between the single quotes, let's say we're searching for two words. One of them is hello, and the second one is world. Now, in order to specify to regex that it should search for one of these two words, you need to specify the vertical line between them. So, as I said, it will put first thing it finds as a match and not the second thing. So, for example, let's press here enter, and this is our regular expression object, and right now I will show you what I mean by the previous thing I said. So, string equals, and in between the brackets, let's say we specify the sentence hello world. Now, what do you think that will actually happen right here? Well, it will put as a match the first thing that it will find, as I said before, so it will be hello in this case. Let me show you right here. If we just type here first underscore match equals, and then I specify regex.search, which is a function that we covered in the previous videos, so you should already be familiar with it. And then in between the brackets, I specify string. If I want to print this match, I can simply just type first underscore match.group in order to print it out, and you will see that it will only find hello. It will not put a match of hello world in it. But if we want to, for example, reverse this in a different order, you can simply just type here string 1 to be equal, and then we will use the same actual string, just we will reverse the actual word. So we will type here world hello, and we're going to perform the same search onto the actual regex object by specifying the second match, and you will see that right now we will have the world as a result, because it is the first word that it actually encounters that actually match this pattern right here. Okay, so second match equals regex.search, and we want to search from the string 1. And right here, if we simply just print the second match by specifying the group function, string, yeah, it's not string.match, it is second underscore match.group, and you will see that right now the match will be equal to world. Okay, so now let's take a look at the optional matching with the help of a question mark. Now, the question mark is another character that you can use to represent the, as I said, optional matching. And what I mean by that is that the question mark represents the group that should optionally be found if it is in a sentence. Now, for example, let us take a look at this example right here. So our underscore regex, we're going to use, or we're going to call it like that. That's going to be our regex object, so equals to re.compile. And let's say we want to search for word basketball, for example. So let's specify the R right here, open single quotes, and specify basketball. Now, let us implement the question mark right here. And in order to implement it, we need to implement it in front of the actual characters that we want to put in the brackets. Now you might be asking, what am I talking about? I will show you just in a case. Let's say we put these three letters in brackets. Now this can be anything you want, it doesn't have to be these three letters, I'm just showing you an example. And after this bracket you specify the question mark. Let me just find it on my keyboard. Okay, so here it is. And what this will do is it will try to find both of these things in a sentence, whether the word is basketball or whether the word is basketball. Now it will find both of those words. That's the implementation of the question mark. Basically, it means that this part of the word is optional. So it doesn't have to be in it, but if it is in it, it will also put it as a match. So let me show you right here. If I just press here enter, and we specify, for example, string 1 equals to, let's say, they are playing basketball. Now, basketball is not really a word, but we're going to use it just to test out our regex object. And in order to match with this, we can simply just type here match1 equals, and then we will use our regex object. So our underscore regex dot search, and we're going to search from the string 1. If I just press here enter and try to print the match.group, you will see that we will find the word basketball. But if we have a string 2, for example, that says they are playing basketball, and we have a match2 that is going to be equal to our underscore regex object dot search, and we search from the string 2, and we once again print this actual object or this actual match right here, you will see that it will also find basketball. So once again, this exclamation mark right, this question mark right here represents, or it is put in front of the actual optional line that should be found in a match, but it doesn't have to be in it, if you understand what I'm saying. So what we are going to do right now is we can take a look at the example of this with a phone number. So let's say user of program doesn't want to enter the code that represents the area code or the vendor code of a phone number. We can handle it like this. So for example, let me just restart this. So we have new open and clean idle right here. I will import RE. And let's say we have a phone underscore number, which is going to be once again our regular expression object. It is going to be equal to re.compile R, and then in between the single quotes, we are going to use the question mark to actually put the first 3 digits as optional. So we can do that just by simply opening up brackets, specifying backslash d backslash d, which we know by now that it represents digits. And we also need to specify the dash right here, and you will see in just a second why. And after this open and close brackets, we specify the question mark. So it means that all of this before it will be optional. Then afterwards, we specify backslash d for the second 3 numbers, and then dash, and then once again we specify backslash d 4 times. So backslash d, and this is going to be our pattern. Now before we begin, let us go over this one more time. So we specify the R for the regular expression, we open and close single quotes, and there we specify in between the brackets the backslash d dash. So if we have a phone number that is something like this, 065-555-5555, we consider this part as a vendor code, but we also need to use this dash with it in case the user only specifies this as a phone number. We don't really want to leave this dash in it, because then it would be incorrect. So we want to also use this as a part of the optional phone number, okay? Because otherwise it will not find the phone number. So let us delete this. And right now what we are going to do is we are going to perform the search for a phone number. So match1 is going to be equal to phone underscore number dot search. And let's say in between the brackets, we specify a string that says my number is, and let's try with the, first of all, with the vendor code. So 065 or 4, doesn't even matter, 065-555-5555. Okay, then we can add dot as the end of the sentence, press here enter, and if we try to print this, so match1.group, open and close bracket, you will see that it will find the entire phone number. But if, for example, for some reason the user only specifies the actual phone number without the area or the vendor code, it will also find that one as well. So phone underscore number dot search, and here we specify, here we specify the same sentence but without the area code. So my number is 555-5555. Press here enter, and if we try to print it, you will see it will find that one as well. So it does find matches. Now you can also use the find all function that we took a look at before to find both of the phone numbers, even though if they are different. So for example, match 3 is going to be equal to phone underscore number dot find all in this sentence right here. So right here we have, I have two phone numbers, 065-555-5555 and 444-4444. Press here enter, and match 3, if we just simply print it, let me just check. Oh yeah, it will not work right here. Yeah, because it will only try to find this right here. So let me just try it like this, if I just copy this. But I don't think that will change anything if we just simply add it right here. Add the regular expression right after it. Let's see if this will work. String object cannot be interpreted as integer. Yeah, let's go like this. Okay, never mind. I didn't copy everything, doesn't even matter. We're going to take a look at the find all in just a second, but before we do that, let us take a look at the curly brackets or big brackets usage in the actual regex. So what we did is we took a look at the question mark, what it means. We also took a look at the vertical line, which basically chooses between two different matches, whichever it finds first. And right now let's take a look at the big brackets. Now, it is used once you want to search for a string that is written more than once. For example, if you were searching for hello, 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 written in the actual string, you can do it by simply specifying the 3 in between the actual brackets, which are those big brackets, which I'm going to show you right now. So let us take a look at that. For example, let's say we have a string that equals hello, hello, hello. There. Okay, so simple as that. And our regex actual object will be something like this. Okay, so re or regex equals re.compile. Here we specify it just like this. So open these big brackets, specify the word in it that is going to be repeated. In our case, the word is going to be hello. And right after it, once you close the big brackets, open them again and specify 3. Okay? Simply just specifying this, it means that it is going to search for a string that has this word printed out 3 times, one after each other. So for example, right now, if we want to check for the match, we can simply just type here match equals and then regex.search, and we want to search from this string. Then if we just type here match.group, you will see let me just check it out right here. Yeah, for some reason it doesn't seem to actually find the match. Maybe I'm doing something wrong right here. Now, of course, I don't really know all of the syntax by myself. I usually search it up. But let us check it out right here if we can actually fix it. Let's say we have a string that only says hello, hello, hello. Maybe that is the problem. We have our regex right here, which should be correct, and then we'll perform the actual search once again. Match doesn't seem to actually find the match. Okay, doesn't even matter, but this is the actual syntax for finding those kind of words. Now for some reason it doesn't really want to work right now. Maybe I'm doing something wrong, but nonetheless this is the actual syntax for specifying multiple words repeated one by one. Now let's actually take a look at something that I know will work for sure, such as the actual find all function. Now we mentioned it before, but unlike search function, this function will return the actual all matches that it finds in the given string. So right now let us take a look at it once again. Let's say, yeah, let's close it. I will reopen it because we have written too many stuff, so we don't actually confuse ourselves with the previous lines. Let us type here import RE in order to import regex, and let us use the example of the phone number because that one is the most simple to remember. Phone equals re.compile, and there we will specify the phone number format, such as, for example, \d. Okay, so we specified the phone number format, and right now, if we take a look at the previous example we did, if we take an actual look at the search function in this case, it will only find the first phone number in the actual string. So let us go over that real quick. Match equals, and then phone.search. We use phone.search because this is our regex object. And then in between the brackets, we will specify a string. And let's say it says I have two phone numbers or two numbers, 555-555-5555 and 444-444-4444. Simply by typing match.group, you will notice that it will only find the first phone number. But if you use the all matches, so all underscore matches equals phone.findAll, and you specify the same string, I will copy it so I don't actually write it twice. And then you want to print the for all matches, you will see that it will return a list of all the matches it found in the given actual string. So that is really important to remember. It is one of the most usable things in this regex library, this find all function, and this is something that you will use the most. Now, let's take a look at the creating your own set of characters in regex. For example, sometimes specifying the pattern can be a little bit too long, so Python has an option to specify for which characters are you searching for in a string. So let us take a look at that right now. Let's say you want to know, for example, how many vowels are there in a string and which they are. So you want to return an actual list of all the vowels it found in a given string. You can simply do that just by specifying the regex object like this. So vowel regex, let us call it just like that, equals re.compile. And there, in between the brackets, we're going to give it a regex object, which is going to look something like this. So open and close single quotes, and open and close square brackets. And in between the square brackets, we're going to specify all the characters that we are searching for in a string. So we want to specify all the vowels. So like here, we'll just type A, E, I, O, U. And then we also need to specify the same letters in capitals. So we actually find the capital letters as well. So let us specify them. A, E, I, O, U, then, or U, or however you want to pronounce it, U or U, and then press here enter, and basically all you want to do is specify the string from which you are searching for. So string will be equal to, let's say, today is a really nice, and just so we can check whether the capital letters work as well, we'll specify the A with the capital A, and then we'll press here enter, and we're going to perform the find all function with our regex object. So vowel regex.findAll, and there we'll specify string, and you will see that our regex object and our find all function will return the actual list containing all the vowels in the given sentence. Now, you can also specify a range instead of the characters, such as, for example, if you specify, let's say, different regex equals re.compile, and there we specify in between the square brackets, we specify something like this. So A to Z, lower letters, then capital A to Z, and then 0 through 9, which is basically, this means that we actually are searching for any letter and any number in this sentence itself. And you will notice right here, if I just type different regex.findAll from the same string as before, you will see that it will actually find the entire string, just it will return it in a list which elements are going to be the string characters, as we can see right here. Today is a really nice day with capital A as well. So this syntax right here will return every character and every letter, and every number there is. Such as, for example, you can also specify, instead of A to Z, you can specify A through C. It doesn't have to be the entire alphabet. You can specify something like this, and that will work as well. Okay? Now, if you want to check for Python regex online, you can take a look at the website https and then pytex.org. And I will show you right now. If you just open this up, go to pytex.org. This website right here is basically, there isn't really much to it. What you have right here is basically two prompts right here to import the regular expression and to also import the test string. And just to make sure that it works, let us import our regular expression, which is going to be this one, without R, I believe. We'll check it out. Paste it right here, and then also paste the sentence, and it should return all the vowels in this sentence. Copy our test string, and then regular, let me see where the actual matches are. Let's go like this, because apparently we need to specify the actual R. Let me just see how this works. Haven't really... Okay, so here it is. It for some reason didn't want to find it before, but right now it does find it. As we can see, it found all the actual vowels in this sentence. So this is a website you can use in order to practice your regex. There are some other options right here that we're going to take a look at later on, but for now this will be more than enough. Okay, so I just wanted to show you that you have this website to use if you want to, and that would be about it for this tutorial. I hope you enjoyed it, and we're going to continue coding and learning regex in the next tutorial. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And right now, let us continue with the regex characters. So what we're going to take a look at right now is the upper arrow characters and $sign characters in regex. So open up your idle once again. Idle. Let me enlarge this. Import RE as usual. And right now, let us first of all say what those characters are. Basically, the upper arrow character, which is this one. As you can see, I'm not really sure how to call it, but this character, find it on your keyboard. What it represents is, it is basically placed at the beginning of regular expression, and it means that it will search for the pattern at the beginning of string. So let us take a look at the example of that. If we just simply specify our underscore regex equals re.compile, and in between the brackets we will specify first of all R right here, then in between the single quotes you use the upper arrow and then specify hello. For example, press here enter, and what this means is it will search for the hello at the beginning of the actual string. So if you just type here our underscore regex dot search and you use hello world, you will see that it will find the actual object and it will match it with hello, as we can see right here. But if you try to search for the actual regex object in this string, which is going to be world hello, which still has the hello world, you will notice that it will not find any actual match with this string right here, because the hello world is, or pardon me, the hello word is not located at the beginning of the string. So same with the $, just the $sign represents pattern at the end of the specified string. So let's say we have a regex object called ends with equals re.compile, and what we are searching for is the regular expression that ends with a digit. So we can simply just specify \d, which stands for a number, and then we'll specify the $sign after it to let the regex, or to let the Python know that we are searching for an actual number at the end of a string. So press here enter, and let's search for it. Ends with .search. Specify the string right here. The number of apples on table is 4. Press here enter, and you will see we found a match 4. But if we use the same sentence, ends with .search, the number of apples on table is 4, and then you add a dot right here, you'll notice that it will not find any match, because this actual sentence doesn't end with a digit, it ends with a dot. So that is something also useful to do. Now you can also combine the upper arrow and $sign to specify to regex that the entire specified string should be equal to pattern. Okay, so that's also something you can take a look at. We're not going to do that right now, but you can do it if you want to. Another thing in regex is the dot character, which represents the, basically it represents exchange characters, or basically it can be any character. Now what I mean by that is I will show you right here. Wherever you place dot in the regex actual expression, it can be replaced by any other character in a string. Okay, so if you have our _regex equals re.compile, and there we have regex object that looks something like this, or regular expression that looks something like this, .ad. What this means is it will search for any word that has any character right here and ends with .ad. So let me show you. If I press here enter, and I go right here and type here our _regex dot find all, and in between the brackets we specify some words that end with ad. So bad, sad, dad, glad, mad, head. Press here enter, and you will see that it found all of them, as we can see right here. But you will notice that this glad word right here only added, or basically only sent to the actual list this lad string, because this is the only actual word that has 4 letters. Therefore it will only match the letter that represents the dot. As you can see, our regex object is basically, let me find it, dot and then ad. So it will only match with 3-letter words, and also it will match with the 3rd character, or from back, and then the ad. As we can see right here, all the other words matched correctly. Okay. Now, there are also some of the other functions that we should take a look at in the actual regex. For example, the re.split method splits the string where there is a match and returns a list of strings where the splits occurred. Okay, so for example, let us use the split function in order to test this. I will close it and restart my idle. Okay, import re. And let's say we have a string that looks something like this. So string equals, and then we will specify 12 written with the actual words, then 2 dots or colon, and then 12 written by numbers, and then we will also have 89 colon, and then 89 written by numbers, and then dot at the end. So our pattern is going to be \d and then plus, which basically stands that we are searching for multiple numbers or multiple digits. Let's type pattern right here. Pattern equals \d plus. This is our actual pattern for regex, and all we have to do is use our split function in order to print the result. As we can see, the result equals re.split, and we want to split it by the actual letters. You will see right here pattern, if we specify the pattern, and then the string, and we print result, you will see how the result will look like. Let me just see right here, why didn't it split it by comma? 12, and then this, 89. We use the \d. Yeah, that's because we didn't use \d, we actually used the front slash, or however you call it, simply just slash. We need to use \d. And then we can perform same thing right here. And you will see it will right now split it with a comma and add it into a list. Okay, press here enter, print the result. You will see right now we have everything we need. So it split it by the numbers, and then it basically removed those numbers and added only the strings into the actual list itself. As we can see, we have 12, we have 89, as well as with the column, and we also have the dot that we specified at the end. Now, if the pattern is not found, the array.split will return a list containing an empty string. Now, you can also pass the max split argument to the rsplit method. It is the maximum number of splits that will occur. So basically, the split function will split it by the desired pattern. Okay? Now, let us take a look at the usage of that max split. So we'll have the same string right here. We're going to use it. Just let's say we add another number. Copy this, paste it right here. And after the 89, let's say we have 9. Okay? Just like this. We have the pattern which is going to be the same pattern. \d plus. And then we're going to have the actual max split to be equal to 1, which is going to mean that it should only split once at first occurrence. So split only at the first occurrence, and the result will be equal to re.split pattern, comma string, and then comma 1. And this 1 is going to be the max split representation, which, as I said, it means that it will only split at the first occurrence, as we can see right here. If I just press here enter, and I try to print the result, you will see it will only split it once. As we can see right here, we have 12, then it is missing a number, and the rest of the string is stored as a second element right here. Okay? So simple as that. Now, by the way, the default value of max split is 0, meaning that it should split it by all possible splits. Okay? So the next thing that we're going to take a look at is a function called sub. Now the syntax of re_sub is like this. So re.sub, and then in between the brackets to specify 3 actual arguments. First one is pattern. The second one is replace, with what to replace. And the third one is the string from which you are reading. What this method returns is a string where matched occurrences are replaced with the content of replace variable. So let us take a look at the example. Let me delete this. We're going to have a multi-line string, for example. Let's say the string is string equals, and we can define the multi-line string in a different way right now. Let's say we define it just like this, so ABC 12, and in order to actually define a multi-line string without using the 3 single open and close quotes, you can simply just specify backslash right here, and then go into the next line and specify the rest. So ABC 1 2, DE 2 3, and then backslash n for the new line, and then F4 5 6. Doesn't even matter. This is our string. Press here enter. If we print it right here, you will see how it looks like. And right now, let us create a pattern, which is going to be this one. So equals, open single quotes, backslash s plus, and what this pattern basically does is it will match all white space characters. So this pattern will match all white space characters. Now, and we want to replace them with an empty string. So replace is going to be empty string, and that is something that we are going to use to replace. And basically all we are left to do is create a new string and perform this sub function. So new string equals re.sub, and there we need to specify 3 arguments, as I said. First one is going to be pattern, which is the \s plus. The second one is going to be replace, which is empty string, and the third one is the string from which we are replacing. And right now, if we print the new string, you will see it will print out ABC 1 2 D E 2 3 F 4 5 6. So you can see it removed all the empty spaces and it replaced them with an empty string. Therefore, everything is now put together. Okay? Now, if the pattern is not found, the re_sub will return the original string. So right now you can pass count as a 4th number to the re.sub method. If omitted, it will result to 0. This will replace all occurrences. Okay? Let us take a look at that one as well. So we have the same string, which is going to be this one. Let us just copy it, paste it right here. So we want to actually have the same string right here. Now we want to match all white space characters as before. So pattern is going to remain the same, as well as the replace is going to remain the same. But right now the new string, new underscore string, is going to be equal to re.sub, and there we need to specify the actual pattern. Now right now we'll specify pattern replace. We want to replace the string, and the fourth element is going to be the count. Okay, so we will set that to be equal to 1, and then if we print the new string, you will see it will print it differently. Or wait, let me check it out. Yeah, it did print it differently. As we can see, we are no longer having these empty empty spaces right here in between the ABC and 1 2. So what it means, it only went to the first actual element it found and it replaced it with the actual empty string. Okay, so you can also check it out whether it will work twice just by specifying the actual string, and you can see it does work. So you can specify how many times you want to replace as a 4th actual argument to the sub function. Okay, so that is also something to take a look at. And right now, what to look at sub_n function. The sub_n function is basically similar to the re.sub, except it returns a tuple of 2 items containing the new string and the number of substitutions made. So let us take a look at the sub_n function as well. Clean. Open up my idle once again. For some reason it takes a little bit longer to open. Let's go once again. Okay, so here it is. Let me close this one. Import re, and let's take a look at the example of using the sub_n function. So we will create once again a multi-line string. So string equals ABC 1 2 backslash, go to the next line, DE space 2 3 space new line character, and then space F45 space 6. Close the single quotes. This is going to be our same multi-line string. We're going to use the same pattern, which is going to match all white space characters. So equal to backslash S plus. We're going to have the replace string to be equal once again to the empty string. And right now we're going to use the sub_n function. So new underscore string equals re.sub_n. And there we specify the pattern, the replace, and the string. So this one takes the same arguments as the sub function. Just right now, if you see right here, if I print new string, it will return a tuple. And we know that it is a tuple by these brackets right here. You remember that tuples have normal brackets, while as the lists have square brackets. And you will see that it will return the result, as well as it will return the amount of times it performed the replace function. Okay, so basically that would be about it for this tutorial. I hope you enjoyed it, and I hope I will see you in the next one. Bye. Hello everybody, and welcome back to this section. And right now what we're going to do is we're going to take a look at different modules with the interaction of the websites, as well as the interaction with the HTTP requests, HTTP responses, and so on and so on. So first of all, the HTTP requests, dealing with HTTP requests in Python is not that easy, especially when we have two different actual modules, yourlib and yourlib2, to handle HTTP related operation. Now both of these modules basically have different set of functionalities, and many times they need to be used together, such as, for example, the main drawback of using yourlib1 is that it is confusing. Few methods are available in both yourlib and yourlib2, and the documentation is not so clear, and we need to write a lot of code to make even a simple HTTP request. So to make things simpler, one easy to use third-party library known as requests is available, and most developers prefer it to use it instead of the urlib library. Now it is an Apache 2 licensed HTTP library powered by urlib and httplib. So in order to install the requests module, because it doesn't really come pre-installed in Python, I already have it installed. Therefore, if I just open my idle and type import requests, it will work. But if you don't have it installed, you will receive an error. Now, there are two ways to install it, basically, or not two ways, there are two different ways to install it with the same command, that depend whether you actually put the pip inside the path, which allows you to actually run it from whichever directory you want. And in case that you don't really know what I'm talking about, I will show you right now. If you open up your command prompt, and in order to open up the command prompt, you just simply type cmd, press here enter, and this is the command prompt, which you can type the commands that are going to get executed by the system. And if you actually added the Python as a path, so you can execute it from whichever directory you want, in order to actually install requests, you can simply just type pip install requests, and then it will work. But if you are using the Python as in my case, where I don't really have it in a path and I can't really execute it from anywhere I like, you will need to navigate through the app data directory and through the programs to find Python 3, and then go to the scripts folder of Python 3 and perform this same actual command. And I will show you how you can do that. Basically navigate to your account directory, and you can navigate just by going to cd and then specifying the path, such as for example cd, then users backslash, and then the name of the user that you currently have Python installed in. And once you're there, all you want to type is this command, so cd app data, so app and then capital data. It will lead you to this directory, where in order to check what is stored in this directory, you can simply just type dir right there, and you will see that there are 3 different directories in this directory. Now we want to go to the local directory, so we can do that just by typing cd empty space and then local, press enter, and then you will be in the local directory. In order to check what is in the local directory, type dir once again, and you will see multiple folders right there. The one that we're interested in currently is the programs folder. So make sure to navigate to the programs folder, and you can do that just by simply specifying cd programs. And there, if you type dir once again, you should see Python directory. Cd to that directory, press dir once again, you should see Python 37 directory if you actually downloaded the current version of Python as I did. If you are watching this in the future and there is a newer version, maybe this will be named differently, but it should be Python at least. So cd Python 37, and there, once you type dir, you should have a bunch of files as well as the scripts file. Go to the scripts file, and from there you should execute the same command that we did at the beginning of this tutorial, which is pip install and then requests. Press here enter, and this will install the request for you. Now make sure that you're connected to the internet. Now right here I already did install it there, that's why it actually says requirement already satisfied, because I installed it previously and I already have it. And once you perform this actual command, you will be able to use it as well. Okay? So once you actually finish all of that, you can close this, and you can go back to the idle. In order to import requests, you simply type this line that I typed at the beginning of this video. And now let's take a look at how we can actually make a simple GET HTTP request. So GET is by far the most used HTTP method. We can use GET request to retrieve data from any destination we want. So let's start off with a simple example first. Suppose we want to fetch the content of the home page of our website and print out the resulting HTML data. Now we can do that using the requests library simply with two line commands. Okay, so we imported requests, and right now we're going to create something like this. So r equals requests.get, and all this takes in between the brackets is the URL of the site that we want to get the page from. So let's say we want to get the page from facebook.com. But make sure that you add the single quotes, and make sure to add HTTPS, colon, 2 slashes, and then facebook.com, and then single quote at the end. Okay? Now, in order to actually print the HTML page, you can simply just type here print, and in between the brackets r.content. And you will see, squeeze text 929 lines, you will see that because it is a huge file, it will not really print it, as it says right here. The squeezed output is very long, 929 lines. Expanding it could make idle slow or unresponsive. It is recommended to view or copy the output instead. Really expand, you press here yes, and you will see the HTML code of Facebook. Now, because this is too long, and because this is actually making my actual idle unresponsive, we're going to restart this. I just want to show you, and we can take a look at a different example with a smaller page. So let's say, let me run my Apache 2 web server on my laptop, so I will do that real quick. The reason why I'm using my laptop is because the HTML code of that page will be rather small, so that's why we can actually use that one to test this. Okay, so I started the Apache 2. Now let's import requests. R equals requests.get, and what I'm going to specify in between the brackets is the IP address of my laptop. Whoops, let's see. Because the target machine actively refused it. Okay, maybe I am refusing connection, doesn't even matter. Let's just use an actual real site. So equals requests.get, and in between the brackets let's specify, for example, let's say this website, and make sure to specify the actual HTTP. Let's see if this one will work. Okay, so this one does work. And let's say whether the content is too large to be printed out. If it is, doesn't even matter. We're just going to continue into the next example. Yeah, this one is even larger, as it says right here, squeezed 2072 lines. But basically you get the point. What this actual 2-line code right here will do is it will perform a GET request onto the specified URL, and then it will, in order to print the HTML code of that page, you simply just type here print r.content in between the brackets, and it will prompt you with the HTML code of that page. It will also print the response in an encoded form, but if you want to see the actual text result of the HTML page, you can read the .text property of this object. Similarly, the status code property prints the current status code of the URL. Now we know that there are different status codes, such as, for example, 400, 404, 200 is the status code of OK. That means that you successfully loaded pages. Basically, there are different status codes. Now let me restart this once again because that error is too large. So let me import requests. And let's see how we can actually get this status code. So we know that we can for sure load the Facebook page as it is online and running. So let's see whether we will indeed get the status code of 200 once we try to actually load that page. So we will perform the same requests. Or let's go for the Twitter this time. So requests.get. We will specify https twitter.com. We perform the get requests, everything works really well. In order to get the text printed out of the HTML code, you can simply just type print r.text. That is what I told you before. And it will of course say squeeze text 2,793 lines. That's why we will not really try to print it out. You can write it to a file and then inspect it. What we're more interested right now is to see whether we got a status code of 200, but even by this reply right here, we can guess that we did, but let's just in case print it. So in order to print that, you simply need to type the R, which is the object that performed the actual get request, as we can see right here, and then dot status underscore code. Let me see. Yeah, it's not stats code, it is status code. So r.status underscore code. And you can see we did get a code 200, which means that we successfully loaded the page. Okay, so also let us take a look at how we can actually read the response. So the response of an HTTP request can contain many headers that holds different information. That's why it is also important to know about the responses as well as to know about the requests as well. Now, HTTP bin is a popular website to test different HTTP operation. Let me just show you right here. If you just open up your Google Chrome, Firefox, or whatever you use, and you simply just type HTTP bin. Okay, HTTP bin.org, I believe. Yeah, it's not .com, it is .org. Let's go right there. Okay, so this is the website, and let's say and in order to inspect your actual packages flowing around, you need to go to the /get, I believe. If I just go right here, yeah, there it is. And this is basically your HTTP requests and responses. As we can see right here, the host is the httpbin.org. Let me just enlarge this. This is basically a GET request, and you can see the desired headers of the request. As we can see right here, headers accept encoding, accept language. So this is a GET request that we send to the actual site. And this site is good is because it actually prints out our request. As we can see right here, we are user agent, Mozilla, Windows 10, which is correct. And we are going over Google Chrome. So everything right here is correct. And this is our HTTP requests to this httpbin.org website. So right now, let's see how we can actually interact in our Python with this actual website. So let me lower this so we can have both screens right here, even though we might not really need them, but doesn't even matter. Let us leave it right here. We'll perform the GET requests onto this website, which is httpbin.org and then /get. So in order to do that, we simply need to call requests.get, and in between the brackets, we specify http column / httpbin.org/get. This is our website. We perform the GET request, and let's say what happens once we print the header. So print r.headers, that is how we can print them. And in between the square brackets, we specify which header we want. So let's say, for example, we want the server header. Okay? Press here Enter, and we can see that the output of this server header. Now we can try different ones if we want to, such as, for example, r.headers. And let's go with the, for example, date. Date is not defined. Yeah, it is not defined because we need to put it in between single quotes. Okay, and we can see the given date of the performance of this GET request. Now let's see different ones, such as, for example, headers, and in between the brackets we specify content type. Press here Enter, application JSON. So you can see that you can actually print and retrieve the headers with the usage of the requests library. And we can also access each header value by using specific keys. Note now, one thing to also note is that the key is not case sensitive. Now, similarly, let's try to access the response value. So the above header shows that the response is in JSON. As we can see right here, it says content type and the application JSON. Now the requests library comes with one built-in JSON parser, and we can use it to parse it as a JSON object. So we can do something like this, requests dot get, and let's do it from two different lines. Oops. First of all, we need to store it. So requests dot get, in between the brackets we'll specify the same link. So http//http bin.org/get. Press here enter, and basically we did the same as in the previous actual example, but right now we're going to simply make a new variable. So response is going to be equal to r.json. So we're going to parse this data that we retrieved with the JSON library, or not the JSON library, with the JSON function. And if you simply just print r.json, you will see that we will get the output in a JSON format right here. As we can see right here, we have headers, accept encoding, host, user agent, and we can see that it differentiates from this actual request right here, because the user agent is no longer Mozilla, Google Chrome. Right now it says user agent is Python requests, which is actually correct. Okay, so that is also something to take a look at. But you can, of course, if you want to, you can simply just print different fields, such as, for example, print, and from the response we will set, let's try to print URL, and we will see that we actually do get https http bin.org/get. So that is also something you can do. You can use JSON library to print it in the JSON format. Now let's say how we can actually pass the parameters in the get request. Now in some cases you'll need to pass parameters with your get request, which take the form of query string. Now to do this, we need to pass these values in the parameters as shown, right, as I will show you right here. So we imported requests, and now what we are going to pass to our actual website is the payload. So we will create a payload which is going to be a dictionary, which is going to have its keys and values. So the first actual element is going to be the username, which is going to have the key of, for example, administrator, doesn't even matter. And it also needs to have the password. So we will specify password right here, 2 dots in order to specify the key, and the password will be password. Okay. And in order to actually send this as a payload to the website, all we have to do is simply perform the same requests. So requests.get, same as before, open and close single quotes, and type here http dot 2 dots and then / http bin.org/get. And before you click here enter, you need to add comma and then set the params variable to be equal to payload. That is how you can specify the parameters in the get request. If you just press here enter and you print the r.text, print it right here, you will see what your actual request was. As you can see right here, user agent is Python requests, the URL is this one, and you can see that we actually passed the parameters in a link as well as the arguments that we see right here. And we can see that the URL that we actually try to get is this one, username equals administrator, as well as password equals password. Okay, the origin, this is the IP address of the website, and therefore we now know that we successfully passed the parameters with the actual get request. Okay, so that will be basically about it for this tutorial. I hope you enjoyed it, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now what we're going to do is we're going to see how we can actually make post requests using the requests library. Now the post requests are opposite of the get requests. Basically it means sending data to a server as opposed to retrieving it, although post requests can also receive data within the response, just like GET requests. Now, in order to use it in Python, instead of using the GET method, we need to use the POST method. For passing an argument, we can pass it inside the data parameter. Now, in the previous video, we saw how we can pass the arguments in the params parameter. Right now, it is different. We're going to pass it in the data parameter, and we're going to perform it on the same website as we tested before, so http://bin.org. But right now, we're going to go to this link, http://bin.org/ and then post. You will go right here and it will say method not allowed. This method is not allowed for the requested server. Okay, that doesn't really concern us. We want to just test it out with our Python. Whoops, we need to go to idle, enlarge this, and then I will import requests library. We need to create the payload once again, which is going to be our data currently, and we're going to once again parse the username and the password. Just right now, you will see that once we actually print the contents of our headers, it will not be in the link itself, it will not go through the link, it will go through something as a form or something like that. You will not longer see the link containing the username and password because we are performing the post request right now. So right here we need to have username, let it be admin, then the next thing we need is a password, so password parameter is going to have the value of password, doesn't even matter, you can specify anything you like, and right here we need to create the post request, and to create the post request you simply just call the request library and then .post. You specify the link in between the brackets, which is going to be http://http://bin.org/post, which is the actual path to the website that we want to perform the post request to. Then once you do that, simply just press comma and specify the parameter data to be equal to payload. Okay, simple as that. Press here enter, and right now what we can do is we can print, first of all you can print the URL if you want to, in order to just make sure that you are specifying the correct URL, and you can also print the text format. As we can see right here, in the previous actual video where we actually sent it with the GET request, you remember that the URL consisted of username and password right after it, and right now we're passing the password and username inside the form, and you can see right here, because this is a post request. You can see the usual headers, host, http://bin.org, user agent, Python requests, and so on and so on. So the data will be form encoded by default. Now you can also pass more complicated header requests like a tuple, if multiple values have the same key, a string instead of a dictionary, or a multi-part encoded file. Okay? And what we're going to do is we're going to take a look at actually sending files with the post request in the next video. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial, and right now we're going to take a look at how we can handle redirections from a different website. Now, the redirection in HTTP means forwarding the network request to a different URL. For example, let's say we try to visit a website, so open up your idle. First of all, import the requests, and let's say we try to visit github.com, so r equals requests.post, and in between the brackets we simply specify http://www.github.com. So this is a website that we actually want to visit, and you will notice that once we actually print the history of this website, and by history I mean the history of paths of our post request, you will notice that we actually got a 301 status code. So r.history, press here enter, and you will see that the response was 301. And 301 response means that it was redirected. Okay, even though that once you print the actual r.status code, you will get 200, that doesn't mean that in the process of actually getting the page you want, you didn't get redirected at least one time. Now you can see that the redirection process is automatically handled by requests, so you don't need to deal with it yourself. Now the history property contains the list of all response objects created to complete the redirection. In our example, 2 response objects were created with the 301 response code. HTTP 301 and 302 responses are used for permanent and temporary redirection. Now, if you don't want the request library to automatically follow redirects, then you can disable it by passing the allow redirects equals false. As we can see right here, r equals requests.post, perform the post request to the same website, www.github.com. Oops, I actually wanted to add that, but doesn't even matter. Let us go once again. Copy this, paste it, add comma after the link, and type allow underscore redirects equals false. Press here enter, and if you just print r.history once again, you will see it is an empty list, as well as if you print r.statuscode, you will get 301. That is because we are stuck on the actual response that wants to redirect us, because we don't really allow it. Therefore, we can't really load the page. If you simply just try to print r.text, you will see it doesn't contain any HTML code, because we didn't really successfully load the page, because we actually didn't allow the redirects to happen. So that would be basically about it for this short tutorial. Hope you enjoyed it, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now what we're going to do is we're going to take a look at some of different modules that allow us to interact with different browsers, with HTTP protocol, and also we will take a look at a BeautifulSoup module that is going to allow us to parse HTML data more easily. Now, of course, we are going to continue right after it with the requests module, but right now let us take a little bit break from that and let us see some of the other available modules that are in Python 3. Okay, so first of all, we will take a look at the web browser module. Now, web browser module is not really something that you will use a lot. It can be useful for certain things, but most likely it is used just to open up your browser. Nothing more than that. And you will see just how that works. Basically, in this module we have a function called open, which can open a new web browser with the specified URL in brackets. So let us take a look at it. Simply to use it, let me just enlarge this. To use it, you simply just type import web browser, and it is an already pre-installed module in Python 3, therefore there is not really a need for us to install it, so we can import it right away. And let us see how it works once we call the open function. So in order to call it, you just type simply web browser.open, and in between the brackets, between the single quotes, you need to specify the desired URL. So let's say we want to, for example, visit the python.org or the official Python website, http or https, then 2 dots or colon, / and specify just python.org. This is the full link. Make sure that you specify within the link also http or https, depending on the website that you want to visit, and also make sure to specify afterwards the entire link. Press here enter. It will say true, and you will see right here that it opened my Internet Explorer, and it also loaded the Python official website. As you can see, this is the link that we searched. So that is the actual function that we can use right here. Now let's, for example, try to create something useful with this function. So we will try to create a program that will open Google Maps when you specify the location that it should search. For example, you know that once you open Google Maps and you specify the location in a certain tab, you will see that it actually, let me just show you right here, if we go down here, Google Maps, open the Google Maps right here, this is the website that we're going to search, and let's say you search for California. You press here enter, and you will see that we get a different link every time you basically search for something. Now you will also notice that the link starts with /maps/place. and then afterwards you add the actual address. Now let me just click right here, and then once you add the actual address that you're searching for, it will lead you to a specific part of the continent or the city or whatever you actually search for, and it will show you that on the maps. So all we have to do is prompt the user for the location, which they will then specify, and afterwards we will simply just search this link and add the location that the user specified right after the /place. So right here, this is the location, and we will actually add that thing. So let us see how we can do that. Now first of all, let me restart this so we will have a clean program. Right here we are going to import two modules. One of them is the web browser module and the other one is the sys module. But before we do that, let us open a new file because this is a program that we are going to run. So import web browser and sys module. These are the two modules that we are going to need. And before we actually code anything, let us save this file. We can save it right now in the actual, let me just see right here. Yeah, we will save it in the Python module, in the Python directory, doesn't even matter. Web browser open.py. Press here enter, and you successfully saved your program. Now this is a program that we will have to run through a command prompt because we imported the sys module, which we will use in order to specify the arguments, so we will need that one as well. And right here, let us go, for example, to specify something like this. So address will be equal to open and close single quotes, and then to that we will add the arguments that the user will specify in the command itself. So we learned this join command. We know that this will join whatever the string is to the empty string, which is our address current string. Then we will add the sys arguments. And in order to specify that, we will call this sys function and we'll specify argv for the multiple arguments. Now also make sure that in between the square brackets in argv you specify 1 and then colon, because that will mean that it will skip the actual program name and it will not search the program name in the Google Maps. Because let's say we search something like this, or we run the program like this. So web browser open.py is the name of our program, and then we want to search for California 23 or something like that. Basically specify any address you want with as much detail as you want, and it will parse this to the link, and there it will find this in the actual Google Maps. But we specify from 1 and then till the end because it should skip this one and not parse it into the link. It should only parse the location. Okay, so let us delete this. And basically all we have to do is call the web browser function, web browser.open, and in between the brackets we need to specify the link that we saw, which is the Google Maps /map/place. So just specify https://www.google.com/maps and then /place, and then add another slash, and what we're going to do right here is we're going to concat the address that the user will specify, so the address, just like this. Save this program, open your command prompt, so cmd, just type in your search bar, navigate to the actual Python 3 program or wherever you actually saved it. In my case it is in the app data, local, then programs, then cd python 37, and if I just type dir right here, here is my web browser open, or pen in my case. I didn't specify O, doesn't even matter. We will just run it like this, and then we'll specify California. Press here enter, and you will see that it actually opens Google Maps, and it opens the location California, as you can see right here. Now you can also try to specify a more detailed location if you want to. In my case I don't really need to. You can specify any other city or any other country you want to. So let's try web browser pen, .py, and let's try for Paris, for example. So we will specify Paris, and you will see right here we indeed get the actual map of Paris, which is in France. Okay, so that is a basic usage of this module. We saw a simple example of how we can use it, and right now what we're going to do is we're going to take a look at another library that we can use. Now that library, let me just close this, we don't really need it. We will just leave the idle open, and that library is actually called BeautifulSoup. Now, it is a module that is used for extracting information out of the HTML page. Now, the name of the module in Python is BS4, and that's the name that we are going to use to import it. But first we need to run the command pip install BS4 in order to install it, because it doesn't really come pre-installed in Python 3. Therefore, we need to use our pip module or pip script, or however you want to call it, in order to install the desired library. Now, once again, if you didn't put your Python to the path, you need to navigate to the directory of your Python 3 and then run the actual pip command, and I will show you how you can do that. So once again, just open up your command prompt just by specifying cmd in the search bar, press here enter, and by default I believe it should lead you to the directory of your account right here. And once you're at the directory of your account, just type here cd app data, press here enter, then after it press cd local, press enter, press cd programs, press enter, and once you type dir in the cd programs, you should have a directory that is called Python. Navigate to that directory, so navigate to Python, press dir once again, you should have Python 37. If you have multiple things right here, doesn't even matter, just navigate to your Python directory, and there, one last directory we need to go to is the scripts directory. So change your directory to scripts, and you are good to go. All you need to do right now is install the desired library, and we do that by specifying pip and then install, and then the name of the library that we want to install, so BS4 in our case. Press here enter, of course make sure that you are connected to the internet, and this will start the process of installation of this library. Now you can see right here it installs it correctly. As we can see right here, successfully installed BeautifulSoup, and it even says you are using pip version, however version this one is available. We can upgrade if we want to, but we don't really need to at the moment. We only wanted this library so we can import it in our Python 3. So click on the X right here, we don't really need command prompt anymore, and let us import the BS4 library. So we import it like this, import BS4, and we are also going to import another library that we're going to need, and that is already a familiar library to us, which is the requests library. So just type here import requests. So it took a few seconds to import, but doesn't even matter, we are ready to go. And what we're going to do is we're going to try to parse the HTML page using these two libraries. Now, why we are doing that? Well, basically the BeautifulSoup has already pre-built functions that we can use in order to actually parse this HTML data way easier than we would have to do without it. So first of all, in order to parse the HTML data, let us think about what we need to do before that. We need to create a request to the page that we want to parse. So we already know from the previous videos how we can actually create requests. So let us just create a variable called result, and the result variable will store the actual get request to a certain page. So we will call the request library right here. So requests.get, and in between the brackets we need to specify a link. So we will specify a random link. I'll specify this one. Now you can specify any link you want and press here enter. This will perform the get request to the page. We can check for the actual status if there is any error, so we can do that by simply specifying result.raise_for_status. Yeah, there is nothing called status. We need to specify result.raise for status. Press here enter, no error, so everything went perfectly. And right now we're going to use the BeautifulSoup library to parse the data. So we will create an actual variable, which is going to be called site soup. Doesn't even matter, you can call it anything you want. It is going to be equal to bs4, and from the bs4 we are going to call the BeautifulSoup function. As we can see, by the default the idle prompts us with that function because it is one of the most used functions. And in between the brackets, what this actual BeautifulSoup function takes is it will take the HTML data, whether you actually load it from a file or whether you perform the GET request like we did. And in order to actually parse the HTML data right here, we can simply just type result.text. Okay? So, if you want to make sure, before we actually type this, you can simply type result.text. And you can see squeeze text 120 lines. We can actually run that right here for some reason. Okay, so here it is. This is the HTML data from that certain page. Let us just go all the way down. Yeah, I didn't think that the 128 lines will create us a problem, but for some reason it still is laggy. And now that you know that this indeed is HTML data, let us rewrite the line. So site soup equals, or let me just restart this because you really can't see anything out of that HTML data. I shouldn't have actually printed it out. I will just type everything real fast. We import it to libraries. Then we perform the GET request. So result equals requests.get HTTP, and then specify the link. Oops. Yeah, I need to restart it once again. Sorry about that. For some reason, I am making a lot of mistakes right now, but doesn't even matter. So BS4. Now let us make sure that we type this correctly. So result equals requests.get. Now also I'm wondering whether there is an actual clear command for this idle. Not really sure. If any of you know that there is a clear command to clear the screen from the idle, please post in the questions below, so everyone should know that. And me as well, even though I will search it right after this video because it is necessary in case you actually make a mistake and a huge error pops up right here. It basically just looks ugly to look at, therefore it is always good to clear the screen. But let's get back to our program. Let's not stray away from this actual program. HTTP. Make sure to specify the correct link. Okay, so the result request is performed correctly. We can see that it finished everything. Just I made a typo right here, and we will continue with that word so we don't actually restart for the third time. So what we're going to do is we're going to create another variable site soup that we did before and call the bs4.beautifulSoup onto the actual result.text, which we now know is the actual HTML code of the page. So result, and right now I called it lst.text. I called it that by mistake, so don't really think that I called it because, and not because I wanted to call it like that. And press here enter, and what this function will return is a BeautifulSoup object. Also, one more thing is you should make sure to run this program while you're connected to the internet, because otherwise you will not be able to even perform this GET request. Okay, so once we did this, in order to see that it will indeed return the BeautifulSoup object, you can simply just type the site soup and you will see that this belongs to the class bs4.beautifulSoup. So we use the library bs4 in order to perform this actual task. And right now, we're going to use a method from BeautifulSoup to find certain element. Now this was a simple program that we saw that we can actually see how we can create a BeautifulSoup object, and right now we will take a look at the function that can return elements of web page with BeautifulSoup object simply just by specifying the CSS selector for the element that we are looking for. Now the CSS selectors will specify the pattern that program will use to find different element in the HTML code. Now what I mean by that is something similar as in the regex library. We took a look at the regex library and we know that we need to specify the pattern that it should search for, and the regex actually has its own syntax But right here, we specify our own syntax just by specifying a certain element from the CSS. For example, those of you that know the CSS and HTML know that, for example, div element, input name, input type button, div span, and so on and so on. Well, basically, those are the things that we're going to specify in the brackets for our Python program. Okay? But for those of you who don't know CSS, don't worry, it is rather simple. And basically, all we are doing is specifying just different CSS elements in Python 3 code. So nothing really to worry about there. Now, let's see how we can actually do that. So once again, make sure you import the BS4. And just to make sure, I will restart this once again, so we don't go on with the actual result specified incorrectly. Right now, we only need, let me import this one first. So import requests and BS4. And right now, result will be equal to requests.get. And let's, for example, try to get twitter.com. But make sure that we specify HTTPS before that. Or let's simply just go with another smaller website, for example this one. It doesn't have .com. Now once again, you make sure that you specify any website you really like. It really doesn't matter which website you specify. Now I'm not really sure if this website is an actual HTTPS website. We're going to see in just a second if this works. Okay, so it is taking a few seconds to finish this, and basically, what is this? Yeah, it is because I actually specified the HTTPS and the website is an actual HTTP. So let us simply just continue with the website that we used previously, because then we know that we for sure won't get any error. Result will be equal to request.get, and we are simply just going to search for the previous website in our program, so this one. If you are running with a different website and it works, you make sure to continue with that one, it doesn't matter. We're going to create our site soup object as we did before, which is going to perform the BeautifulSoup function onto the result.text, which is our HTML code. So you can see this finishes relatively quick. And right now, let us take a look at different things we can do as we created this object. So first of all, as I said, we can select the elements by using the select function. So we can call or make a variable, which in our case will be a list. And we will call the site soup object, which is our BeautifulSoup object, and we will concat the select function to it. Now, if you remember what I said, this select function takes an input of the CSS element. So we will have to specify a CSS element right here. So let's make sure that we specify something that is usual, such as div. So this is something that any website must have. Now you can specify anything else if you want to, but for now, let us simply just specify div. Now we can check the length of the elements to see how much of the actual results it has retrieved. And we can see that it has retrieved 33 results. If you simply just type elements right here, you will see that it has too many lines to print because it is basically an HTML code. Now, there are ways that we can actually parse these elements without printing all of these lines, and one of them is, for example, to print the actual stuff that's written on that website instead of the HTML code, and we can simply just do that by specifying, for example, let's specify the third element of this list, which is going to be the third div element in the HTML code. We specify it by specifying 3 in between the brackets. Or pardon me, once we specify the 3 in between the brackets, it is the fourth element because we know that counting in Python starts from 0. So we're specifying the fourth element and we're going to use the getText function on it. And you can see that this is the string that is written under that div element. Once you actually go to this website, so let us go there. Wait, I will search it right here. If we actually look for it, you might be actually able to find this. Let's see. Where is this? Now this is on my language, therefore most of you will not actually understand it. but let's just try to find this string. Now we can see this string right here is this one right here. Then this goes, here it's that. And then goes the actual menu, if I am not mistaken. Yeah, here, this is the next thing that we see. As we can see, these 4 words, here they are, I believe. Let me just double check everything. Yeah, here they are, these 4 words. And basically, that is what you do with the getText function. So simply you select the div element, which we can see right now that all of these actual elements belong to the same element. So all these selected. So this string right here, this string, these 4, and then this menu right here all belong to the 4th div element. If you, for example, try to print the 5th, which is selected by the number 4, you will see that we will get something else printed out. So basically we only get this first string right here, as we can see right here. Now if you simply try to print, let's say 10th, we will see if we even get anything. Yeah, we don't get anything. Let's try with the 2nd. You can simply experiment with this and see what do you get. Now for some reason we actually get the entire div elements printed out right here, and you will see once we actually specify elements from 0, you will see that the same thing will actually get printed out, just with more strings attached to it. As we can see, we also have this inner string right here at the beginning, so all these other elements will also going to contain it, but also different things as well. So you will get, once you specify the actual 0th element, you should get specified the entire div elements and how it looks like on the website. Okay, now let's see another thing that we can do with this. We can simply just get the string of this, if you in case need it, doesn't even matter. You want to, for example, print it, and you want to print the 0 element, you can simply just print it like this. So elements, I'm missing an N. Okay, press here enter, and you will see squeeze text, 98 lines. Now we will not print it right now because it might actually slow down our program. But if we can print actually this element in text, you can see how it looks like. Now this \n will no longer be \n, it will actually get printed out as a real text. So let me show you right here. String, 3rd element, press here enter. Yeah, pardon me, it will not get printed out as an actual text. This string of the elements is, I actually mistaken these 2 functions. This one will actually print it as a text, and this one will actually print it as a code. As we can see right here, this div group right here, and we can see that it indeed is div group by seeing the open div tag and close div tag. We know that this group corresponds to this string right here. And if you actually try to search for it, you can see it right here, such as, for example, this word. Here is it in the actual code, and you can concat these 2 in order to see the similarities and differences. Basically, this is the code for this text, simple as that. Okay. Now, another thing that we're going to take a look at is the attributes method to these elements that we can use. So it will return the dictionary of attributes which then you can use as you like. So for example, elements, and we will use the same element, which is the 3rd one or the 4th one in Python 3 programming, and use the .attrs, press here enter, and you will see that it is in the class pad group. Now you might be asking, what is this pad group? Well, if you take a look at more closely at the code, you will see that right here it starts with div class equals open and close double quotes, and in between pad group. Okay, if you simply just specify elements from the 0 and then you specify attributes, you will see this ID and then this DocuWiki site. Now we can't really print that out because, or let's actually try to print it out, maybe we can. Elements, we want to print the string from the element 0, which is going to actually give us everything. Yeah, it is 98 lines. It's best for us that we don't actually print it, otherwise our program will bug out. But you will be able to find this ID in the actual code once you print out the code. Okay? So basically, the attributes actually returns the dictionary of the different div class that you are using, in our case in the element 3. And in the element 0, it will return the ID. Okay? So basically, those of you that actually know web development basically understand this a whole lot better. All these CSS calls and this HTML code right here, this div tag, you shouldn't really have problem to understand this. Now, we will continue with this in the next lecture. For now, that should be about it. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now, let us return to our requests library and see all the other available options with it. Now we took a look at some of the simple stuff with the request library. Now we're going to take a look at some of the stuff that you can also do, such as encoding, such as printing the raw actual HTML page, such as printing or, for example, posting files to the actual website. And we're going to take a look at some of the different examples of doing that. We're also going to take a look at the reading contents of the server's response. And let us continue with all of that in this video. Open up your idle. Import requests right away. So import requests. And right here, what we're going to do is we're going to do something that is already familiar to us, and we're going to perform the get request. So type here r equals requests dot get. And what we're going to search for is the actual GitHub page, and you will see right here, if you specify single quotes and HTTPS and specify api.github.com/events, press here enter. It will take a few seconds to finish, and once you actually type here r.text, we can see that it actually is indeed squeezed text in 522 lines. Okay, so we will not really print it. What you need to know though is that the request will automatically decode content from the server. Now, most Unicode characters are seamlessly decoded. Basically, what that means is when you make a request, the requests make educated guesses about the encoding of the response based on their HTTP headers. Now, the text encoding guessed by requests is used when you access r.text. You can find out what the encoding request is using just by specifying r.encoding. And we can see that it is used the UTF-8 encoding. Okay? Now, if you want to, you can, for example, change the encoding simply just by specifying the encoding you like in the actual r.encoding environment. So r.encoding equals, and between single quotes you need to specify the encoding. Let's say we use ISO 8859-1. Press here enter, and if you change the encoding, the request will use the new value of the r.encoding, but only whenever you call r.text. So right here, r.text, yeah, it still is 522 lines. It doesn't even matter, we will not print it out, but you might want to do this in a situation where you can apply special logic to work out what the encoding of the content will be. For example, HTML and XML have the ability to specify their encoding in their body. Now, in situations like this, you should use r.content to find the encoding and then afterwards set the encoding. So r.content, we already know what that does. Basically the same as r.text. Now the r.text will actually print out the page itself. We already know that. And basically after you execute these two commands, this will let you use r.text with the correct encoding. Now requests will also make custom encodings in the events that you need them. If you created your own encoding and registered it with the codecs module, you can simply use the codec name as the value of the r.encoding, and requests will handle the decoding for you. So that is also something that you should know. Now this is mostly aimed at the web developers. nothing really there for anyone that is not really interested in this web developing stuff and in this request library. You can feel free to skip this, and we're going to simply just look at one more thing or two more things. One of them is getting a raw response content. Now you can simply just do that just by specifying stream equals true in the actual request.get function. Now basically this is mostly used in rare cases, that when you actually want to get the socket response from the server, you can access it with the result.raw function. Now if you want to do this, make sure that once again you set the stream to be equal to true in your initial request, and you can do it like this. So for example, we have result equals requests.get, and in between the brackets you simply just specify the link. So we are going to use the same link, so https api.github.com/events. But don't press here enter, make sure to add comma and specify stream equals true, otherwise this will not work. So stream equals true, press there enter, and then you can just type r.raw, and you will see that basically it created the actual HTTP response object at this memory address. Now in order to actually read from that memory address, you need to type r.raw.read, and then you can specify in between the brackets how many actual bytes you want to read. Let's say we want to read 15 bytes. Press here enter, and for some reason we don't really get anything right here. Let's specify some lower amount. Maybe that is the problem. Let's say 10, for example. Yeah, it doesn't really want to work, but this is the way that you actually can do it. Now maybe for some reason it didn't perform the request correctly. That's why it won't actually print it out. But this is the actual process. So basically you perform the request. Afterwards you can actually just simply type r.raw.read. Yeah, I think I know why. It is not r. We actually need to use the result.raw.read, because the R is actual this request that we performed at the beginning, and there we didn't use stream equals true, therefore it doesn't really want to print it out. I just noticed that, so we need to type here result.raw.read, specify 10 bytes, and you can see right here it prints us the first 10 bytes. Now if you want to, you can simply just specify .raw.read and specify 20 bytes, and it will print out the next 20 bytes. Okay? Now the most important thing right here is to make sure that you add this stream equals true, otherwise this will not work. Okay, so now let us take a look at, before actually closing this video, at one more thing, and that is posting a multi-part encoded file. Now requests make it simple to upload a file. Basically all we need to do is specify the URL, and we can specify the file just like this. So let's say the URL will be equal to, for example, let's use the previous website from the previous tutorial, which is https, then column / http bin, then .org/post, because we're going to post the actual files. We're going to create a post request, and there we're going to go to the actual /post directory onto this website URL. Okay, right now all we need is an actual file, and the files, you can simply just type any file you like. Let me just go right here. Let's see where this is, and right here let us create a new file. Or let me just see right here. It doesn't even matter. We're going to actually use this web browser open file from the previous video to actually try to upload it to this web server. Let me just see how it is called, web browser pen. Because we are in this directory in our idle right here, we're going to specify this file in order to upload it. Now it doesn't have to be the file from this directory. You can simply just specify to try to upload a file from the desktop directory, but make sure that once you open that file you specify the full path to that file, otherwise it will not be able to find it. And simply we can just, let me just close this, simply we can just make files uploadable just by putting them in something dictionary like, such as for example adding the key of a file to be equal to the value of the file content right here. we know that we open a file with the open tag, and in between the brackets make sure that you specify the file name. In my case that is webbrowserpen.py, which is the name of the file. We need to know how we open it. We open it to read bytes. Now always make sure that you read bytes, because we're actually going to send the raw content to the actual page itself. Press here enter, and you can see everything is opened correctly. And right now all we need is to actually send this file, or files, doesn't even matter. I just defined one file right here. All we need to do is create an actual post request. So result will be equal to requests.post, and we are posting onto the URL, which is this URL right here, and we are posting files. So files equal files. This parameter files is something where you actually set the equal to be equal to the files that you defined. Now this part right here doesn't have to be called files, it's simply called files because we called it like that here. You can call it anything you want. Press here enter, and let's print r.text. Press here enter, squeeze text, not r.text, result.text, and you can see right here the actual arguments, data files, as we can see right here. Let me just find, where is it? Where did it store it? Yeah, it is on the post page. User agent Python requests, correct. Open, place, address. Yeah, here it is. Here is the actual contents of the file. As we can see right here, we imported a web browser. This is the actual contents of the file. And we know that by seeing the actual key, which is file that we specified right here, and the actual raw data of that file is the actual content of the file, which is this one right here. We know that because we actually coded this web browser open.py program in the previous video. Therefore, we know that we successfully uploaded this file to the page. Okay, so that would be basically about it for this tutorial. Hope you enjoyed it, and we're going to continue coding with some of the more advanced stuff in the request library in the next tutorial. Hope I see you there, and take care. Bye! Hello everybody, and welcome back to this tutorial. And right now what we're going to do is we're going to take a look at some of the more advanced usage of the requests library. Now we're going to take a look at cookies, session objects, now requests, posting different authentication protocols, and so on and so on. What we did in the previous tutorials is we took a look at some of the simple things we can do with the request library, such as performing the simple get or post request. We also took a look at the usage of BeautifulSoup while parsing the HTML data and selecting different elements of the HTML data. And also we took a look at the web browser module, which allows us to actually use the open function to run our web browser. Okay, so right now let us start off with the session objects. First of all, open up your idle right here. Let's wait for it to start up, enlarge this, and import requests as usual. So import requests. We imported requests, and let us first of all talk about session objects. Okay, so basically the session object allows you to persist certain parameters across requests. It also persists cookies across all requests made from the session instance. And basically, we're going to use the urllib3 connection pooling in order to perform the session object. So if you're making several requests to the same host, the underlying TCP connection will be reused, which can result in a significant performance increase. Basically, with the session object, we allow us for a certain user to persist its connection with a browser or with a different website. Basically, it also allows the browser and the actual website to remember the information about the specific user, such as, for example, username, password, basically anything like that. We can set with this session. Okay, that's why once you refresh the page, you're not logged out of the actual account of yours because of the help of session and cookies. Okay, so right now, in order to actually create a session, we need to create a variable. For example, let's call it s. The variable s will be equal to requests.session. Now the S is capital in session, so make sure to actually write it correctly. And right now we are going to perform the GET request to the same actual page that we did before, which is the http://bin.org. Okay, so in order to do that, we can simply just type s.get, and in between the brackets we'll specify https http://bin.org/cookies. Now we are accessing different directories right now, /set, and then /session cookie, and one last slash, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is basically the directory in the HTTP website which allows us to perform this. Let's press here enter. You will see that we get the response 200, which means that the actual request was okay and it managed to go through. And right now we will get the basic result, which is going to be equal. So r equals s.get, and all we're going to get is the same part of this actual path. So just select from the HTTPS to the cookies, copy this, paste it right here. Now let me just delete the last slash, we don't really need it. Whoops. Yeah, let us redo that because I've managed to somehow mistype this. It was supposed to go in between the single quotes. So r equals s.get. Let us just type it, https://http://bin.org/cookies. Press here enter, and basically if you just simply print r.text, you will see cookies session cookie 1, 2, 3, 4, 5, 6, 7, 8, 9, which is basically what we set with this command right here. So if you copy this command, let me just show you, copy it, change this to, for example, hello world, press here enter, we get the response 200. We set the session for us to be named as the hello world, which is the ID of our session right now. And if we simply just perform the get requests, so s.get to the same page, https://http://bin.org/cookies, press here enter and print once again r.text, you will see that right now the session cookie has been changed to hello world. So that is how you can actually change the session cookie. Now, sessions can also be used to provide default data to the request methods. Now, this is done by providing the data to the properties on the session object. Now, what I mean by that is simply, let me just restart this. So we have a fresh idle open, import requests. And right here, we're going to create the same session object, which is done by specifying requests.session. Press here enter. And right now, what we're going to do is we're going to provide the authentication for our session. Now the authentication we can provide just like this. So s.auth equals, and in between the brackets, we'll specify user and comma, specify password as well. So we will just type here user and pass. Press here enter, and all we need to do in order for this to work is to update our headers with desired actual things we want. So basically we need to specify s.headers .update, which is a function that allows us to actually update our own headers, and we will specify in a dictionary like bracket. So open these big brackets, we'll specify test and then colon, and then open single quotes once again, and then true. Close the brackets right here. Press here enter, and all we need to do is perform the get request with our headers that we want. So s.get, and all we want to do is perform the get request to this website, the same website as in the previous example. So https://http://bin.org/headers. But before you press here enter, make sure to add comma right here and add the headers to be equal. And then you can specify this that we specified right here, which is test and true. So right here, open single quotes, type here test, comma, and then open single quotes, type here true. Press here enter, set object. wait. For header set object has no attribute items. In which line is the actual error? Let us see right here. s.get headers equal. Well, for some reason this doesn't want to work, but doesn't even matter. We are going to try something differently right now. Let us try, because we can see that the error is somewhere around here. Let us try whether we can actually access the cookies in our headers. Now we can do that just by simply creating a new session object. So s equals requests.session. Let us see if we will get the actual error there. And our R will be equal to get request onto this page, https://http bin.org/cookies, which is another directory on this website. And then we are going to add comma and then cookies equal open and close big brackets. Let's specify from my browser as an example. So from my and then column and then open single quotes once again and type here browser. Press here enter. Okay, so right now we didn't get error as we did right here. And let us print our response. So r.text, print it, and we can see cookies from my browser. Okay, so we can see that that works. Let us try whether it will work once we specify something differently. It should work. Copy, paste. Let me enlarge this. Copy, paste, and let's type here once again our good old phrase, which is hello world. So hello world. Press here enter, print r.text once again, and you will see that right now cookies are specified as hello world. Now if you simply just perform the request without specifying the cookies, which is r equals s.get perform, single quotes, https http bin.org/cookies, press here enter, and if you now print r.text, you will see that the cookies will be an actual empty thing, so we will not have anything specified within the cookie brackets. Now if you want to manually add cookies to your session, you can use the cookie utility to manipulate session.cookies. Now sessions can also be used as context managers. For example, you can specify with requests.session open and close brackets as s, which is our usual variable for the session. So as s, then specify column, press here enter, s.get, and then you can specify which link you want, which is for example https://http bin.org/cookies/set/session cookie. I forgot a /session cookie /123456789, which is our cookie. Press here enter, press enter once again, and we can see we got the response 200, which means okay. Okay, so basically that would be about it for sessions. Now of course there are lots of other things to talk about with sessions, but this should be more than enough for now. Now let us take a look at the next thing, which is going to be the request and response object. So basically we saw how we can actually get the request, but we also saw how we can actually get the headers from our response. But what, for example, if we want to get the headers from our own request? Now, whenever a call is made to request.get, you are doing two major things. First of all, you are constructing a request object, which will be sent off to a server to request or query some resource. Second, a response object is generated once request gets a response back from the server. The response object contains all of the information returned by the server, and it also contains the request object you created originally. That's why we can also access our own header. So first of all, let us create a simple request. We know how to do that. So r equals request.get. And let us, for example, get the default Python page. So https ://python.org. Press here enter. Okay, so everything worked perfectly, and now to access the headers from the response, we can simply just type r.headers. And you will see these are all of the response headers that we received from the server. As we can see, server nginx, content type text/HTML, the encoding is UTF-8, we can see the connection keep alive, the cookie is strict transport security, okay, max age, include subdomains, and so on and so on. We got different things right here. But if we want to actually see our own headers that we sent to the actual server, we can do that just by simply specifying r.request.headers, which will prompt us with our own headers that we send to the server. As we can see right here, user agent is set to be equal to Python requests, which is true because we are running the actual request from the Python. We accept encoding, JZip, deflate, connection keep alive, and that is basically all about our own requests. Now, whenever you actually receive a response object from the API call or session call, the request attribute is actually the prepared request that was used. Now, in some cases, you may wish to do some extra work to the body or headers on anything really before sending a request. So maybe you want to moderate your own request before you actually send it to the server. You want to moderate your own headers before you actually send them to the server. Well, you can actually do that. Now, let us take a look at some of the example. Let me just restart this real quick. Idle, open it up. Let us import from requests, let us import request and session, okay? And let us create the session object, which we know how to create by now. And we can create the request variable to be equal to request. We want to request the post to the URL. Basically, the URL can be anything you really want. Now, URL and then comma, you want to specify the data to be equal to data and the headers to be equal to headers. Now, of course, you can actually change the headers if you want to. You can delete special headers if you want to. Let me just press here enter. Yeah, it says URL is not defined because we didn't post any URL. But in order to actually delete the headers, you can simply just type, now, for example, delete. First of all, pardon me, we need to create the actual prepared of the request object, which we can do just by specifying prepped equals request dot prepare, if I'm not mistaken. Request is not defined. Yeah, request is not defined because we actually didn't specify any URL. Let us specify first of all a URL. Let me paste this, and instead of URL, I will simply just type https://python.org. Press here enter. Yeah, data is not defined. Let me just switch this up. Let me delete these two values for now on. How did I copy the URL thing? Doesn't even matter. I will just copy it one more time, and I will delete these two values. Press here enter. Request sent successfully. And now the prepared request, which we will specify as prepped, so prepped equals request.prepare. Press here enter. And now, let's say, for example, let me just type here prepped. You will see prepared request. Now, let me see if the prepped.text is a thing. Yeah, it doesn't have the attribute text. Okay, doesn't even matter. But if we want to, we can simply just do something with the header, such as delete the content type header, for example. So you can do that just by simply specifying delete prepped.headers. And in between the square brackets, you can simply specify which part of the header you want to delete. In our case, let's say we want to delete content type. Press here enter. Key error, content type. Let me just see what the error is. Let us first of all try to add something to the prepped body. We can do that just by simply specifying hello world. Press here enter, and let's right now try to delete content type. Okay, never mind. This doesn't want to work for some reason. It doesn't even matter. Basically, let us see how we can actually modify the headers by ourselves on the other way, because for some reason modifying it like this doesn't want to work. I will just check it out real quick if this other way will work. So we will import, or from requests, we will import request and session. Let us define the s to be equal to session, just for future example, and let us create a request with our own actual header. So request equals request. Let's perform the get request. Get request onto the https python.org, and let's add the headers to be equal to, I actually pressed enter before I should, so let me just type here headers equal. Now let's say, for example, let's say we specify connection instead of keep alive. Let's type not alive. Press here enter, and now let us send the request once again. So request, specify right here that it is a get request indeed, comma, then specify the link that we want to, which is https://python.org, and then comma, and we'll simply specify that headers equals to headers. Press here enter, we can see that the request has passed. Now if we just type here request.request.headers, let me just see right here, request, or what was it? Was it request.headers? Yeah, never mind, let's just type here request.text. Oh yeah, that is because we are actually using the request function. It doesn't really work like that, but we did successfully manage to actually change the headers to our own headers. You remember once we actually checked out our own headers with the request.headers function, we saw that the connection was set to be keep alive. And right now we sent the actual request with the headers equal to our own headers, and all we actually changed was the connection to be changed from keep alive to not alive. So basically, that is something you can do as well. Now, of course, you don't really need to change that one. If you don't want to, you can simply change the server, or, pardon me, not the server, in the actual request. You can actually change the URL, you can change the data if you want to, just by simply adding right here data equals and then specifying your own data if you need to. And basically you can change anything you want. So play around with the headers if you want to, and we will continue coding in the next lecture. So hope I see you there, and take care. Bye. Hello everybody and welcome back, and right now let us continue with our advanced usage of the requests library. Now what we did in the previous video is we saw some of the examples of using session and cookies. We saw how we can actually set our own cookies by the default on that http://bin.org page. We also saw how we can send different authentications. We saw how we can actually change some of the contents of our request headers, and also how we can print the response and the request headers out. Okay, so right now what we're going to do is we're going to take a look at the SSL certification. So right now we are going to open up our idle, open it up, and basically the requests library verifies SSL certificates for HTTPS requests. Just simply the same way as the web browser does that. By the default, the SSL verification is enabled, and the requests will throw an SSL error if it is unable to verify the certificate. So simple as that. Let me just import my requests right here. Press here enter, and let's say you, for example, type requests.get, and you specify this page, https google.com, or not google.com, let's go facebook.com. Press here enter, and we will get a response 200, which means that the page has been loaded successfully. Now, let's say, for example, right now we get this page, .get https request p.in. Press here enter, wait a few seconds. For some reason it is lagging out right here, but doesn't even matter. What matters is that this page does not have an actual certificate enabled. Let me just see right here. What did we get as an error? Max retries connected with caused by new connection error. Okay, it doesn't even matter. What we're going to do is we're going to try to verify with our own request the SL certificate. So let me just restart this. Because of this error, we will simply just import requests once again. And what we're going to do is we're going to specify, instead of the URL, or besides the URL, we're also going to specify the verify option, which is going to have a directory where the path, where the certificate is, where the SL certificate is. So right now, requests.get, and let's say, for example, we want to go to https://github.com, comma, and then you simply just specify verify, and you need to specify the path to the actual certificate, which is this one, comma, single quote, and then /path/to, and then /cert file. Press here enter. Could not find a suitable TLS certificate bundle, invalid path. Let me just see. Cert file. Yeah, okay, so it probably isn't at this current path, but once you actually know where the certificate is, you can simply just check the verification with this actual variable right here, or should I say it argument. Simply just specify the path to the directory where your certificate file is, and the requests library will simply perform the check by itself. Now, you can also do it the other way, which is simply just creating the session object, which we did in the previous video. So as equals requests.session, press here enter, we created a session object, and you can simply just specify as.verify, and then in the brackets, or doesn't have to be in the brackets, you press here equal, and then single quote, and then /path/to/certificate. Now, of course, this basically path is optional. You don't really need to specify it like this. In most of the websites, it will be different path. But let's now see how we can actually disable the verification in our own request. Now, the list of the trusted certificates can also be specified through the request CA bundle environment variable, which we don't really need to take a look at that. But what we should look at is that the request can also ignore verifying the SL certificate if you set this verify variable right here, either here or either here, if we set it to false. So if I just specify requests.get, and I simply specify http / and then some website, and then comma, and I specify right after it that the verify should be equal to false. Then it will not go through the directories, it will not try to find the actual SL certificate, it will simply give us the response OK, and it will load the page. Now, by the default, this verify variable is set to true, but you can change it, as we saw right here, if you for some reason don't really want to actually check for the SL certificate. Now, you can also specify a local certificate to use as a client-side certificate, basically as a single file containing the private key and the certificate itself, or as a tuple of both files. Now, how do we do that? Well, I currently don't have a file like that, but I will show you how the syntax goes. Simply you just specify requests.get, And as usual, the first argument will always be the website, so specify https://facebook.com. And right after it, you want to specify the cert equals open and close normal brackets, and then you type here double quote and /path/client.cert. Well, let's say we name it like that. It doesn't have to be client.cert, but right after it you press here comma, and the next thing is the key. So you specify the key right after the client. Let's say it is something like that. It is called something like this. So /path, /path/client key. Okay, so basically this would be the syntax for that. Of course, it says it will not find the TLS certificate file, invalid path /path/client cert, because I don't have it on my current PC. That's why it gives us an error. Now, of course, another way, as we saw right here, you can do that through the session as well. So s equals requests.session. We always create the session object first, and then s.cert equals, and then specify /path/client.cert. Okay, so basically you can do that as well if you want to, like this. Now, if you specify a wrong path or invalid path, you'll get an SSL error. Now, basically we saw right here that right here we could not find suitable TLS certificate bundle, and as well right here we couldn't find the TLS certificate file, invalid path. This is the mostly normal error that you will receive if you don't have the actual certificate, but you can also receive the SSL error, which will, for example, say error number and then something SSL. Basically, it will be a different error than this one. Just so you know, the errors will not be the same. Now, let us take a look at something called body content workflow. Now, by the default, when you make a request, the body of a response is downloaded immediately. So once you make a GET request, you will download the body of the response right away. Now, you can override this behavior and defer downloading the response body until you access the response content attribute with the stream parameter. So basically, it will not store the body until you actually access it or want to access it with the response.content attribute. But let me just restart my idle right here. We got too many errors to actually deal with, and we will simply just import requests, and I will show you how you can actually specify the stream parameter in the actual request. So you have a URL, let's say the URL is https://twitter.com. This is our URL, and we want to perform the request, which we will store in the R variable. So requests.get onto the URL, and then we need to set the stream to be equal to true. Now, at this point, only the response headers have been downloaded and the connection remains open. Now, hence allowing us to make a content retrieval conditional, which we can do if we want to. For example, you can simply just specify an if condition like this: if integer of the r.headers, and we want to see whether the actual length of the page or the page is big enough, or we actually want to see how big the page is, and we can simply do that just by accessing the response headers, the content length parameter from the response headers, which actually stores the size of the page in bytes, pardon me, and then we need to actually call that parameter right here, which is the content length. We talked about it before. It is stored in the headers themselves. And we simply want to specify, for example, it is smaller or larger. Let me just find where the actual smaller or lesser sign. Okay, so here it is. Smaller than 2_long. Press here 2 dots, and then right here we simply can specify that the content will be equal to r.content print content, for example. press here enter, and it will say too long is not defined, because of course we don't really have that variable, the too underscore long. You can set to be equal to as many bytes as you want to. I just showed you here the actual example where if the page is smaller than the desired amounts of bytes in the actual page, you can store that into a content variable and then print it afterwards. Now you can simply just access it just like this, r.content, press here enter, and it will say squeeze text 2306 lines, which we already saw before. That's why we will not really print it, because it will actually make our idle lag out. Okay. Now there are also different things you can do, such as streaming uploads, keep alive. Now streaming uploads basically is request supporting streaming uploads. They will allow you to send large streams or files without reading them into memory. Now, in order to do that, basically simply provide a file-like object for your body. So, for example, you open and then specify right here somebody. Doesn't even matter, we don't really have it, but if you had it, you can specify the name with the name right here, and then you want to read it as bytes. Close the brackets, specify it as f. This is a simple example of opening a file. It is rather simple, or the same, should I say, and you will simply just perform the request right after it. So request.post, and you want to actually add to that body something like, or to a certain URL. We will just specify URL variable right here, so we don't really type some URL, and you want to set the data to send to this actual URL to be equal to f. As we can see right here, we opened this body for reading bytes as f, and then we send the actual post request to a certain URL with the same data, or with the data specified to be f. Okay, let me press here enter. Of course, no such file or directory, somebody. Doesn't even matter. Now, another thing that you can do with the requests is that basically requests support chunk transfer encoding for outgoing and incoming requests. Now, to actually send a chunk encoded request, simply provide a generator, or basically any iterator without length for your body. So let's say we have a function generate. We call a function like that, and all this function does is it yields these two strings, hi and yield there. So this is our entire function. Let's say what happens once we actually call it. It will say generated object at this actual address. Okay, and now if you want to perform the actual request with this actual data, you can simply just specify requests dot post. Let's say we are running a post request to some actual file. So let's say https facebook.com, doesn't even matter. Specify any URL you want, and you specify that the data that should be sent is equal to the generate function. Memory, a bytes like object is required, not a string. Yeah, that probably has something to do with the actual link itself. Of course, it will not work right here. As it says right here, you can check it out at memory view. A bytes like object is required, not string. Okay, of course, but this is something that will work sometimes, so make sure to keep that in mind as well if you want to send the chunk encoded requests. So this is the way to do it. Okay, but this is also some of the not that important parts for those of you who do not want to actually study the web development. This is not something that you're interested in. This is just some of the more advanced stuff that you can do with Python regarding the requests library. So let me just restart this once again. Now, another thing that you can actually do is you can simply create your custom authentication with the requests library. Now, requests allows you to specify your own authentication mechanism, whether you have it or not. You can create it. Basically, any callable which is passed as the authentication argument to a request method will have the opportunity to modify the request before it is sent out. Now, authentication implementations are subclasses of auth base, which we will see how we can actually import. Now, from the requests library, we will import auth base. They're very easy to define, and basically the request provides two common authentication scheme implementations in requests, such as HTTP basic authentication and HTTP digest authentication. Now, let's see how we can actually do that. So simply, in order to just import the auth base, which will allow us to actually create our own authentication, you can simply just specify from requests.auth import auth base. Press here enter, you will see it went without any problem. And let's say we create a class which is going to be our own, or custom auth. Let's call it like that. It will take the elements of auth base, because the auth base is a class, or basically a parent class, so we can take its actual elements into our own class. We saw how we can do that in the actual studying of classes. We remember the parent classes, the inheritance of different objects from one class to another, and so on and so on. Now, basically, what we want to do is we want to create the init function. So def init, it takes the self argument and the username argument. Press here enter, and then specify that the self.username will be equal to username. Now, this is any authentication related data right here. You can also specify password if you want to, but for now on, let's just stick with the username. Whoops, I closed it a little bit too early, so let us just go once again. Custom auth base, def init, self, comma username, two dots, and then self.username equals username. Press here enter, go one step back, and another function we need is the call function. We need to specify the self argument and R, which will allow us to actually modify and return our own request. Okay, and then R.headers, we want to simply add a header, which is going to be, for example, our custom auth. Let's call it like that, doesn't even matter. And all we need to do is specify the actual variable that holds the authentication, which in our case it is only a username. So if you had a password, you would also specify something for the password, but for now on we only have the username, and we want to return the actual response or the request. And then we can make the actual request with the request library by specifying requests.get. Let me just import requests in case it will not work with this thing. So we will just specify requests.get, and in between the brackets you simply specify the URL such as HTTP and then some random website. Of course, this will not work on a random website. This will only work if you have, for example, your own website. And right after it, you need to specify the auth parameter to be equal to your own authentication, and you specify it just by specifying the class name, which is custom auth, and in between the brackets you need to specify the actual username. As we can see, that is the only thing that we have for the authentication. You can simply specify admin, for example, doesn't even matter, and then after it close another bracket, and you can send this out, which will give us probably an error. Yeah, because it is not an HTTPS website, it doesn't really have any checks, so therefore we actually successfully sent this and got the response 200 OK. Now, basically, this is one of the ways that you can actually custom or define your custom authentication. Now, what we're going to do in the next video is we are going to take a look at the JSON library and also streaming requests. We're going to take a look at how we can set up our own proxies, how we can set up the socks, and so on and so on. So that would be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now we're going to continue with our requests. So what we did in the previous video is we saw some of the different examples of using actual requests, such as defining your custom authentication, such as, for example, posting multiple encoded files, such as basically chunk encoding requests. You remember that generate with the yield function that we send to the actual server. Well, right now what we're going to do is we're going to take a look at the JSON library and also streaming requests. Okay, so open up your idle right here. I will just navigate to my idle, and we will import two libraries. One of them is the JSON library and one of them is the request library. So just type here import JSON and import requests. Those are the two libraries that we will need. And we're simply going to create a GET request with specifying the stream parameter to be equal to true. So r equals requests.get, open and close normal brackets, specify the actual link, and we will go to the httpbin.org website. So just type here https httpbin.org/stream/20. And right after it, you need to specify the stream parameter to be equal to true. So stream equals true. Press here enter. We can see it executed correctly. And now we're going to use the iterlines function, where that function allows us to easily iterate over streaming APIs, such as the Twitter streaming API, for example. Now, it can only be used once we actually set the stream parameter to be equal to true, and then it will iterate over the response of the server with iterlines. Okay, so all we need to do is specify the actual for loop in order to read all of those lines. So for line in r.iterlines, iter_lines, open and close brackets, put column, press here enter. And now we are going to filter out keep alive and new line. So basically if line, so if line exists, we need to decode the actual line. So decoded line, decoded_line will be equal to line.decode. And the actual encoding that it is used is the UTF-8. So we'll specify to decode with the UTF-8. Make sure to specify it just like this. And all we want to do afterwards is we want to print the decoded line, but we need to use the JSON.loads function onto it first. So in order to do that, we will just simply use a function within a function. So print, and in there we will specify JSON loads. And what we want to do with the JSON loads is we want to actually load the decoded_line. Press here enter, and you will see all of the lines that we were able to get. As we can see right here, those are our headers. As we can see, the Python requests is where the actual request is coming from. The host that we want to visit is httpbin.org. This is the IP address right here. We can see accept encoding is enabled, JZip. Let me just find another R agent. Okay, the R agent is from where are the actual requests coming from, and we already saw those are Python requests. So we successfully were able to decode with the UTF-8 and also print the JSON loads or the JSON format of the decoded line. Now, when we are using the decoded Unicode to be equal to true, with this actual function iterlines or itercontent, because that function also exists, you will want to provide a fallback encoding in the event that this server doesn't provide one. So for example, we can do something like this. So let me just restart this real quick. Open up the idle, import JSON and import requests. And we will perform the actual request to the same website or the same page. So r equals requests.get. And there we will specify the same website. So https /httpbin.org/stream/20. And comma stream equals to true, because we know that we must have this in order to be able to perform the iterlines function. Press here enter, we perform the get request successfully, and all we want to do is check for the encoding. And in order to check for the encoding, we can access the encoding parameter with the if statement. So if r.encoding, and we want to see if there is anything, so is none. If the encoding is none, what we want to do is we want to set the encoding to be equal to UTF-8. So in order to do that, we can simply just type here if r encoding is none, then r.encoding is equal to UTF-8. Once you specify that, press here enter, press enter once again, and right now we can actually continue with the similar thing that we did in the previous actual example, which is for line in r.iter_lines. We will specify the code underscore Unicode to be equal to true. Also, don't forget the column at the end because we are using the for loop. Press here enter, and now we check for the line. So if line, then we want to print the JSON data of that line. So JSON underscore, or pardon me, dot loads from the line. And you will see that we get printed out the exact same thing. Now, and one warning that you might want to consider is that the iter lines is not retrent safe. Basically, calling this method multiple times can cause some of the received data to actually get lost or to be lost. Now, in case you need to call it from multiple places, use the resulting iterator object instead. Now, basically, what I mean by that is that you want to first save the first line for later, or you will just skip it, and then afterwards you want to enter the for loop. Okay? And basically that would be all about the actual JSON library that we'll use in order to actually print our own request in the JSON format. We also use the encoding. We also use the new function that we haven't encountered before, which is this iterLines function. And right now what we're going to do is we're going to take a look at using proxies in the actual Python requests library. So go right here. If you need to use a proxy, you can configure individual requests with the proxies argument to any request method. So all we need to do is first of all import requests, and you need to specify your own proxies. It is rather simple. So proxies can be equal, and then right here specify for the HTTP and HTTPS. So let's say HTTP. And you can simply just add any proxy you want. For example, HTTP, column / and then you specify the IP address that you want to use for the proxy. It doesn't even matter. Now, if you have one, specify it. If you don't have one, you don't need to specify it. And also HTTPS, you can set the same thing right here. Doesn't even matter, just type some IP address of your actual proxies, and then let me just type right here my router's IP address. Press here enter. These are our proxies. Of course, I just use my router, and if you have a proxy, you use that one instead. And all you need to do afterwards is simply just specify requests.get and specify HTTP some website with the parameter proxies to be equal to your specified proxies that you specified upwards. Press here enter, and you get the response 401. Now that response 401 is because of my proxy, so don't really worry about that. You can also configure proxies by setting the environment variables HTTP proxy and HTTPS proxy. So basically you can set the variable, for example, HTTP_proxy, which is defined like this. And then you simply just specify the same link that you specified right here. Okay? You can do the same thing for the actual HTTPS, just add S right here and specify your proxy. And then afterwards, all you need to do is just perform a simple GET request without even specifying the proxies right there in the brackets. Okay? So that is another usage of the proxy. Now, if you want to also include the socks in addition to basic HTTP proxies, requests also can support using SOX protocol. This is an optional feature basically that requires that additional third-party libraries to be installed before we actually use them. Okay? Now you can get the actual dependencies for this feature from pip. Now, our usual pip, we need to open up our command prompt, navigate to our Python 3 scripts library where we can actually access pip. So cd app data, cd local, cd programs. Let me just see where it is. cd python, cd python 37 and cd scripts. There, I will clear the screen. There we can actually install the required requests or SOX library. In order to do that, you can simply specify pip install requests, and after request you open and close the square brackets, and in between the square brackets you specify SOX. Press here enter, and what pip will do is it will install the desired library for you. Okay, as it says right here, successfully installed PySOX. Now once you install those dependencies, using a SOX proxy is just as easy as using the HTTP one. So simply just specify, the syntax would look something like this. Instead of specifying proxies like this right here, you can specify them with using SOX, something like this. So proxies equal, open and close big brackets, and then specify in the dictionary like format, so HTTP, then another single quote, SOX5, because SOX5 is mostly what you're going to use, then user, column pass, at host, and then column port. Now that you also specify for the HTTPS, so you can do something like that, and then HTTPS proxy would be equal, or would belong to the SOX5, column / user, column pass, at host, and then column port. Basically, this would be something, this would be how you would define the actual proxies using the shim SOX5. And this SOX5 actually causes the DNS resolution to happen on the client rather than on the proxy server. Okay, so basically that would be about it for the actual proxies. Now, what we actually want to take a look at as well is the HTTP verbs. Now, requests provide access to almost the full range of HTTP verbs, such as get, options, head, post, put, patch, and delete. We only saw the get and the post by now. Now, we will begin with the verb most commonly used, which is get HTTP. Get is a method that returns a resource from a given URL. We already know that. Now, as a result, it is a verb you ought to use when attempting to retrieve data from a web location. An example of usage would be attempting to get information about a specific page from GitHub, let's say. Suppose we wanted to actually create a request, we would do it simply just like this. So let me just show you. First of all, we need to import the actual requests. We already saw how we can do that, import requests, and then you simply just create the requests.get. Now we didn't really need to import it right here because we already did import it right here, but doesn't even matter. And then you would simply just specify the URL that you want to get. Okay? Now, you can also confirm whether a certain page responded correctly. So let us create an actual request, so request.get, and then specify https twitter.com. Press here enter. We perform the request, and we should now confirm whether the Twitter responded correctly. Now, if it has, we want to work out what type of content it is. Now, we can do that by simply specifying an if statement that will say if r.statuscode or status_code equals to requests.codes.ok. Press here enter, and if it is equal, then we'll print from the response headers, we'll print the actual content type parameters of content dash type. Press here enter, and we will see text HTML charset UTF-8, and we know that the encoding is UTF-8. Okay, now, so we know that by now, we know that the actual page is HTML. Now, let's say we also want to get a request to the actual GitHub, so request.get, in between the brackets, we'll specify HTTPS column //api.github.com. Press here enter, request performed successfully, and we want to print the r.headers content type. Press here enter, and we get a similar response just right here. We can see that the encoding is UTF-8, but the application is JSON. So now, right now we know that the GitHub returns JSON data. So right now we can use the r.json method to parse it into Python objects. So you can specify something like this: data will be equal to r.json. Press here enter right here, and you can simply just print, because the JSON data format is actually really similar to the actual Python dictionaries. You can simply just print data.keys. We know that there are keys in the Python dictionary. Press here enter, and you will see a bunch of the results right here, which are the actual keys. Now we can also print if we are looking for something. Let's say we want to print open and close brackets, then print data, and in these square brackets we can specify that it is Unicode, then basically specify user_search_URL. What I actually specified right here is just the last example in the keys that we specified with this function. I just typed the last example. You can use any other example you want. So let's say we take a different one, such as, for example, team_URL. Press here enter, and you will see its link. Okay, you can also try different ones if you want to, but that would be basically about it for now. Now, the next thing that we can take a look at is the options verb to see what kinds of HTTP methods are supported on the URL we just used. So basically, for example, let's say verbs equal requests dot options, which is another HTTP word, and we will simply specify r.url, which is the link that we simply searched. Press here enter, and verbs.statuscode should return a 500. Oops. Oh, okay. The status code returned 204. Basically, what this actually means, or what I think it means, is that the actual GitHub doesn't really implement the options method in it, and therefore we can't really use it. If they did enable it, however, we should be able to actually get back the available options that we can use on a certain website. So let's try a different one, such as, for example, verbs equal requests dot options, and we'll specify this URL, so HTTP, and then this one. Press here enter. Okay, we perform the actual request, and let's see, verbs.headers, we will access the headers as before, and then we will simply just type here allow. Or let's try with the verb.statuscode for some reason. Okay, verbs.statuscode 200. Okay, so we got the 200. Let me just try verbs.headers. Okay, so these are our actual headers. Let me just see where the actual response is. Weird, it's not here. Well, doesn't even matter. That's how you can actually access the options. Therefore, you need to use the verbs.headers allow. Let me just check it out. Self.start. Yeah, never mind. Okay, now the next thing that we're going to look at, this options thing actually doesn't really matter that much. I thought that with this actual function we can actually retrieve our available options with the certain website, but it looks like we can't. But what we can do is we can simply perform the get and post request. We know that those two actually work every time, but that would be about it for the actual basic HTTP verbs. Now you can try different ones as well if you want to, but also another thing that you should know is about the custom verbs. Now from time to time you may be working with a server that for whatever reason, allows use or even requires use of HTTP verbs not covered above. Which I mean is we not covered the get, the post, the options. One example of this would be the mkey call method some web dev servers use. Basically those actual can also be used with the request library. These make use of the built-in request method. For example, let's say we have r equal requests.request, and then you would simply specify if the actual server uses, you would specify mk call, and then comma URL, and then the data equals data if there is any data to actually send to the server. That is the syntax, so that is also something you can do. And basically that would be about it for this tutorial. Now we took a look at a lot of stuff actually. We took a look at the different verbs that the HTTP protocols use. We took a look at the encoding. We changed the encoding. We also took a look at the JSON library and also printing the data in JSON format. So that would be about it for this actual request library, and we will continue coding in the next section. So hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And right now we're going to enter something called socket programming. Now basically that belongs to the network programming part, and what we're going to do is we're going to actually try to create a simple server and client side code which will be ran on two different PCs, or in our case we can run it from the same PC, so we can actually just check whether it works or not. Now in order to run it on the same PC, we will use the local host IP address, which is 127.0.0.1. We can specify any port we actually want as long as that port is not in use. Now of course, if you have multiple PCs that you want to test this on, feel free to actually change the IP address to the IP address of the server and then perform the connection from one to another PC. Okay, so first of all, what are sockets? Well, sockets are the endpoints of a bidirectional communication channel. Now, sockets may communicate within a process, between processes, on the same machine, or between processes on different continents if that's what you want. Sockets may be implemented over a number of different channel types, now Unix domain sockets, TCP, UDP, and so on and so on. The socket library provides specific classes for handling the common transports as well as generic interface for handling the rest. Okay, so basically Python provides two levels of access to the network services, and at the low level you can access the basic socket support in the underlying operating system. That basically allows you to implement clients and servers for both connection-oriented and connectionless protocols. Now, connection-oriented is referring to the actual TCP protocol, which actually requires a three-way handshake in order to be able to perform it. And the connectionless protocol is mostly referring to the UDP protocol, which is basically just sending a stream of data without actually wondering whether the data came whole, untagged, or basically whether it came at all into the desired machine. Okay? Now, Python also has libraries that will provide you with a higher level access to specific application level network protocols such as FTP, HTTP, and so on and so on. Now, but in this section right here, we're going to cover the understanding of the most famous concept in networking, which is a low-level socket programming. That is the basics of the internet themselves. And what we're going to do right now is we're going to take a look at the basic example or a picture of a server and a client. Now what I mean by that is, let me open it right here, is we have two things. One of them is the server and one of them is the client. And this right here are the functions that we need to use in order to perform the connection between each one. The server will be desired to actually create the socket object first. Once it creates the socket object, that socket object needs to take two arguments, and one of those is the actual the actual IP address, and the other one is the port. That's where the bind function comes in use. So basically what we will do is we will bind those two. We will bind the IP address of our own machine that we are listening on, and we will bind the port that we are accepting connections on. as it says right here, this is server creating listening socket, and then it performs the listen function that is inbuilt in the socket library in Python. What this listen function will do is it will listen for the incoming connections, and as soon as the connection comes, the accept function will be called, accepting the connection from the client and therefore establishing the connection via three-way handshake or via TCP protocol. As we can see right here, in the meantime, at the client-side code, the socket object has been created. We have a socket descriptor written to the memory, and therefore we call the connect function, which is going to simply connect to our server. Now, keep in mind that the server and client can just simply be two different machines. You can simply just have two laptops and just pretend that one of those laptops is server and the other one will be a client that wants to connect to that server. Basically, the same thing is with websites. You are simply a client accessing this server, which is a website. So once you actually perform the connect function, the accept function will be called right here. And as I said, it will establish a three-way handshake or a TCP connection. As soon as you establish it, you can simply just send the data and receive data between two PCs with the send and receive command. As we can see, the send command from the client will be client sending data and server receiving data. Now here we need to keep in mind that we don't actually put both the client and the server to send data at the same time or to try to receive data at the same time, because then our programs will crash because nobody is receiving anything and they're both listening for the data at the same time. So that is also something that we need to keep in mind. So the receive and the receive should never go one with another. First of all, we send data and the server receives data. Then if we want to, we can change that and call the send function from the server, while as the receive function will be called at the client-side code, which means that the server right now is sending the data and the client is receiving the data with the receive command. Once it actually sends all of those data, and once they want to terminate the connection, they can simply do so, and afterwards we need to close the socket object, and we do that with the close function right here, as we can see right here. So the close function is something that we called at the end of the actual connection. Now, there are a few actual terms that we need to take a look at right here in the socket programming. One of those is the domain. Now, the domain, basically the family of protocols that is used as a transport mechanism. These values are constants such as, let's say, AF-INET, which is the IPv4, the PF-INET, PF-UNIX, PF-X25, and so on and so on. Now, the type of the communications between the two endpoints typically SOC stream, or which means that the actual connection is via TCP handshake or connection-oriented protocol, and SOC DGRAM, which is for the connectionless protocols, or basically it stands for UDP. Now those are the two that you will most likely encounter all the time. And the next thing is the protocol, which will typically be 0. Now this may be used to identify a variant of a protocol within a domain and type. Okay? The next thing that we need to remember is the actual host name, the identifier of a network interface, basically a string which can be a host name, a dotted quad address, which means that you are simply specifying an IP address or IPv4 address to this specific server, or an IPv6 address in colon, and possibly dot if you want to. A string broadcast will specify an ADDR underscore broadcast address, a zero-length string which identifies in ADDR any, or an integer interpreted as a binary address in host byte order. Okay, and the last thing that we need to take a look at is the actual port. Now, each server has its IP address, of course, and once you try to connect to that server, you need to specify to which port are you connecting. Now, there are multiple ports, over 65,000, and therefore, if you simply just specify the IP address, the programs will not know on which port to listen on. So, for example, if you simply specify the server to listen on port 200, and then you, from the client, don't specify a port, and it sends to some random port 300, the server will not receive connection because it was listening on a different port. So, each server listens for clients calling on one or more ports if you want to. A port may be a fixed port number, a string containing a port number, or the name of a certain servers running on that port. Okay? Now, we're going to start off by actually creating the socket module or the socket object, pardon me. In the next tutorial, this short tutorial was just about me explaining actually how we can do certain things, how does the server and the client actually work. We can see a visual representation right here of all of the functions that we are going to use. We also discussed some of the things that are important, such as IP addresses, ports, domains, protocols, connectionless, connection-oriented protocols. Now those are also some of the important things, whether you're TCP or UDP server and client. And we're going to continue coding, or we're going to start coding with the socket library in the next tutorial. So hope I see you there and take care. Bye. Hello everybody and welcome back to this tutorial. And right now what we're going to do is we're going to start with this socket module. Now first of all, at the beginning we need to import our socket object, our socket library. So that is at least easy to do. Just open up your idle right here. Open it up, and in order to actually use the socket library, all you need to do is simply just type import socket. The library is already pre-installed in Python, therefore we don't really need to use pip in order to install it. Now, to create a socket, you must use the socket.socket function available in the socket module. Now this has a general syntax and it will most likely always be the same, and the syntax looks something like this. So as equals socket.socket. Then, first of all, we will specify the socket family, which we'll talk about in just a second. So first of all, socket family, then socket underscore type, and then the protocol, which will be by default set to be equal to 0. Okay, so first of all, let's talk about all of these three values. The first one is the socket family. Now, this is either going to be AF Unix or AF inet. Now, in order to specify that, you simply need to type here socket.af underscore inet, because that is the actual socket family that we are going to access, and the socket type will most likely be oriented to the type of the connection that you want to, whether it is a TCP or UDP connection. And by that I mean whether it is a connection oriented connection which requires a three-way handshake such as TCP protocol, or whether it is a connectionless connection or connectionless type of actual socket type, and therefore we need to specify sock underscore dgram. But we want to actually have a three-way handshake. We want a connection oriented connection, so right here we'll specify socket.sock underscore stream. And this last part, which is the actual protocol, which I set here to be equal to 0 for one reason, is because this is usually left out and the default actual value of the protocol is equal to 0. Now, of course, if you want to, you can simply change that, but for now on we don't really need it, therefore we are going to set it to be equal to 0 or simply just leave it out. Once you press your enter, you successfully created your socket object that belongs to the socket.af inet socket family, which means that this is going to be an IPv4 address or IPv4 IP address, and we set the socket.sock stream, which means that we're going to have a TCP connection. Okay, now once you have the socket object, then you can use the required functions to create your client or server program. Now, following the actual image that we saw in the previous video, first of all, if we want to create the actual server code, we will simply just specify the bind function. Now, if you remember, the bind function will take two arguments. One of those arguments will be the actual IP address of our own server, so our own IP address, and the other one will be the actual port number that we want to listen on. Now, in order to check out your IP address, if you want to use this over your own local network, you can simply just type cmd. Once it opens up, first of all, make sure that you are connected to the internet, as I am right here. As you can see, network internet access, and all you need to do is type the command ipconfig. Now, what you are searching for in the result of the ipconfig is the actual IPv4 address, which is right here. And my current IPv4 address is 192.168.1.4. Okay, so just remember this IP address or copy it if you want to. Let us copy it. Okay, we copied it, even though I did remember it. You can leave it right here if you don't want to close it, and then you will call the bind function, which we simply just called s.bind. And the IP address has to be specified in between the quotes. So make sure to open double or single quotes, and also make sure that you open and close the actual brackets twice. And what I mean by that is I will show you just in a second. What you actually want to create right here is something like this. Let me just delete the single quotes. So open, and double closed single brackets. Okay? Pardon me, not single brackets, just simply brackets, and then open single quotes and paste the actual IP address. And somehow it managed to paste it outside of the single quotes. It doesn't really matter, we will fix it. And then comma, specify the port number, which can be any number you want. I usually pick a high number because I know that most likely that port will not be used by any other application or program. So I will just simply specify 50,005 as a port. Press here enter, and we successfully coded the bind function, binding our own IP address as we are the server right here. We're coding the server-side code, and we also binded the port 50,005. The next thing we want to do is we will call the listen function that is going to set up and start our TCP listener. Now the listen function basically takes only one argument, and that actual argument is going to be the number of requests that you want to have in your server-side code. So simply just specify s.listen, and if you want to have, for example, 3 connections, you specify here 3. If you want to have, for example, 5 connections, you simply just specify here 5. Okay? Once you do that, let me just see right here, Windows Defender Firewall has blocked some of the features of this app. Okay, we want to actually allow the access because we know that it's us that is actually running this. Therefore, we're simply just going to click allow access. And then the next thing is basically establishing the actual connection. Okay, then once you actually code this part, you need to go to the actual client-side code. So we will open another idle, because we need to have 2 idles open in order for this to work. Just imagine that each idle is a different PC. It will work exactly the same, just you will specify different IP addresses right here, whether you're actually making a connection that is going to be in your local area network or outside of the local area network over the internet. So right here, what we want to do is we want to first of all import a socket, and the part of the client-side code is going to be rather the same as the actual server-side code. Not all of it, but the first part where we actually create the socket object is exactly the same. So we want to create the same socket object because we're going to perform the connection one with another. So or let's differentiate them just by simply specifying here that the name will be sock and not s. So sock will be equal to socket.socket. And we simply specify that we want the IPv4 address and that we want the TCP protocol. So in order to do that, we can simply just type here socket.af_inet, comma, socket.sock_stream. As we can see, they're both exactly the same. Press here enter, and we created our socket object. The next thing we want to do is we can simply get the local machine name if we want to, so get host by name, which is not really something that you might need, especially if we know the IP address of our server, which is the IP address of my Windows 10 machine. We'll simply just specify only the port to be equal to the same port that you specified in the server-side code. Make sure that you don't really mistype the port, because then the connection will not work, as the client will try to connect to a different port. So both the IP address and the port have to be the same in the both programs. Okay, so the port is equal to 50,005. Yeah, it is equal to 50,005. And then afterwards, we can perform the connection to the host on the specified port. In order to do that, we call something similar to bind function, just this is reversed. So we call sock.connection, or connect, pardon me, not connection. And make sure that you once again open 2 two open brackets and two close brackets, and then you specify first argument, which is going to be the IP address, which is 192.168.1.4, and then you simply specify the port number, which is going to be the port variable, because we actually stored this number into this variable. Press your enter, and we actually did perform the connection. Or pardon me, we didn't perform the connection, I just noticed. We didn't perform it for one actual reason, and that reason is because we didn't really call the accept function into our server code. Now you will notice, let me just go right here, that if I specify s.accept, or pardon me, the s.accept function will return the two values. One of them will be the socket object, where it will be stored in the memory, and the other one will be the address of the client, which will be the client's IP address as well as the port from which they are connecting to. So what we want to do is we want to split those two variables by simply specifying client socket, comma, and then client address will be equal to s.accept. Okay, so simple as that. We'll press your enter, and let me just see right here. Okay, client address. Let me just print the client socket just to see. Client address. Okay, so we did receive a connection, as we can see right here. We managed to actually connect. You can see that the connection from the client came from a whole different port, as we can see right here. The port from which connection was initiated, or from which the client initiated the connection, is port 53408. And the port where we actually got the connection back is the port 50005. Right now, once we actually establish the connection, we can exchange different messages if we want to. You can simply just print something like right after the actual accept function worked, which means that we got the connection back. You can simply just type got a connection from, and then you can simply just type %s, oops, and then the %string from the client address. Now make sure that you add the string right here, because otherwise this will not get printed out. You will get an error. You need to convert the client address into a string. Okay, and right now let's see how we can actually create and send messages and receive them between these two programs. In order to do that, we have certain functions that we already looked at in the previous video, and those functions are receive and send. The receive functions, this method basically receives TCP message, and the send function, this method transmits TCP message. Okay, so let's try to actually send from the server to the client a hello message. So in order to do that, we can simply just type the client socket, because make sure that right now you're no longer going to type s.send in order to send the message to the client. You will use the client socket that we received once the accept function was called. As you can see, the client socket is stored in the client socket library, variable. Therefore, we need to call it right here. So client socket.send, and in between the brackets, all we need to specify is basically the message that we actually want to send. Now, first of all, before actually doing this, since we are actually using Python 3, we will need to encode the message, and then we will need to decode it once the actual client receives the message. In order to do that, we'll simply just use the UTF encoding. First of all, let us type here message to be equal to input, enter any message, press your enter, it asks us for message, and we will send to the client, hello, thanks for connecting. This is our message, press your enter, and in order to send this message variable, which contains this string right here, we need to encode it with the UTF-8. If you want to, you can use other encoder if you want. I will simply just use UTF-8, so message underscore encoded will be equal to message.encode, And in between the brackets, we'll specify UTF-8. Press here enter, and now we have the message encoded. And all we want to do is simply send this message. So in order to do that, you simply just type client socket.send, and in between the brackets, you simply specify what you want to send, and you want to send the message underscore encoded. Okay, but before you actually type here enter, you need to call the receive function onto the client-side code. Okay, so in order to actually receive an actual message on the client-side code, we need to call the receive function. So right here, we will type, for example, message will be equal to sock.receive, because we are receiving from our own socket object. We will simply just type here sock.receive, and this actual function, or the receive function, takes takes one argument, and that argument is the amount of bytes we want to receive. So if we specify right here 1024, this means that we don't want to receive more than 1024 bytes. So we'll just press here enter, and what you will notice right here is that the actual message basically hangs right here, or the receive function hangs right here, and basically the program will not continue executing until we actually receive some data to our client-side code. So you will notice, let me just make this smaller so we can see both windows at the same time. Let's make this big enough, okay. And if I right now press here enter, you can see we sent 29 bytes, and we can see that the program has continued executing, or basically this function is no longer hanging. If you just type your message, you will see hello, thanks for connecting, but you will see this B right here, which means that we actually need to decode this, and we can simply do that just by specifying message underscore decoded equals message.decode, and we want to decode the thing that we sent, and we sent it with the UTF-8 encoding. Therefore, message decoded, as you will see right here, will no longer have this B right here. It will just be a simple string. So don't forget that once you actually encode it in the Python 3, you also need to decode it, or pardon me, once you actually encoded it in the server-side code, you also need to decode it in the client-side code. As we can see right here, same goes if you want to perform the reverse action by client sending the message, we will see in just a second, and the server receiving the message, you need to perform the same action. So right here, once you actually receive the message, you can simply just type print message from server, and we will simply just concat message decoded, press here enter, and you will see message from server, hello, thanks for connecting. Then we can simply just type message underscore back will be equal to, let's say, input. Do you want to respond, pardon me, to this server? And then we'll leave the actual open thing so we can specify yes. Thank you for letting me connect. And then exclamation mark, press here enter, and we can see we created the message back, which stores this string. Now in order to send it, we need to perform the same text just in the reverse as we did before. So first of all, what we're going to do is we'll call the receive function to the server, which is expecting an actual answer. In order to do that, we will just type here client socket.receive. We want to receive 1024 bytes from the client socket, which means from this client only. Now, if you had multiple clients connected and you specify this right here, you will know this function will not stop if you receive a message from a different client. It will only stop if you receive a message from the client that you specify the client socket for, as we can see right here. Right now, all we need to do is encode this, so message underscore back underscore encoded. You will notice that right now we are encoding here and decoding here, while as in the previous example we were encoding here and decoding in the client side code. So message back encoded will be equal to message underscore back dot encode with this same encoder, which is going to be the UTF-8. And all we need to do is send this message. In order to do that, we simply just type sock.send, and we will send message underscore back underscore encoded. Press here enter. We can see that we received, or pardon me, we sent 38 bytes from the client-side code, and that this server received that message, just it still has this B, therefore we need to actually decode it in order to be able to print it as a string. So in order to do that, we can simply just type, oops, we didn't really store this in any string. Let me just repeat this code. Message back equals, and then we will just type here client socket.receive. Then we will send this same message once again. So we actually store it on the server side into a variable. As we can see right here, again 38 bytes sent. And right here, message back underscore decoded will be equal to message underscore back dot decode with the UTF-8. Press here enter. We can see it worked, and right now you can simply print response from the client, and then we will add plus message back underscore decoded. Press here enter, and you can see response from the client. Yes, thank you for letting me connect. Okay, so basically we saw how we can send and receive messages between server and client. And what we're going to do in the next video is we're going to create a server and client side code, and we're going to see how we can actually create a while true loop that is going to be able to send messages indefinitely between the server and client side without us actually interact with code, without it also having any other problems such as hanging out on the connection. If we, for example, mistype and specify both of those programs to receive an actual connection. So we're going to see how we can do that, and we're also going to see how we can send the messages indefinitely if we want to, and for example perform some different tasks from one PC on another PC. So that would be about it for this tutorial. Hope you enjoyed it, and I will hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now, as I said, what we're going to do is we're going to code a simple TCP server and TCP client that are going to be able to send messages indefinitely. Now what I mean by that is we're going to code a while true loop that is going to basically go between the send and receive functions on both sides. So let us open up our idle, and what we are going to do is we are first of all going to create a TCP server code simply just by going right here, new file, because we are going to write a file and save it onto your desktop. Okay, so go on to the save, go to the desktop and call it, for example, tcp_server.py. Press here enter. Now we have the actual server onto the desktop, as we can see right here. And right now, let us continue with our coding. So first of all, we're going to import two libraries. Both of those we actually used. One of them is, of course, the socket library. So we will import the socket, and we are going to import the datetime library. So we can actually use the time where we actually connected to the server, send messages, and so on and so on. So let us just type here from datetime, import datetime. So basically we are importing the datetime module or datetime class from the datetime module. And right now we can continue coding our server. So in the previous video we saw that we actually defined the IP address and the port within the function itself, within the bind function. And right now we're going to put those two values into a variable. So we'll just type here host, which is going to be our server IP address, or basically the IP address of our own machine. Because we are running this basically on the same machine, we are going to check out our IP address, go down here, specify CMD. Once the command prompt opens up, you simply just type your ipconfig, and the output will be stored in the IPv4 address parameter, as we can see right here. It might be different for you. Now, it will most likely start with these three values right here, but if it doesn't, don't worry, there are different formats of IPv4 addresses. This is a local IP address, so we will just simply remember this, which is 192.168.1.4, and then we will specify between the double quotes 192.168.1.4. Okay, the next actual variable that we want to have is the port number. So port will be equal to the actual port that we want. So in the previous video, what we did is we specify a port 50,005, and right now let's say we choose the port 6789, which is the port that we're going to use right now. And also let us take a look at the third actual variable, which is going to be the amount of bytes that we want to receive, or the maximum amount of bytes that we want to receive. So in order to do that, we can simply just type here max_size, which is going to be equal to 1024 bytes. So if we receive anything larger than that, our programs will most likely crash. Therefore, we set the maximum size to be equal to 1024 bytes. Okay, right after we defined all of our variables, we can simply print right here. So print starting the server at, and then we will simply just use time in order to specify the actual time that we started our server at, date time. And then we will use a function that we covered in the previous tutorials, which is the date time now. You can simply just find it right here. For some reason I can't really find it right here, but we will simply just call it just like that. We'll call the now function, which will print the current time of the running of the server, and then afterwards we can print that we are waiting for the incoming connection from client. Okay, so right after we print this, we can actually create the socket object and perform the byte function as well as the listen function. But let me just go right here. We will actually code it in between these two actual statements. So first of all, we will create the socket object right here. We'll call it sock. It will be equal to socket.socket. Now we already discussed this in the previous tutorial. All we need to specify right here is the AF_INET, which stands for the IPv4 connection, and we also need to specify sock_stream, which stands for connection oriented connection, or the TCP connection. So socket.socket and then socket.AF_INET as the first argument, and then socket.sock_stream as the second argument. So we actually set up our socket object. All we need to do is bind our ports, and we can do simply just by specifying sock.bind, open and close double brackets, remember, not single brackets, otherwise this will not work. And all we need to specify right here is the IP address and the port, and we can simply just specify them with the variable name, so host, port. Okay, and then we will print starting the server at date time now, which will print the current time. Then we will actually print waiting for the incoming connection, and then we will call the sock.listen function, which will listen for the incoming connections, and we will specify right here that we want to listen for 5 connections, okay? Even though we will only be accepting 1, but we will type here that we want to listen for 5 connections. And then afterwards we will simply just call the accept function, which, as you remember, it will store 2 values. One of the values will be the socket object for the client, and the other value will be the actual address, the IP address, and the port from which the client has connected to, or connected from. We can specify that by storing the values into different variables. First one will be the one that is going to store the socket object, and it is going to be called client. And the second one we will just call the ADDR, which stands for shortly address, and then we will put it to be equal to sock.accept. Okay, so this is all already something that we did in the previous tutorial, nothing really new for us. Let us save this before we actually continue, and we are going to right now, let me close this, I will open my idle, and we will open a new program, so new file. We will close this one as well. We will save it first of all, and we will save it onto the desktop. Make sure that you put them in the same directory, even though it doesn't really matter right here, but if you want to put them so you have them at one place. And we will call this one tcp_client.py. Save, And right now all we need to do is perform the actual connect function and creation of socket object in order to be connected to the server. But first of all, let us import socket, and let us also import datetime class from the datetime module. So from datetime, import datetime. We will set the host variable to be equal to the same IP address, so 192.168.1.4, and we will also set the port to be equal to the same port as we specified right here in the actual server-side code. So it is the port 6789, press here enter, and the max size will be equal to the same max size that we specified in the server-side code, so it will be 1024 bytes. Okay, so basically right now that we define the actual variables that we need, oops, I'm missing an equal sign right here. Okay, now it is good. And now we can print that the client is starting. Okay, so starting the client at, and then we will simply just add the datetime.now, which will print the current time of running of this program, and then we will create the socket object. Because we called it right here sock, we will simply just call here s, so s equals, I mean, you can call it the same name if you want to, as we did in the server-side code, but let's differentiate them and actually use a different name. So we'll just specify here as for socket object, and it will be equal to socket.af_inet, comma, socket.sock_stream. Okay, press here enter, and all we need to do, or all we're left to do in order to perform the connection between these two machines, we need to simply just type s.connect, open and close double brackets, so make sure that you open and close double brackets as we did in the byte function, and simply specify host, comma, port. Okay, so right after it we can save this, and let us actually try to run this. First of all, we will run this server, run. Let me first see if we saved it, so save, and then run module. You can see starting the server at this time right here, waiting for the incoming connection from client. And now this will hang right here because it is stuck at this line right here, waiting for someone to accept the connection. Now let me just go right here, find the actual window of the server, or pardon me, of the client, and put the server right here, so we can see both of those at the same time. And right now, as soon as we actually run the client, the programs, or the both programs, will close. So run module, we can see we actually ran the client, both of those programs have finished, as we can see, waiting for the incoming connection for client. It is no longer hanging at the connection, and here it printed out starting the client at this time, and it then closed the program. So we successfully were able to establish the connection, and right now what we want to do is we want to simply enter the while true loop in order to be able to receive and send messages. Okay, so first of all I will put these actual windows to be smaller so we can see them both. Just like this. Enlarge this one as well. Okay, and let us continue with our server-side code. So right now that we actually accepted the connection, let us enter the while true loop. We know how to do that. We simply just specify while true, and anything we execute right here will be executed indefinitely unless we actually close the program. So the first thing that we are going to receive, or that we are going to actually do, is, let's say that the data for the server, or in this case, in the previous case, the server actually sent the message first, but right now let's say that the server needs to receive the message as soon as the client connects. So in order for server to receive the message, we simply need to specify from which socket object are we receiving the message. And we want to receive the message from this socket object that we stored in the client variable, so we'll simply just specify client.receive, and the amount of bytes that we want to actually receive from the client is stored in the max size variable, so we'll just simply type here max_size. Okay, now that we did that, we need to actually decode this data right here, because the server actually sent and encode data. So we'll just simply type here print at, and then the actual time, so at datetime dot now, and then address, and the address, just to remind you, the address is an actual IP address of the client, also the port from which the client has performed the connection from. So what we will do is we will simply just print out right here at a certain time from this IP address and port this address said, and then we will just type here data.decode, and we will decode it with the UTF-8. Let me just put this right here so we can see everything. Okay, so press here enter, and basically once we actually type this, we will right away prompt into an actual input message. So we will just type here message to client is going to be equal to input enter message to client, and then we're going to send the encoded message. So first of all, we will encode it. Message to client encoded will be equal to message to client.encode with the UTF-8. So UTF-8 will specify it like this, and all we want to do is simply just type client.send .send, and we want to send the message to client encoded. So we are sending an encoded message, and as soon as we do that, we're going to go at the beginning of the while true loop, and we will go to the beginning, which is the data that is going to be received once again. As we can see, we are going to once again receive the data, print it right here, then go to the input message, and then we will once again send the message to the client. Okay, so right here, let us code right here the while true loop that is going to be correspondent, or that is going to fulfill this server-side while true loop the same way. So we'll just type here while true, and because the actual server was the first one to receive the message, then the client has to be the first one to actually send the message. So therefore we will just type here message to server equals input enter message to server. Simple as that. We will just prompt the user to send the message to server, and then we will send the encoded version of this message. So first of all, message underscore to underscore server underscore encoded will be equal to message to server dot encode, and we will of course once again encode it with the UTF. So simply just specify here UTF-8, and then we can send this message to the server and proceed to receiving the message from the server. So in order to send the message, we will simply just type here s.send, and then we will send this message. So message to server encoded. Okay, so right now this actual line right here is corresponding to this line right here. Let me just find it right here. Okay, and once it actually receives the message, it will print the message with this line, and then it will prompt the server for the input of the message to the client, and then we will send the message to the client. Therefore, right now here we need to receive the message. So the data will be equal to s.receive, and we want to receive everything of the max underscore size, which is 1024 bytes, and then we want to print the decoded version of this data. Okay, since the server side encoded and then sent, we right here need to decode it. So we will decode it just like this: print at and then at datetime.now someone or server replied with data.decode UTF-8. Okay, so we will print that, and basically that is the end of the while true loop for both the server and the client. Now at the end of the program we of course need to call the close function, so we will close the socket object right here, as well as we will close the socket object right here, so sock.close. But first of all, we'll just type here client.close and then sock.close. Right now, let us save both of these files. So click here, save. I will go right here and save this one as well. And first of all, we will run the server. So we will be stuck at this line right here. It will print these two values and it will be stuck right here until we run the actual client. Then it will enter the while true loop. So first of all, we run this. Oops. Run. As we can see, it ran the program. Right now, let me just close this. Right now, let's say we run this part, and you can see that we get prompted enter message to server. So we type here hello server, press here enter, and you can see that it says right here, just it actually split it up because we have a small screen. Let me just go right here. You can see if we enlarge this, it will say at this certain time, this date, this time, the actual IP address of 192.168.1.4 from the port 53543 said hello server. And then we get prompted back message to client. You will notice that this program still hasn't finished running because we're in the while true loop and waiting for the message. And we can type here hello client. Press here enter, and you will see that right now the client prints out at this time server replied with hello client. So what we have right here is a simple version of a chat program. So we can just type here how are you today server, and then it will get printed out at the server side of the code. Now note one thing is that these two programs can be ran from totally separate machines as long as you specify the correct IP addresses. Now it can also be ran from another continent to a different continent as long as you specify a different IP address and you perform the port forwarding, or you have some other actual program that will perform the port forwarding for you. Okay, for now on it will only work on the local network if you specify the local IP address which is given to you by your router. This IP address of course does not work to connect from outside of your network. So you can just type here I am fine, how about you, and you will see that we can exchange for as long as we want. But one thing you might notice right here is that we can't really close this program. There is no other way except keyboard interrupt, as we can see right here. Oops, right here, and then right here. Oops, what am I doing? Yeah, right here it can't really even perform the keyboard interrupt because we're actually in the receive function itself trying to receive the messages. Therefore, we need to do something about that so we can actually close the programs correctly. Now, in order to close the programs correctly, we can simply just write a simple if statement that is going to check for a specific message which will indicate the closing of the connection. And how we will do that is we will simply specify if a certain message was equal to, for example, exit, we will exit this while true loop, leading us to these two actual executions which will close the socket and close the connection. Okay, so right here, we'll simply just, after we receive the data, we'll simply just check if data dot decode UTF-8 equals to, let's say, Q. Let's say Q stands for quit, and if the actual client says Q, it means that they want to terminate the connection. Therefore, we will break out of this loop if that is the case. If that is not the case, we will print this and continue executing these other things, as well as going back to the beginning of the loop. Now we also need to perform the same thing right here. Let us just see where do we have to perform this. We have to perform it right after we receive the actual data. So right here, if the receiving, if data underscore dot decode UTF-8 is equal to Q, we want to break out of this loop as well, leading us to close the connection. So let me just check out right here. There are two parts where we need to implement this. We also need to implement it right here, because if you notice, let's say that the server is the one that actually sends the Q message. It will go through here. This will not be executed because the message was not Q, let's say. Then it will go through here and it will input a message of Q. Then we will send that to the actual server. And then we will go to the beginning of the while true loop. Then we will get stuck at this line because the server actually received this message of Q and it broke out of this while true loop, closing its program, and therefore we are going to be stuck right here without ever receiving anything back. So we need to double check everything, and by double check I mean right here, if message to client is equal. Now we are not using message to client encoded, we want to simply just check the raw string which is received from this statement right here. If the message to client is equal to Q, break out of the connection or break out of the while true loop. Now make sure that this statement is written after you send the actual message, because if this is Q and then right after it, once you specify Q to this message, you break out of the loop, it will never get sent to the client, and therefore the client then will not know whether it should terminate the connection or not. Okay, so same thing goes right here. Let me just see if the message to server equals to input, if the message to server encoded, message to server encode, then we send that. And then before we try to receive, we will just check if message to server is equal to Q. If it is, we will once again break out of the loop. So right now let us save these two programs. File, save, file, save. We will run the server first, run it, waiting for the incoming connection from the client. Okay, good. And then we run this one as well. Enter message to server. So right now let us first of all try to exchange a few messages. For example, hello. It gets printed out right here. Hello there. How are you today? Good. Doesn't even matter, we will just send good. Okay, then bye. And then this sends Q. Hello everybody, sorry but my actual PC crashed and now I had to restart it, and now we will continue from where we stopped. So basically we have our TCP server and TCP client. Let us open both of those codes right here. Oops, let me just open it with the edit with idle. Let's try to edit with idle to see what it will open up. Okay, so here is our good usual server-side code. Now we also need to open the TCP client, which is the client-side code, and right now let me just put them side by side so we can see both of them as we execute them. Now we just need to test out the actual Q option to see whether it does perform well. So all we need to do is just simply click run module onto the server. As we can see, the requested address is not valid in its context. Okay, well probably since I restarted the PC it did change the actual IP address, therefore I'm going to check out for the new IP address, which right now is 192.168.1.5. So let us change the IP address from 192.168.1.4, as we can see it's specified right here, to .1.5. So let's first of all go right here, press here 5, and do the same right here. Let's save both of the programs. Now make sure that even if you also get the same error, check out once again for your IP address, because it might have changed. If you don't have a static local IP address, it can change from time to time, and it will change from time to time, especially if you connect to a different network and then you try to run this program and you get an error. Always make sure that you have the correct IP address specified. Okay, so right now we will run the module. As we can see, there is no longer an error. We are running this, waiting for the incoming connection from the client. Let me just lower this so we can run this one as well. Run client, and now we have the connection opened. Okay, so now the server is waiting for the message. We specify here hello, it gets received back. We specify here hello back, and the client also gets the message back. Now let's say the client is the one that wants to quit the messages. The client can simply specify Q, and you can see both programs close without any errors. Now it goes both ways, so let us run once again both of them. So we can now specify that the server will try to quit the connection, and then they will both close once again. Run module right here. We specify hello from the client, hello, and let's say the server doesn't want to talk anymore and presses Q. You can see both actual programs terminate and close correctly. So that is something we wanted. Now that we got that out of the way, you can implement different things to these programs if you really want to. Such as, for example, if you want to execute something on the target machine, you want to create a file, you want something that is more SSH-like, for example, executing or navigating through different systems in the actual or on the actual different machine. Basically, once you log into SSH, you can execute different commands on a different machine that can be all around the globe. And right now, you can implement the same thing right here. So, in order to implement something like that, you would probably use something like the OS library. Now, we will not do that because there is no really point. We did cover the OS library in great detail. You know how to change directories, you know how to navigate with system through the OS library, you know how to check whether a file exists. You can implement all of that code in the while true loop. So the example would be something like if data that is received or data.decode UTF-8, and then we know that in the actual Python, let me just type right here, starts with, or is that the name of the actual function? Yeah, I'm not really sure if it is called like this, but you know that starts with function that we actually covered. You can use it, or you can simply just use something like this. If the first two characters from the data decode of the UTF-8 are equal to CD, then you can simply just os.change directory from the data.decode, and then in between the brackets we specify UTF-8, and then we specify that we want to change the actual directory to everything specified from third character onwards, or from second character onwards. Let me just see right here. Let's just leave it for third, because let me show you what I did right here. Let's say you want to change the directory on the different machine that you are actually using as a client. You type the command that looks something like this. So, for example, cd desktop stands for change desktop. This is the command. And what we did right here, first of all, don't actually forget to import the OS library, otherwise this will give you an error, because os.change directory doesn't really exist without the OS library. And let's say the client actually sends this message to the server. It wants to change the actual directory on the server. So it sends the messages that looks like this. What we do right here is we check if this message, if the first two characters of this message are equal to CD, as we can see right here. Then we will proceed to perform this stuff right here, which means if the CD is the first two characters, it means that the client wants to change the directory on the server. Then we proceed to change the directory to the actual environment or to the actual directory that is named from the third character of this message onwards. Because the first two characters will be CD, then the third character will be an empty character because you need to type a space, and everything after it will be the name of the directory that you want to change the directory to. Therefore, right here we specify from the third character onwards. So that is how you can actually combine different things that we learned and implement them wherever you want. This is just some of the example. Now we will not really do that, doesn't even matter. You can also implement different things if you want to. You can execute different stuff. For example, let's say we want to start a notepad on the actual on the target machine. You can simply just type here if on the different machine. You can simply just type here if data.decode UTF-8 equals to, for example, start. Now you need to specify different commands because all of these commands will have their own meaning. You can name them anything you want. For example, if you send in the chat server start, then what this will do is it can perform the subprocess function, so subprocess.popen, and it can open the actual notepad, for example, and then let's say it opens the notepad and shell equals true. Of course, we need to make sure that that is right here as well. So basically it would look something like this. Now of course I would probably get some error right here because I forgot something, but if something like this is called, you can implement everything that we learned in the previous tutorials. You can also implement anything that we did with the time itself if you want to. You can list different directories, you can execute different commands, such as, for example, let's say print date time. We can do anything like that. Well, basically there really isn't much to do at this actual message and clients or server and client programs. What we did right here, we simply created a normal program that will send and receive messages from the both sides. So basically that would be about it for this tutorial. I hope you enjoyed it, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we're going to take a more advanced look at defining sockets. Now what we did in the previous tutorials is we saw how we can create a simple program that is going to be a program that is going to basically send and receive messages from one PC to another. Now what we did in order to implement that, we created a socket object. We also created a while true loop that is going to receive and send data. I also showed you some of the ways how you can actually implement more different things except actually sending just messages, such as, for example, changing the directory, writing to files, or executing some different commands. Now, right now, we are going to take a look at the more advanced sockets. Now, basically what we did in the previous tutorials is the TCP server and client implementation. We saw how we can actually create the connection via three-way handshake, and then basically we processed into actually sending and receiving messages. Right now, let us take a look at some of the partial reads and writes in the advanced sockets. Now, socket programming can usually be a little bit difficult. It is often a mess. There are a huge number of options, many corner cases, as well as many failure modules or reliability issues. Now, be aware that the read and write function, or the reading and writing to a socket, may involve partial data transfer. Now, what I mean by that is that the send function that we saw previously, let me just open up my idle, open it up right here, and that the send function, so, oops, import socket. Okay, so finally the send function that we actually used in order to send data, that function will actually return actual bytes sent. So for example, if we have a string that's going to be the actual length of, let's say, 8 bytes, the send function will return the actual amount of bytes that were sent, which is 8 bytes. So let us see how we can do that, just by simply, let me just create the socket real quick. We will just simply establish a connection. I will not explain anything that I'm doing, because we already passed this. For s.bind, and we will bind my IP address, which is 192.168.1.6, and then we will go to the 6789, let's say that port. Now we are going to listen for two connections, doesn't even matter, and client's address will be equal to sock.set. Press here enter. Let us just create real quick the client, which is going to connect to the actual socket or to the actual server that we coded right here. All of these things should already be familiar to you as we did them before. So let me just socket.socket, socket.af_inet, socket.sock_stream, s.connect, and right after we connect, we should be able to establish a connection. So 1.1.6, make sure to check first of all what is your IP address, your local IP address, and that we already know we can do with the help of the command prompt, and then specify it right here, and then specify the port. Yeah, because we actually called it sock and not s. S is in our server, so let me just go right here, comma, and right now the port number, and we are good to go. We have established the connection. So right now let us create a data, a simple data that we are going to send to our server. So right here, let's say we have data equals hello world. Press here enter, and basically if you just type here length of data, you will see it is the length of 11 bytes. Okay, and now if we simply just want to send this data, we can do that just by specifying s.send data. But before we do that, let us create client.receive 1024 bytes will be data. Now the server is waiting for the message from client, and now if we send the data, yeah, it is sock.send. Once again, it is not s.send. A byte object is required. Yeah, we will actually have to encode it because we are using Python 3. Therefore, it has to be encoded in order to be able to transfer it over socket. And we can see that the actual send function prints out right here that 11 bytes were sent. Now we received right here, and if we just type length of data, we can see that we also received 11 bytes. Okay, so now if we actually decode this, because we can't really print, if I just type here data, you will see that it will print it out with db right before it. That means that the data has to be decoded. Therefore, we need to just simply type data.decode, and we can decode it with the UTF-8. So we can see the amount of bytes that the actual socket has sent over network. As we can see, the length of the data that we received is 11 bytes, and if you simply just count letters in the hello world, we will receive 11 bytes. And basically, the same goes with the send function. It will by default, if you don't specify anything else, it will output the amount of bytes it has sent. Now, the only reason why this amount of bytes is equal in both of these programs is because we used the encoder. Now, if we didn't use it, well, for example, in Python 2, you can send the data without encoding stuff, and there, the actual send and receive function will not be the same length. So, for example, the send function will print out a different value for the same data than the receive function will print out once we actually receive it. So, for example, the send will type that it sent 11 bytes, while as the data will print out less or more bytes than that. Okay, so basically those are partial writes and reads. Now also be aware that for TCP, the data stream is continuous, so no concept of records. What that means is basically once you send data and you send more data, the actual server that is receiving the data. So let's say the client sends something as it did right here, and the server needs to receive it. The receive function may return data from both of the sends combined, or less data than even the first send. Okay, so you can just simply see right here, if we specify that the data will be equal to client.receive, we want to receive 1000 bytes. Okay, and let's say that the actual client sends sock.send, it sends data.encode, or let's just type here, let's first type two strings, string 1 equals hello, string 2 equals world. And now we first want to send the string 1, which we will have to encode UTF-8. And now we send the string 2, which we also need to encode UTF-8. And you will notice that we in total sent 5 plus 5, we sent 10 bytes in total. So these two strings have hello world. Each of them has 5 letters, and each letter represents 1 byte. Therefore, we have 10 bytes in total. But if you just print data right here, you will see that we only have the word hello right here. That basically means that as soon as the actual server received something, it closed the connection and it stored the value right here, and it wasn't trying to receive no more. So if you try to send multiple stuff like this, it will not work. It will only store the first stuff. Now, a lot of that depends on the OS buffers, the network bandwidth, and the actual congestion. So if you want to, for example, send all data, to wait until all data is sent, you can use send all. Now, it will block until all data is transmitted. For most normal applications, this is what you should basically use. Now, the only exception is you don't want to use this if networking is mixed in with other kinds of processing, such as screen updates, multitasking, and so on and so on. But even if you use the send all function, for example, a client wants to send multiple things and it uses send all function, and the server receives that, how can the server know when is the end of data? So how to tell if there is no more data that is going to come? Now, this receive function will return an empty string once all of the data is sent. Now, this means that the other end of the connection has been closed, so no more sends. In order to actually write this properly, you need to perform some data reassembly. So basically, receivers often need to reassemble messages from a series of small chunks. So now, right now, we're going to see a programming example for that. So for example, let's say we have the max size value to be equal to 1024 bytes, okay? And then we have fragments, which is going to be the fragments of data. So right here, fragments equal, open and close brackets. We're going to create it to be a list of chunks. And right here, we're going to enter a while loop. So right here, we'll specify while not done. We're going to specify chunk to be equal to s.receive, or pardon me, client.receive, and we're going to receive max size. Okay, this is our actual line that is going to get a chunk, and now we're going to check if the chunk is actually equal to, or if it doesn't exist. That means that we actually received all of the data. So if not chunk, we will break out of the loop. In any other case, we will append to our list of chunks. So fragments dot append chunk. That means basically right here, this break statement right here means that we no longer have any data to receive, therefore we're breaking out of the loop. So right here, press here enter. Name done is not defined. Pardon me, I used the done, which we didn't really define. So let us do it like this: while not while chunk or let me just see right here, we can specify while or let's just try with the while yeah, simply let us just go with the, yeah, it is invalid syntax, so while true, let us go with the infinite loop. So while true, chunk will be equal to client.receive of max size, if not chunk. I actually wanted to use chunk as an actual parameter in the while statement, but let us see if this will work. So fragments.append chunk. Press here enter, and we can see that we are basically stuck right here because we are stuck on this statement right here, and therefore let us try to send something that is going to be a lot larger than 1024 bytes. Because if we actually send something that is going to be 1024 bytes big, it is going to store it simply because the actual max size is 1024 bytes. But what we are wondering is what happens if the actual data that we are going to receive is larger than this number. So in order to check that out, we can simply create a variable called data, or large data, let's call it like that, large data. And let's create it to be equal to a times 2000. Let me see right here. A is not defined. Yeah, we need to actually type it like this. Large data equals a times 2000. Okay. So right now we have a large data variable that is stored the 2000 times a. So basically 2000 letters, which consists of letter A. That is 2000 bytes, therefore 2000 bytes is larger than 1024, and right now we will see if I just specify length of large data, with the small d, okay, 2000, and right now if we just specify sock.send, and we send large data.encode, and we encode it with the UTF-8. Okay, let me see right here. For some reason it is still stuck right here, so if not chunk, let's try to keyboard interrupted, but for some reason it doesn't want to. Not really sure what is wrong right here. So basically we enter a loop, we receive the data, if not chunk, so basically if the data right now is no bytes, we will basically break out of the loop. In any other case, we will simply just fragments.append. So let's try to sock.send all. Let me just try something. Data equals a times 48, and if this works, I will simply just explain to you why I did this. But if it doesn't, we will simply just restart. Yeah, okay, it did work, and let me just explain to you why it did work. So basically, if I just get the length of the chunk, 976, which is weird. Okay, so we don't have the entire actual string printed out right here, which is a little bit weird, but this wasn't meant to be actual. But we'll see how we can actually do the correct way of this in the with the usage of the JSON library later on. For some reason, once it actually sends the entire data, it doesn't set the chunk variable to be equal to nothing, so basically to be equal to none. Therefore, we need to send the round number, and round number is 2 times 1024, which is going to be 2048 in order for chunk to be equal to nothing. And right here, let me just see right here, that's what we actually sent, and that's why it closed the while true loop. So you can see 2000 is what we sent from the first try, and from the second try we sent 48. Okay, so basically, let me try this one more time, just a little bit different. So while true, chunk equals client.receive max size. Okay, if not chunk, we're going to continue with this. We will break out of the loop, fragments dot append, we are going to append chunk, and then we're going to set the chunk to be equal to nothing. Okay, press here enter. Now we are waiting for the data. Let's say we send the data once again, so sock.send data.encode, and we encode it with the UTF-8. Press here enter, and now we send the large data as well, and we will see what is the actual size of that data that we receive. Oops, not data, we want large data.encode UTF-8. Okay, never mind, this didn't work. We will just close it right here. And we will see the actual true example, what I wanted to show you later on with the JSON library. I just want to show you the basic understanding behind it, but for some reason this doesn't seem to work. Maybe it is because we are using something as a list, but it really shouldn't be something like that. But we also made a mistake. Once we actually printed out the chunk, we should have printed out the fragments, because that is where we're storing our variables, or that is where we're storing our data, or basically the list of chunks. Now we're going to get back to this later on with the JSON library, but for now on we're going to make a pause, and we're going to continue in the next video with the timeouts and blocking sockets and so on and so on. Now we're not going to touch any of that in greater detail. Basically we're going to just take a look at it, and we're going to pass through different things that you might need later on. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this tutorial. And right now what we're going to do is, as I said, we will continue with our sockets. We're going to focus mostly on blocking sockets, on socket timeouts, on defining some of the socket options, and so on and so on. Now what we did in the previous video is we took a look at some of the more detailed example of using send and receive functions and what they retrieve, the amount of bytes they retrieve, and we also tried to actually make our own while true loop, which is going to basically receive the exact amount of data that it is being sent, but for some reason it didn't want to work. Now I have a good idea why, and we'll get back to that once we actually encounter the JSON library within the socket programming. But for now on, let us focus on the timeouts in sockets. So basically, first of all, open up your idle, and I will simply just show you the usage of those functions that we have in socket library. So first of all, import socket library, and most socket operations will block indefinitely. Now you basically, if you want to, you can get an optional timeout. So first of all, if you create a socket that is going to be equal to socket.socket, and it's going to be equal to socket.af_inet, which is our usual socket, and it's going to have the socket.sock stream for the TCP connection. In order to set a timeout, which is an optional timeout, you can use the function called setTimeout. In order to do that, you simply just call your socket descriptor and basically set the timeout function. So set timeout, and in between the brackets you will specify the amount of seconds that you want the socket to be timeouted. So let's say we specify 5.0 seconds or 5 seconds. Press here enter, and basically what this means is that, let's say you have a connection established already. We will not establish it one more time because we don't want to waste time doing that, but let us get into more details what this will do. So if you had a connection established, and let's say you call this socket to be set timeout for 5 seconds, and that means that if you get an s.receive function right after it, so let's say right after it there goes the s.receive, which wants to receive 1000 bytes, it will get a timeout exception error. It will say basically socket.timeout, and it will say the error is timed out. Now, if you want to actually enable this, you can simply just remove the socket timeout for a specific reason or whatever your needs are by setting the timeout to be equal to none. So basically set timeout, you simply just call the same function that you called in the previous example, and you simply just specify none in the brackets, and therefore it will actually remove the timeout and you will no longer have it. Okay, now you can also use non-blocking sockets. What their use is instead of timeouts you can use them. So the non-blocking sockets, you can set them simply just by calling the set blocking function. So in order to do that, you can simply just type s.setBlocking, and let's say you want to set that to be equal to false. You would simply do that just by specifying the set blocking and false in the brackets. What this means that the future send and receive functions that you call right after this statement right here will raise an exception if the operation was blocked. Okay, so it will simply just say if you try to s.receive once again, it will tell you resource temporarily unavailable. But as soon as you disable it, you can simply just call s.receive once again, and the data will be received, and therefore you can use it. Now these non-blocking sockets are sometimes used for polling. Okay, so another thing that we should briefly take a look at is the socket options. Now what socket options allow us to do is to specify something that we might need for our own use. So basically sockets have a large number of parameters. They can be set using the s dot, or doesn't have to be s, you can whatever your s object is called. So s dot set sock opt is basically the function that will set socket objects, options, and in between the brackets you will specify the options. So let's see an example of setting socket objects options to reuse the port number. You would simply do that just by specifying set socket opt, and in between the brackets you specify socket.sol underscore socket, everything capital, comma socket.so underscore reuse addr, comma 1. Press your enter, and right after it you would be able to call the bind function as we did in the previous examples. Basically this is an example of reusing the port number. Now you can basically go to the default Python page and take a look at the socket to see all of the available socket options that you have in this library. So these are not the only ones, these are just some of the ones that are almost always used, but you don't really need to use them. As you saw in the previous tutorial, we didn't really use them, but if you encounter this function, it will most likely be this specified in between the brackets. So once again, this is a function that sets timeout, this is a function that sets blocking, this is a function that sets socket options. Now another thing that you might want to consider is basically that you can use sockets as files if you want to. Maybe sometimes it is easier to work with sockets represented as a file object, and you can simply just do that by specifying file descriptor. For example, let's say we call it f, and you simply just specify f to be equal to s.makefile. It will make a file out of your socket object, and therefore you can use the socket object from now on as the same way you use the actual file. So for example, f.read is a function you can use. Now it will say right here an error, a request to send or receive data was disallowed because the socket is not connected. Of course we're not connecting, but you can use the same functions that you used in the actual file manipulation. So you also have f.read lines, you have f.write, you have f.write lines, which is a function that we didn't even see before in the actual file creation. You have f.close as well as s.close in the socket library. Basically all of the same functions that you used in files you can now use on sockets as well. Now basically it is easy to write programs that will mysteriously freeze up or don't operate quite like you would expect if you use these sockets as files. So it is a little bit tricky. It has a tricky resource management. It must be managed, both the socket and the file independently. So keep an eye on that. That is also something that you should basically take a look at. And also what we're going to do in the next video is we're going to take a look at creating the server and client using the UDP protocol. So what we did in the previous tutorials is we always use the socket.sockstream, which stands for the connection oriented program, or basically using the three-way handshake over TCP. And what we're going to use in the next tutorial is the UDP. We're also going to take a look at the Unix domain sockets, the raw sockets, and all the other stuff as well. So hope you enjoyed this tutorial, and I hope I see you in the next one, where we'll start off with coding UDP server. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And right now let us continue with our sockets programming. So as I said, right now what we're going to do is we're going to take a look at the UDP protocol and implementation of the UDP protocol in the socket library, or in the client and server implementation. Okay, so first of all, there are a few things that we need to know about the UDP. First, the data in the UDP protocol is sent in discrete packets, or as should I say, datagrams. So you will have no concept of a connection, no reliability, no ordering of data, and basically the datagrams or the packets may be lost, and it can arrive in basically any order as they want to. But the good thing about this is that it has the higher performance, and it is mostly used in games, in streams. For example, let's say you're having a call or watching a stream on Twitch, or having a call over a Skype. It is basically a UDP protocol. That's why sometimes you have more lower resolution, or you sometimes just lose the connection and track, or some packets are not received. That is because you're not really using losing connection, because the connection was never there. You're simply just dropping some of the packets that were used in order for you to, for example, receive all the audio from the Skype call, for example. So basically the packets can be dropped. There is no confirmation at the other end that the packets have been received, and therefore it is a lot faster. Okay, so right now we're going to see a simple UDP server. So open up your actual idle, enlarge it right here, and we are simply just going to import, or let's import it like this from socket, or let me just go to the edit. I will go edit, configure idle. I will enlarge it so you can see everything a little bit better. Let us go 20, apply. Okay, so let us code right now. We will import socket a little bit differently, so we will import it like this from socket. We will import everything. Now the reason why we are importing it like this is because we don't really have to type right now s equals socket.socket and then in between the brackets socket.af_inet and so on and so on. We can simply leave out this first socket if we want to. So we can do it like this. That's because we imported socket differently. So right now from socket we imported all, and s equals socket and in between the brackets af_inet. And the thing that changes right now is we want to create a datagram socket. Therefore we will no longer have this sock_stream. What we're going to have right now is sock_dgram, which stands for the datagram socket. Okay, so simple as that. Press here enter, and we created our socket object. Now the process of the server is the same. So basically you simply just type s.bind, and in between the brackets you specify your IP address and you specify the port that you want to bind to your IP address. Okay, so simply just specify 192.168.1.6. Of course, make sure to check what your IP address is, as it most likely will not be the same as mine. In order to do that, once again open up your command prompt and type ipconfig, and the actual thing that is in line with the IPv4 address is your IP address right here. Okay, specify it like this. And the second argument is, as usual, the port. So let's use port 10,000. Press here enter, and we successfully binded the actual port with the IP address. Okay, now we can enter the while true loop. So while true, press here enter. We can accept the connection, but right here we know that there is nothing as a connection accepting. So right here we don't really need to call the listen and the accept function. All we have to do right here is call data ADDR, which is going to be data that we will receive and the address from where we will receive. And we can right now wait for the message from anyone that basically sends it. And we do that just by simply specifying s.receive from, and in between the brackets we can specify the amount of data. So let's say 1024 bytes. Press here enter, and you can see right here that it is trying to receive the actual data. Okay, so right now let us go to the client side of the code so we can actually send the data. Let me code it right here so we can see both of our codes at the same time. And we will simply just specify from socket import all, the same way we did right here. Let's create the socket object as equals socket, in between the brackets, af underscore inet and sock underscore dgram. Once again, use dgram for the datagram protocol, and the message will be equal to, as usual, hello world. This is the message that we're going to send to our server right here. So in order to do that, you can simply just specify s.send to. So you will notice right here that we didn't really need to use the connect function. You can simply just use the send to function in order to send the actual data to a server. So the first argument to this function is what we are sending, and what we are sending is the message. So we'll just simply specify message. Of course, I believe we need to encode it, or no, we don't really need to, or we will see. And then the second argument will be to where you are sending it. So basically the IP address of the server that you are sending to and the port on which you are sending. So comma, and in order to specify that, you simply just open and close another bracket right here and specify first the IP address, which is 192.168.1.6 in my case, comma, and then use port, which in my case is the port 10,000. Press here enter. A byte-length object is required, so we will just simply create message encoded will be equal to message.encode. Let's encode it with the UTF-8. And right now let us send the message encoded, comma. Everything else is the same. 10,000. Press here enter. We can see that 11 bytes were received. Let's go back. And right now, let us code the rest of the actual program of our server. So right here, we can print the data if we want to, but we don't really need to right now. We will just create a response, which is going to be equal to how is your day? Question mark. Whoops, day. And then question mark. This is going to be our string. Let's create response. Where is? Okay, so here is the underline. Response.encoded will be equal to response.encode with the UTF-8 before we actually send it to our client. And then we will send to, and what we need to actually specify right here is you will notice that right now we don't really have the socket descriptor or the socket object for the client as we had before. Once we actually coded the accept function, we specified something similar to this. just this was replaced with the client word, and this function was replaced with the accept, and therefore once you actually receive the connection, the socket object of the specific client is stored at the address in the client variable, and the address, which is the IP address and the port, is stored in the address variable. And we used to contact or connect or message and receive messages with that client by using the client variable. But right now you will notice that we didn't even have the accept function, and we also don't have the client socket object. Therefore, in order to send this from the server to a client, you simply just specify what you want to send, and in our case we want to send the response encoded. And in order to specify to who you are sending, you simply specify in this case the address, which is going to be the same way of sending as basically in the actual client. So right here you can specify ADDR, because you don't really know the address of that client as long as they don't send the message. So we'll specify right here address. It will be the IP address and the port from where the messages are coming from in the client's case. You press here enter, press here enter once again. We can see we finished our actual while true loop. We sent 16 bytes, and now we're stuck at this line right here. So in our actual client-side code, we can now print what we received, or we can try to receive, and in order to receive we need to implement the same thing as we implemented right here. So the same thing. So let us do that right here. We will simply just specify the same name. So data comma ADDR, which stands for address, is going to be equal to s.receive from, and specify the amount of bytes we want to receive. Let's say 1024 bytes. Press here enter, and right now if you want to, you can print data, which is going to be how is your day. You can see we have this B right here, which means we didn't really decode it, so data will be equal to data.decode UTF-8. And now if we print data, it should be a simple string. So you can see right here, and now the server is waiting for the actual message, so you can send it right here. Let us send one more message and receive one more message, and that would be about it. So we will simply just create another message. So message 2 is going to equal to, let's say, good, how about yours? Now we need to create message 2 to be equal to message 2.encode UTF-8, and we will simply just send that, or we will send message 2 to the actual server. And right now we don't really need to specify the IP address and the port like this. We stored it right now in the address, therefore we can simply just specify right here address. Click here enter, and you will see right now that the server received it and sent once again how is your day. Okay, so it went through this line, it stored in the data, and then it went to the send to, and now it is stuck at the data received from once again. So we will see if you simply just print right here data to ADDR as.receive from, should be the same message as we received previously. So print data should once again be how is your day, and it is. So basically that would be about it for the UDP server. Now what we are going to take a look at in the next tutorial is some of the Unix domain sockets, raw sockets, which is also something that you can use. Now sockets and concurrency, basically different browsers. We'll take a look at some of the different things, as well as we will mention the threaded server and how we can actually implement it. So basically that would be about it for this tutorial. I hope you enjoyed it, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to our new tutorial, which is going to be mostly devoted to the different types of sockets, such as Unix domain sockets and raw sockets, and how we can actually create them. So we're going to take a look at that. What we did in the previous video is we took a look at the creation of the UDP client and server, and we also saw how they can interact with each other, what's the differences between the UDP client and the TCP client, as well as what is the difference between the UDP server and the TCP server. And right now we're going to start off with the Unix domain sockets and how we can actually create them. So basically, first of all, open up your idle right here. As usual, what we need to do is we need to import the sockets library. So import socket, and basically the Unix domain sockets are available on the Unix-based systems, of course, which makes sense, and sometimes they are used for fast IPC or pipes between processes. Now, the creation is rather similar as the creation of the regular TCP socket or UDP socket that we used before. Just specify sock equals, which is going to be the name of our socket object, socket.socket, and now instead of specifying socket.af_inet and then comma sock_stream, you should specify socket.af_unix. Everything capital, and after that socket.sock_stream. Socket has no attribute af_unix. Let me just see right here, dear socket, sock.raw, sock_dgram. Let me just see, af_inet, okay. Let's just try to find it right here. Okay, so we got the IPX, inet, inet6. Yeah, of course, I'm not really sure why I even tried to find this. Let us just go and open up the I'm not really sure why I even tried to actually use it on the Windows 10 machine. What you need to do is you would need to have a Unix based machine or a Linux machine, and basically the creation would be the same, just of course in that case the actual creation would work. Right now it won't really work because you're simply using the Python 3 for basically Windows 10, which is the XE version of Python 3, therefore there is not af_unix for the socket creation of the Unix system. So once again, if you wanted to create it, you would simply specify s equals socket.socket, if you're running Linux, of course, and then socket.af_unix, and then comma socket.sock_stream. You would press your enter and then that would work. The same goes with the actual UDP client, UDP socket. So socket.socket, socket.af_unix, and then comma socket. And you simply just specify sock_dgram, which represents the UDP. Okay? Now, the address can simply be a file name in the Unix domain system, so you know that once we actually specify the TCP client in our Windows 10 environment, we would need to specify s.bind, and then in between the double open and double close brackets, what we would specify is the IP address, and then we would specify the port. Now in the Unix-based system, address can be simply a file name. So what you would specify right here is, for example, a temporary directory, so s.bind, and you specify /tmp/ and then some directory, doesn't even matter. Basically, this is the server binding, and then the client connection, what the client actual program would perform in order to connect. We know that in Windows 10 environment we will need to specify s.connect and then specify the IP address of the actual server as well as the port on which we want to actually connect. Now in the Unix based systems it is simply just connecting to the directory, so all you will need to do is specify in the client side code s.connect, and then in between the brackets you would specify the actual directory to which you want to connect, or basically the file name. As we know, in Unix-based systems, address can be a file name. Now the rest of the program that you would write in order to perform the server and client connection is rather the same, so rest of the programming interface will be the same as in the Windows 10 environment that we already saw before. Now another thing that you want to actually know about is the raw sockets. So let me just delete this. We already imported sockets. Now, if you have, for example, root or administrator access, you can gain direct access to the raw network packets. Now, what does that mean? Well, first of all, it depends on the system, and the second of all, what the Linux packet sniffing would look like is simply just creating the socket like this. So s equals socket.socket, and then in between the brackets, instead of specifying AF Unix or AF inet, you would simply specify socket.af underscore packet. And basically, then you can specify which protocol, for example, socket.sock underscore dgram, which stands for UDP. Now, of course, because this is on Unix, it will throw us an error right here saying module socket has no attribute AF underscore packet, because this is only working in the Linux systems, okay? Then right after it, all you will need to do is specify the actual interface which you want to bind to, and also which type of packets you want to sniff. Now, what I mean by that is simply, let me just show you in the command prompt, and for those of you who are using Linux, you can simply just type ifconfig in your terminal. So open up your terminal on your Ubuntu machine or any Linux machine that you are using, type ifconfig. Right here I will type ipconfig, because right here I'm on Windows 10. And once you type that on Linux, you should see the name of your actual device, or the name of your actual networking interface, which can be either ETHO, WLAN, WLO1 or 0, doesn't even matter. It can be different for every system. It is usually ETH0, especially if you're running a virtual machine or something like that. It will be ETH0. And then, in order to sniff the packets on a certain interface, what you would specify is s.bind, and instead of binding the actual directory or the IP address with the port number, what you would bind is the interface with the protocol number. So what I mean by that is simply it will take two arguments. So once again, you will open and close double brackets right here. And what the first argument would be is the name of your interface. So all you would need to do is check the name of the interface on which you are connected to the internet, because make sure if you have multiple interfaces that you choose the one that you have connected internet connection with. How you can check that is simply if you have the IP address asserted to you, that means you're probably connected, therefore you can pick that one, okay? And then in between the double quotes, you will need to specify the name of that interface. So in our case, let's say it is ETH0, because that is the most common one, and the probability of you finding this are greater than any other. Then the second argument would be the protocol number, and what does that mean is basically which type of packets you want to sniff. For example, let's say we want to sniff the IP packets from the IP header. Basically, you would specify the IP packet number, which is 0x0888, or pardon me, 800. Then you would specify this, you would press your enter. Now, of course, this will not work because I don't really have the ETH0 interface, and I'm not on the Linux systems. And then all you would need to do in order to receive a packet is simply just specify a while true loop. And in that while true loop, you would simply just specify, for example, message, and then address. And the reason why we have message address is because notice right here that our socket object has sock underscore dgram, which is UDP packets and not TCP packets. Therefore, we are not going to store the client's socket object anywhere in our memory. We can simply just connect with the client over address. And then you specify equals s dot receive from, and specify the amount of bytes, so 4096, let's say. Now you would press your enter, and basically this would receive the packets in Linux system. It will get a packet to you. Okay, so simple as that. Basically that is all you want to know about the raw sockets. Of course there are more things about them, but for now on this would be more than enough, as this is the beginner's course. Now another thing that you want to take a look at, but first of all let me just restart this because we got too many errors since we are not running on the Ubuntu machine. Now also one more thing that you want to know is that servers usually handle multiple clients. So what we did by now is we actually took an example of creating the TCP and UDP client and server, but we only accepted one connection. And you should know that these servers handle multiple connections most of the time. So in order to create something like that, you would need to specify that each client gets its own socket on server. Now, why is that? Well, simply, let's say you're creating a TCP connection, which you most likely are, because there is no really point creating UDP connection with the multiple clients, and mostly because it is connectionless, and you really need to specify the address in order to communicate with a specific client in the TCP connection. What you need to do is simply just create a socket object and then accept the connection, which will store the socket object of the client into the first variable. So if you remember, we would specify something like this: s equals socket.socket, and in between the brackets socket.af_inet in order to create the IPv4 connection, and then socket.sock_stream. Then you would press here enter, and then while true loop can accept the actual connection. So CA equals s.accept, and therefore you would right now accept the connections. Okay? Now it says right here invalid argument is supplied because we didn't really bind or listen or didn't perform any other connection, or pardon me, we didn't perform any other function that we need to. For now on, I just want to show you how you accept connections in this TCP connection. So right here, this variable C would store the client socket object. Okay? So now another thing that you should know in order to manage multiple clients is that the server must always be ready to accept new connections. So therefore, what we're going to do in the next tutorial is we are going to introduce ourselves with the term called threading. So we're going to introduce ourselves with the threading in Python 3. Now, why we need to actually learn that? Well, simply because of this statement that the server must always be ready to accept new connections. You know that this accept function hangs until a new connection is connected to you. Now, you don't want your program to always pause while waiting the connection. You want your program to continue executing at the same time as it is accepting new connections. And in order to perform something like that, you need to make a threaded server. Now, also, the server must allow each client to operate independently. Each may be performing different tasks on the server, therefore they need to perform independently. Okay, and what we will do is we will basically code a brief outline for this solution, but before we actually do that, what we want to do is we want to introduce ourselves with threading, and then after we learn threading, we will go on into the threaded server. Okay, so that would be about it for this tutorial. I hope you enjoyed it, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now, let us continue with our multi-threaded programming. We only mentioned in the previous tutorial, and we also said why do we need that in order to implement it into a threaded server. But now, before we actually do any of that, we need to introduce ourselves with the threading library and explain what threading is. So, first of all, running several threads is very similar to running several different programs concurrently at the same time, but they have multiple benefits, such as multiple threads within the same process share the same data space with the main thread, and therefore basically they can share information or communicate with each other more easily than if they were separate processes. Now, threads are also sometimes called lightweight processes, and they do not require much memory overhead. They're basically cheaper than the process itself. So basically, threading is much more faster, and also a thread has a beginning, an execution sequence, and a conclusion. So basically, once you're creating a thread, you need to know exactly for what are you creating the thread, what will be the purpose of the thread, and what will the thread return at the end. Now, the thread has an instruction pointer that keeps tracks of where within its context it is currently running. It can be preempted or interrupted. It can temporarily be put on hold. It also known as sleeping. While other threads are running. Now this is called yielding. There are also two different kinds of threads. Now the most common names for them are the kernel threads and the user threads. Basically, the kernel thread is a part of the operating system, while the user space threads are not implemented in the kernel. So the kernel thread is something that is running more deeply in the system itself. Okay, now there are two modules which support the usage of threads in Python 3. The first one is _thread. Let me just open the idle. You can import it like this. Import _thread or import threading. Those are two modules that basically allow us to use threads, and they can both be used. Now the thread module has been deprecated for quite a long time. Users are encouraged to use the threading module instead, which is the second one that we imported right here. Hence in Python 3, but in Python 3 the module thread is not available anymore. However, it has been renamed to _thread, which is the first one that we imported right here for backwards compatibilities in Python 3. So we are going to take a look at both of them, but for now on, let us see how we can simply just start a new thread. So basically, to spawn another thread, you need to call the following method that is available in the thread module. So we're going to use this module right here, and in order to spawn another thread, you will simply just specify _thread dot start _new _thread. Now a thread, this function right here would start a new thread, but it needs to have some arguments. Now what the arguments would be is the first argument would be basically the function on which you want to start the thread. Now that function can basically be anything. So let's say you code a function that is going to print hello world every 10 seconds, and you want to specify it right here to run while the rest of the program is also executing, and you would specify it right here. But also the second argument would be the arguments to that specific function. So args right here, if there are any. If there are not, simply you don't need to specify this. But if your function takes arguments, you would specify them or paste them right here. Then the threading library would start the thread, and then it would simply just print hello world every 10 seconds, as well as running the rest of the program at the same time. Okay, so this is the basic syntax for creating a thread with the import thread. Of course, we're going to take a look at the example. This is just for now on a syntax. Now, this method basically this method call enables a fast and efficient way to create new threads in both Linux and Windows. Now, the method call returns immediately, and the child thread starts and calls function with the passed list of arguments. Now when the function returns, this thread will terminate. Now here, in the previous example of syntax, the args is a tuple of arguments, so basically it uses an empty tuple to call function without passing any arguments. The basically example of this would be, so let's say we do something like this. So we imported threading. Let me just go right here. We'll create a new file. Let us enlarge this. We will save it onto our desktop right here. So go to the desktop, thread1.py. We'll save it right there. We're going to import _thread, and we're going to import time. Now we already introduced ourselves with the time module. Right now, let us see how we can implement these two modules together in order to make something that will be easy for you to understand. So first of all, we will create a function, and the function will simply be called print time, as it will print time. So print _time will be our function. The function will take two arguments, which is going to be the thread name, which is the first argument, and the second argument is going to be delay. And I will explain it just in a second, as you will see right now. What we will do right here is we'll create first of all a simple local variable called called count. So count equals, and we will edit the value of 0. So this is the local variable, only belongs to the function itself, and it has the value of 0. Then we are going to enter a while loop. So while count is smaller We just find the okay, so here it is. Took me quite a while to find the smaller sign. So while count is smaller than 5, then 2 dots, then we will simply just call the time library, and from the time library we will call the sleep function, and what we will specify right here, so time.sleep, which is the amount of seconds that the program should not do anything, and we'll simply just specify the amount of seconds to be equal to the delay variable that we parsed to this print time function as a second argument right here, as we can see. Okay, then once the program sleeps, we will simply just increase the count by 1, so plus equals 1, which will add a 1 to the count variable, and right after it we can print something like %s, okay, so %s dot 2 dots %s, and what the actual 2 arguments will be is the first one will be thread name, and the second one will be time.ctime, in between the brackets time.time. Okay, let me just see whether I am missing a certain bracket right here. 1, 2, 3, 4. Okay, so we need one more bracket. 4 open and 4 close. This is first one, second one, third one, and fourth one, and we also have 4 closed. Okay, so press here enter. Basically this is our function for the thread. That is all the function will do for now on, and now we're going to create 2 threads. In order to create 2 threads, we can simply just, in order for our program to execute properly, we'll use the try and except rule, and in the try statement right here we'll try to call the start new thread function that I showed you before in the syntax example. So underscore thread dot start underscore new underscore thread, and basically in between the brackets we need to specify 2 things, as we already know. The first one will be the print time, and the reason why we're specifying print time is because that is the name of our function, and the second argument, oops, not here, print time, accidentally deleted that, so print time is the name of our function, comma, and now we need to specify the arguments. So we know that our function takes 2 arguments. First one is the name of the thread itself, and the second one is the amount of seconds that the program will sleep once it calls the time.sleep function right here. Okay, so we will open our brackets right here in order to specify the arguments. The first argument, let's say we want to call the thread -1. Okay, it will be specified between the double quotes because this is a string basically. And the second argument, let's say we specify that the amount of time that we want to delay the program or our thread will be 2. Okay, then specify comma right after it. Make sure that you have 2 actual brackets open and closed, as we have right here. And we're also going to start another thread, so underscore thread dot start underscore new underscore thread. And what we will do right here is we will open and close brackets once again and call the same function, which is print time. Just right now we're going to call the threads differently, and we're also going to specify the different amount of seconds for the program to delay. So we'll call this one thread -2 and then comma 4 seconds, and then we leave these 2 brackets closed. In the except statement we can simply just print failed to start thread. Doesn't even matter, we can simply just print anything we want, and all we're left to do is call this program. So what we will do is we will simply just while 1 or while true, basically while 1 and while true is the same thing. It will basically execute forever, and then we will specify just pass. So this is the while true loop that will not simply do anything. Okay, so save this program right here, save it just like that, and then simply let us run the module. We started it, we can see thread 1, we can see thread 2, thread 1, we can see that they're executing at the same time and they're printing those statements at the same time. So both of those threads are executing it at the same time. Basically just one of them is going to be executed every 2 seconds, while as the next one has the delay of 4 seconds. Therefore they are not interacting with each other in the means of this actual order being 1, 2, 1, 2. It is rather being mixed up, and we can see that this program right here, it will basically execute forever because we specify the while true loop, or the program itself will execute forever, but the printing statements have already been finished because the count variable has reached the value of 5. As if you remember, every time we actually print this statement, we simply just increase the count variable by 1. Therefore, this is not printing anything anymore because both of those count variables have received the value of 5. Therefore, we'll just keyboard interrupt this as the program goes into an infinite loop. So you will have to simply just press Ctrl+C to stop. Now, although this is a very effective for low-level threading, the thread module is very limited compared to the new threading module. So this was the example of the thread module, and right now let us see the example of the threading module. So I will just restart my idle right here. And basically we already know how to import the threading module. You simply just specify import threading right here, press here enter, and you simply imported the threading module. So the new threading module, which is this one, it is included in Python 2 and in Python 3 as well. It provides much more powerful or high-level support for threads than the thread module that we discussed in the previous example. So basically the threading module exposes all the methods of thread module and provides some additional methods as well, such as, for example, threading.activeCount, which you specify simply just like this, active count. Now we will not call this because it will return an error, but what this function from the threading module simply does is it will return the number of thread objects that are currently active. Now another function, you can simply just specify threading.currentThread, and what this function does is it will return the number of thread objects in the caller's thread control. So basically it will return, as it says, it will in the caller's thread control just check out how many thread objects are there, and it will return the integer value of those thread objects, or the number of those thread objects. Now another important function that is in the threading library is the enumerate function, which simply returns a list of all thread objects that are currently active. Now, in addition to all of these functions, or these 3 functions, the threading module has the thread class that implements threading itself. Now, the methods provided by the thread class are simply these ones. So, for example, you have the run method from the threading library from the thread class. The run method is the entry point for the thread itself. You have the start method. The start method simply starts a thread by calling the run method. You have join time, which you specify the syntax wise like this. So join, and in between the brackets you specify time, and basically the join waits for threads to terminate. You want to join the thread at the end of the execution of the process that the thread had as its task, and therefore right after it the thread will terminate. Another function from the thread class is isAlive, with specified A capital. The isAlive method checks whether a thread is still executing. Common sense, as the name says, is it alive. Now another thing is the getName method, which will simply return the name of a thread itself, and the setName, which will simply set the name for a specific thread that you want to set the name for. Okay, so those are just some of the important methods from the thread class, as well as the imported functions from the threading module. Now let's see an example of how we can simply create the thread using the thread module. Okay? So we are going to first of all open up a new program, as we will see an example of the threading library. Now to implement a new thread using the threading module, you have to simply just do the following. First of all, you need to define a new subclass of the thread class. You need to override the init function or the init method to add additional arguments that you might need. And then you need to override the run method to implement what the thread should do when started. Now we already are familiar with all of these basic terms, such as, for example, overriding. We took a look at that in the classes section. We also know how we can define a subclass of the thread class. And right now, let us see how we can simply just do all of that. So once you have created the new thread class, you can create an instance of it, basically, and then start a new thread by invoking the start method from the thread class, which in turn calls the run method. Okay? So in case you don't understand, let us see a simple example of that. So first of all, we will import threading, and we will also import another library, which is the time library, so import time as well. Now, first of all, what we're going to do is we're going to set a certain variable exit flag to be equal to 0. Now, I will explain it as soon as we get to the exit flag execution. Right now, let us just leave it right here. So simply just create a variable called exit flag and set its value to be equal to 0. Then we will create a class that is going to be called my, or let's go with the smaller letters, so my thread. What this class will take in its argument is the threading.thread, as it is inheriting everything from that specific class from the threading library. I already told you that in the threading library there is a thread class, therefore we are going to use its methods in our own class. So we created the class myThread, and from this library we used this class. Okay, then specify 2 dots. The next thing is we need to create the init function as usual, so simply just specify def __init __. And what this init function will take as an argument is, first of all, it will take, of course, the self argument, then the thread ID, because threads have IDs, their threads have their names, which is going to be our third argument to the init method right here, so the name of the thread, and the counter. Okay, so 4 arguments, or basically 3, because the first one is self. And once you specify all of them, add the 2 dots, and now let's define all of those arguments one by one. Okay, so in order to define the thread itself, you can simply just specify threading.thread and then call the init function on the self argument, so __init __, and in between the brackets we need to specify the self argument as we are in the class. Okay, the next argument that we need to define is the thread ID, so we can simply just specify self.thread or self.thread ID equals thread ID. Self.name will be equal to name, and self.counter will be equal to counter. Okay, so we defined all of the 4 variables that we had defined in the init class, in the init method of our class. Now we need to define the run function that is going to have the self argument, so def run, and all we need to simply specify right here is what is going to be ran once this actual function is called. We simply just want to print different statements right here. So the first statement will be printing, let's open and close double quotes, starting, add a space, and we will simply just print what we are starting, and by that I mean we will print the name of the thread, so plus self.name, which is our variable right here. This is going to be the first thing that the run function will execute. The next thing what the run function will execute is going to be the function print time, which we took a look at in the previous example. Just right now we're going to code it a little bit differently right after our class. So let us just call it right here, and then we will code it below. For now on, what this actual print time function will have as its arguments is going to be the self.name, the self.counter, and the delay. Okay, so simply just specify it just like that. Okay, and then the last thing that we want to execute in this run method is going to be print exiting plus self.name. Simply we will just print exiting and then the name of the actual thread itself. So right now down here, let us code the print time function a little bit differently. So it will take 3 arguments as we specified up there in our class. So print time. The first argument will be the thread name, of course. The second argument will be the delay. And the third argument will be the counter, which we specified in our class as well. Now, what we're going to specify right here is while counter. And basically while counter, so 2 dots, if, and now we're going to implement the exit flag variable that we coded at the beginning as the actual variable that is going to define whether a certain flag is simply just open or whether should we close it with the exit function. So if exit flag, then if exit flag, we will specify thread name dot exit, which is going to be the self.name argument, as we can see right here. So self.name is equal to the thread name. We're going to call the exit function, which will exit the thread, and after it we will simply just type time.sleep, and we will sleep the amount of delay seconds. Okay, right after it we will print something like this. So %s, 2 dots, %s. So basically the same print statement as in the previous example, just right now we're going to include the thread name, so thread name from the self.name variable, and we're also going to print the time, so time.cTime, and then time.time. Okay, let us just count the brackets, whether we have closed and opened everything. 1, 2, 3, 4, and then 4 close brackets. Okay, so everything is good by now, and we will simply decrease the counter right now by 1. So minus equals 1. We'll simply decrease it. All we are left to do right now, right after it, is simply just create the new threads and start them. So in order to do that, let us first of all create new threads, and we can simply just call them thread1, which is going to be equal to my thread class. We are simply just calling this class, and what we will specify right here is these variables right here. So we will specify the thread ID. This one will have an ID 1 because it is the first thread we create. Then the name of the thread will be equal to thread-1 as in the previous example, and the counter value will be equal to 1. Okay, so simple as that. The thread2 will be similar to this, so we will call it an object to a thread class. The actual ID will be 2, the name will be thread-2, and then comma, and let's say 2 as a counter. All we're left to do is simply just type the start function onto these threads in order to start them. So thread1.start will start the first thread, and thread2.start will start the second thread. Now make sure that we also call the join function, which will at the end of the execution join these 2 threads and terminate them. So we'll simply just specify thread1.join and thread2.join, and then at the end of our main program we can print exiting main thread. Okay, so basically this would be our entire program. Let us see how it should run. It should execute both of these functions, or start first of all both of these threads at the beginning. It should execute these print statements right here, as well as, or pardon me, this print statement right here, which is going to print the thread name as well as the current time at which it is running. And then right after it finishes, while the counter reaches its desired value, it should simply just exit the thread 1. It should print exiting thread 1, which is right here, and then it should exit the main thread as soon as these two functions are executed. So first of all, save this to the desktop. Let's call it threading1.py, because this is the threading library or module that we used. We saved it. Let's run it. It says starting thread 1, starting thread 2. We can see those print statements being executed. The thread 1 is executed or exited. The thread 2 is now exited, and then it exited the main thread. So we can see that everything worked perfectly. We managed to actually run our program. It printed out different values. Some of them it printed out at the same time, as we can see right here that it printed out in the same line, which is an actual bug. As we can see right here, thread 2 and thread 1 printed at this time, which is the same time. Right here you can see. That means that they were executing at the same time, therefore our threading works. And at the end we joined these two threads, terminated them, and basically simply just exited the main thread right after. Okay, so another thing that you should know about is the synchronization of the threads themselves. So the threading module basically provides with Python the threading module provides with Python or includes a simple to implement locking mechanism that will allow you to synchronize threads. Now, a new lock is created by calling the lock method, which returns the new lock. Now, the acquire blocking method of the new lock object is used to force the threads to run synchronously. Now, the optional blocking parameter, basically it will enable you to control whether the thread waits to acquire the lock or not. Now, if the blocking is simply just set to 0, the thread returns immediately with a 0 value if the block cannot be acquired, and with a 1 value if the lock was acquired. Okay? Now, if the blocking is set to 1, the thread will simply just block and wait for the lock to be released. The release method of the new lock object is used to release the lock when it is simply just no longer required. So we can simply just take a look at that as well. We're going to implement it onto our own program. So we'll just do a little bit of modification to it, as we can see right here. The exit flag, we can simply just close it right here. We don't really need it at the moment. Just type it right here. The class myThread, we will leave it with the same name as well, with the same argument. The def init function will also take the same arguments as it did before. We'll leave the threading.thread, self thread, defining all of this, we will leave the same as in the previous example. The run self function is something that we will change. So first of all, we will print this statement right here. Then we need to get the lock to asynchronous threads. So we can simply just do that by specifying threadlock.acquire, open and close brackets right here, and then we will print this same statement right here. Let us simply just, for example, change this from 5 to 3 just for the purpose of the program. And then at the end, we will not print exiting threads, thread 1 and thread 2. We will simply just delete it. It doesn't really have any point. What we will add, however, is the thread lock.release. And why we are doing this is it will free lock to release the next thread. Okay, so simple as that. Let us go down to our print time function and see whether there is something right here that we need to change. We parse the arguments thread name, delay, and counter, and then while counter, we will delete this exit flag right here, as well as the if statement, as we don't really need it at the moment. We will leave the time sleep delay, we will print this same thing, and we will return the counter minus equals 1, which is going to be executed until the actual counter reaches 0, therefore it will stop right after it. Okay, now right after that, before we actually create our own threads, we need to implement the thread lock, so we can simply just call it right here, because this right here is not really something that exists. We need to really create it, so we will create it at the beginning of our program just by simply specifying thread lock, which is going to be equal to the lock function from the threading module. So threading thread.lock. We will create the thread lock right here, and we'll create a list, or an empty list in our case, which is going to store our threads. So threads equal open and close square brackets in order to define a list. Then we'll proceed to starting these threads right here. As we can see, we created thread 1 and thread 2, starting new threads. And instead of actually joining these threads, let me delete these two statements right here. What we will do is we will add threads to the thread list. So how we can do that is we can simply use the append function, as we saw in the list section when we learned about lists. We know that we can append different elements using the append function. So we will just use threads, which is the name of our list right here, and we will append thread 1 and thread 2. So append, in between the brackets we specify thread 1, and the next statement threads.append thread 2. Okay, so simple as that. And before we actually close the program, or before we actually print this exiting main thread, we want to simply wait for all threads to complete. So we'll just use the join right after we appended it. So for the for thread in threads list, so we'll just simply type for t in threads. So for each element in our threads list, we want to specify t.join, which will join the thread and then terminate the thread execution, as well as printing this exiting main thread and closing our program. So this should be about it that we should change. Let me just save this and run it in order to test it right here. We can see restarting the program. It is printing this until the actual counter reaches 0. We can see right here it still prints it out. We can see it executed at the same time, it synchronized it. We can see right here we now have thread 1, thread 1, thread 1, and then we have thread 2, thread 2, thread 2, and at the end we exited the main thread. Now this was executed by the help of the actual lock that we defined right here. Okay, so simple as that. Now another thing that you might be interested in is the multi-threaded priority queue. Now the queue basic module simply allows you to create a new queue object that can hold a specific number of items. Now there are following methods that basically control the queue, or that we should use once we actually implement the queue library. Let me just go right here, open up my idle. And first of all, in order to actually import the queue, you simply just type import queue. You can see it is an already installed and pre-built library in Python 3, therefore you can simply just import it without installing it. And a few different functions that you might need to know in order to use this actual module is the get function, which is a method that basically removes and returns an item from the queue itself. We also have the put function. This function adds items to the queue itself. The queue size method returns the number of items that are currently in the queue itself. Okay, so simple as that. Another method that you might want to know is the empty method, which returns true if queue is empty, otherwise it will return false. So this is basically a boolean value, or it will return a boolean value. And another method that you should know is the full function, which returns true if queue is full, otherwise false. Okay, so another boolean method. So right now, at the end of our actual threading task, let us see how we can implement this queue module into our existing program. So first of all, I will close this. We will go at the beginning right here. And before we do anything, let us import queue. So we imported the library itself. And let us set back the exit flag to 0 right here, as we might need it in the program itself. Let us go line by line and see whether there is something that we need to add. Right here we have the thread name, and instead of the counter, let us specify queue. Okay, and you will see why. Just right here at the counter, you simply just specify self q equals q. So this is another actual variable that we'll have as a part of our class. In the run function right here, there are a few things that we need to change. First one is adding the exiting right here. First of all, let us delete everything that we don't need. We'll delete these three lines. We will leave the starting plus self name, and right after it we will call a function that we will name process data. Now this function is not something that exists, we will need to code it, but before we actually code it, let us just call it right here. This function will take two arguments. First one will be self.name, which is the name of the thread itself, and self.queue. Okay. Another thing that we need to add right here is the exiting statement. Well, it doesn't really have to be added right here, but let us add it just in case. And then we will add this self.name in order for us to know which thread is exiting. Okay. Now we can code the actual process data function. So let us go right here, def process underscore data. And we know that it takes two arguments. First one is the self.name, while as the second one is self.queue. So we'll specify right here thread name comma queue. Okay. And now we're going to use our exit flag that we added at the beginning once again. So while not exit flag, exit flag, we will use the queue lock. So queue lock dot acquire, we will use it right here. If not, work queue dot empty. What we will do is we will simply just set the data to be equals to queue.get. Okay, so simple as that. Now before you actually ask what this is, don't worry, we will define all of these values later on in our program, all down here, as well as the redefining the thread locks and thread list and all of that. But for now on, let us just name them like this. Don't worry, this is not something that exists, this is something that we need to define. And right now, queueLock.release, which is the function that we will call right here in order to release it. And then the print statement comes right after, which is going to be %s, and then processing %s, and then we will add with the %, the thread name, and the data itself. And you will see in just a second what this will perform as soon as we actually code the else statement, which is going to simply just do the same thing, which is queueLock.release, and then it will sleep for 1 second. So time.sleep, and specify 1 second right here. Okay, so simple as that. Now we can delete this print time function as we don't really need it in this example right here. So let us just delete it, and let us define all of these things that we used in the actual function process data. So first thing, let us delete this as well. And we will simply just type here, first of all, we will create a thread list, but it will not be an empty list as in the previous example. Right here, what we will do is we will also put the names of the threads in the list at the beginning of the program. So thread 1, thread dash 1, then comma, thread dash 2, comma, and then thread dash 3. Okay, so this will be the name of our list, the name of our threads that are stored in this list right here. And we will also have a name list, which is going to simply just store the names as 1, 2, and we will store it up to 5, so 3, comma 4, and then the last one, which is going to be 5. Okay, so we have two lists. One of them is the thread list, and the second one is the name list. Okay, and then right after it, we noticed right here that we used something called queueLock right here. So we need to define what queueLock is, and simply what queueLock is equals, and that is basically a lock from the threading library. So threading.lock, we already used it in the previous example. Just right here we redefined its name. And then the next thing that we notice that we used, and that doesn't simply just exist like that, is the work queue. So specify right here, work queue is going to be equal, and now we will use the queue library and specify the object queue.queue. And it takes an actual input of 10, which is the argument for the queue class from the module queue. And right now at the end we will create an empty threads list, which is going to be the same as before, and the thread ID will be set to 1. Okay? So these are all of the things that we need to predefine at the beginning of our program, and right now we are ready to create new threads. So simply we will just delete all of this. Okay, so we can leave this 14 threads t.join, I think, but we will delete this right here. And we'll simply just create the new thread. So in order to create it, we will simply just for tname, which stands for thread name, in the thread list. And thread list is a list that already has names predefined right here. As we can see, thread 1, thread 2, thread 3. Okay, so for tname it threads list, what we will do is we will simply just specify thread to be equal, and then we will call our class, which is the myThread class. So my thread, which will take 3 arguments, which first of all is the thread ID, tname, which is the name of the thread itself. So in the first time it will take the tname as thread 1, in the second time it will take the tname as thread 2, and in the third time the name or the name of the thread will be thread 3. Okay, so simple as that. And the last argument that it takes, as we can see right here at the beginning, we did change it. We have something called queue, which is simply just our queue, and then we will specify right here to parse as a third argument the work queue, which we defined right here. Okay, so simple as that. And all we are left to do is start this thread as soon as we parsed all those arguments. So thread.start, and we will append it to our empty threads list as in the previous example. So threads.append, and we will add thread right here. And you might be asking, where does this thread ID come for? Well, we will simply just, since we are passing it in the actual for loop right here as the thread ID, we want to increase it so not every thread of all of these 3 threads gets the same thread ID. So the first one will get thread ID number 1, and then once it goes to the beginning of the for loop, we need to increase right here thread ID plus equals 1, so that the next thread can have the ID of 2. Okay, so simple as that. Right now the next thing we want to do is fill the queue up. So in order to do that, let us go down here, and we'll simply just specify queue lock. So queue lock acquire right here, and now we need to use this names list right here. So in order to use it, we will simply just perform another for loop. So forward in name list, oops, it is not capital name, so name list, we will put the word into our work queue. So work queue, as you remember the put function, I explained all of these functions at the beginning what they do briefly, and we'll simply just put the word into our queue function. And then we will call, after the for loop is finished, we will call the queue lock to release. So simple as that. Okay, we will also check for the queue to be empty, so we will wait for queue to be empty, simple. And how we can do that is we will simply just use while not, and we will use the empty function for the queue library, which I also explained. So while not work queue dot empty, we can use pass. So simply just to pass, we will not perform any task right here, and all we need to do is notify the threads when it is time to exit. So we will simply just set the exit flag to be equal to 1 right here. So exit flag equals 1. We'll simply just put it right here, and then we will wait for all threads to complete and terminate with this for loop that we didn't even change from the previous example, and at the end we'll simply just print exiting main thread. So what we are expecting right here is that the threads start one by one, so starting thread 1, starting thread 2, starting thread 2, and then starting thread 3. Then the thread 1 will be processing all of these values that we specified in the name list, which will say simply thread 1, for example, processing 1, and then a different thread will process the different number, which is written by the string right here. And as soon as they finish all of these 5 words right here, they will all terminate, or all threads will terminate, and then the main thread will terminate as well. So that is the plan. Now let's see how that will work. If we save this and simply just run the program or run module right here, we can see restarting, exiting thread 2, exiting thread 3. Let me just see right here. Let's see, for some reason it didn't really print it out. Let us see why is that. So we did set the exit flag, maybe that could be the problem. So define process data. Wait, let me just delete this, or let's leave it just at the actual hash. So let's leave it as a comment just for a case, so we don't really try to find the error. In case that is the error, we will run this. Yeah, okay, that is not the error. Let us remove that. The threads list has the thread 1, thread 2, thread 3. Processing, then the data. Then we sleep for 1 second. It is as if this this function right here is not even closing. qlog.acquire, that is good. If not, for q.empty, so we check if it's empty. If it is not, then we get the data, we will release the qlog, and then we will print processing, and then we will simply just specify right here the thread name and the data. In the else statement, we also release, which should be good. We have defined everything right here. Then we create new threads, so we create it simply by calling our own class. Then we append the thread. We also increase the thread ID by 1. The qlog acquire is called right here. Then forward in name list. Let me see right here. qlog.release while not qwork empty pass, and then exit flag. The problem right here is, I would say, okay, never mind, we did call the process data. I for 1 second thought that we didn't really call it right here, but we did call it. Well, for some reason this doesn't want to work, but I assure you that once I find the error, I will make sure to notify you in the next tutorial. For now on, this one actually got a little bit too long, so we'll just cut the tutorial short here. We basically learned everything we needed about threading in this tutorial right now, and therefore we can continue with our socket programming and see how we can briefly implement the threaded server. So right now, by now, you might also have an idea how to do that, and we'll see how we can do that in the next tutorial. So hope you enjoyed this lecture, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now what we're going to do is we're going to take a look at the threaded server in Python 3. Now what we did in the previous tutorial is we saw how we can use both the underscore thread and the threaded library in order to implement different threads into our program and to make our program to be able to execute multiple stuff at the same time. Okay, right now we're going to take a brief look at how would the threaded server look like. Of course, we're not going to code it. It is just simply the same as the normal server, just with the implementation of the threading library that is going to handle each client separately. Okay, so open up your idle right here. Let us enlarge this, and basically first of all we need to import both of the libraries that we'll need. So we will import from socket import everything, and we will also going to need to import threading. Okay, so simple as that. And basically the idea of the threaded server is that each client is going to be handled by a separate thread. So what does that mean? We know that once we create the thread, we need to specify onto which function is the thread going to perform, and also with different arguments to that specific thread. So we know that in order to communicate with clients over TCP connection with socket library, we need to specify the client socket object that is stored somewhere in the memory. So each client will have a different socket object. So already by now we know that the function that is going to be executed by thread will need to take an argument of the client itself. So we would have a function that would look something like this: define handle client, which is going to take an argument of the client socket object. Then we would perform some task for the client itself, so something like that right here. Then we would close the connection with the client, and then we would return from the function itself. So basically you just handle the client, you perform whatever you want to do with the client, whether it is a transfer of files, whether it is communication, or basically anything you want to do with the client itself. You would type it right here in a piece of code, then you would close the connection with the client, and you would return from the handle client function. Okay? Now, in order to call that function, first of all, let's create the socket object. af_inet is what we're going to use in sock_stream. Basically, the binding, we will bind the, doesn't even matter, bind your own local host, or basically bind your IP address or the server's IP address, whatever you're using, onto whatever port. In this case, what I will do is I will use the port 9000. Then you listen for, let's say, 5 connections, and simple as that, you set up your socket. Now, the crucial thing right here is that in the while true loop, and the reason why we're using a while true loop is because we need to accept the function, we need to use the accept function to accept different clients at all times that this threaded server is running. So in order to do that, since we're using the TCP connection, we need to specify the first actual variable to store the socket object of the client, and the second variable will store the actual address of the client, which is his or her IP address, and basically the port number that they're connecting on. Okay, and then that equals s.accept, press here enter, and right here you would type the thread that you want to start. Okay, so simple as that. It would be equal to t equals threading dot thread, and in between the brackets we already know what we need to specify. We need to specify the target of the actual function and the argument that we want to parse to that function. So the target equals, basically this target equals represents which function we want to target. We want to target the handle client function, comma, and then we need to specify the arguments to be equal to C. Press here enter, and basically this would be your entire function. Okay, so I will just control C this, or I really can't control C because it is in a while true loop, therefore I need to actually close this program. Yeah, I will terminate it. That would basically be the basic idea behind the threaded server. Okay? Now, there is also another thing that you want to take a look at, which is forking server. Now, this is most likely used on Unix. Each client basically, or it can also be used on Windows, but it is mostly used on Unix. And the basic idea is behind that is that it is really similar to the threading, just that in forking server, each client is not handled by a separate thread. Each client is handled by a sub-process. So in order to do that, it would look something like this. So import OS. From socket we can import everything, and then we would create the socket object as usual. So s equals socket, and in between the brackets we specify af_inet sock_stream. We bind our IP address with the port, doesn't even matter. Oops, as the bind. Bind takes exactly one argument. Oh yeah, the actual error is because I am missing another open and another close brackets. Make sure that you open 2 and close 2 brackets, so right here. Okay, so this works. And after you specify the listen as well, what you will need to specify is in a while true loop you would also accept the connections, and you would use the OS library to perform the fork. Now that's managing client and managing the child process, and it would look something like this. So see while true, first of all we enter the while true loop, and first thing that we want to do in a while true loop is to accept the client connection. So C, A, first of all, first stands for the first C stands for client and the A stands for address. I believe you already know that. So s.accept, press here enter, and what you would check right here is if os.fork is equal to 0, then right here you would manage the client. So you would basically manage client, perform some task right here, then you would close the connection, and then you would os._exit with the 0. Okay? In the else statement, oops, it seems that I have accidentally exited the actual while true loop, but the else statement, let's just hypothetically say that the while true loop was still right here. Basically this would be the parent process, and you would clean up everything and go back to accepting and waiting for more connections, and then you would close the actual connection with the existing client. Okay? But if you want to, you can use both of the ways. I prefer to use the actual threading server in order to accept and in order to manage multiple clients at the same time. Okay? So first of all, I will need to close this because we are once again in an infinite while true loop. Let me enlarge this right here. And another thing that you should know about is the asynchronous server. Now server handles all clients in an event loop. Basically that is what it stands for. And in order to do that, you simply need to import the select library and also import the socket library. So the asynchronous server would look something like this. You would create the socket object with our regular line s equals socket and then specify a finet and sock stream. Then you would perform the code, and then you would have an actual list of clients, not cleanets, clients equal open and close square brackets, list of all active client sockets, and then in a while true loop you would look for activity on any of the existing sockets or on any of the existing active sockets. You would simply just do something like this in a while true loop. You would specify input, output, error equals select.select s plus clients. And then you would process all sockets with the input. So for I in input, you would use a simple for loop. You would perform some part of the code that you want to do there. And then at the end, you would process all socket clients ready for output. You would simply once again perform the output, or pardon me, the for loop in order to do that. Okay? So basically, this is not used that much, but you can use it if you want to. Of course, read more about it on the internet. This is just a brief overview in theory how all of that would go. But for now on, let us actually go with and check out some of the different functions that the socket library provides for us. Okay, so basically let us just close this and we'll simply just check something else that we should have checked before, but there are also a bunch of other functions that you can do with the socket library. Instead of just creating the TCP and the client connection and so on, you can simply just perform some simple tasks such as getting the host name of the local machine, let's say. So if you simply just type socket.getHostName, press here enter, what this will output is it will output the name of the machine that the program is currently running on. Now this is just one of the simple tasks that you can do with the actual socket library. You can also try to get an IP address of a remote machine. So what does that mean? It basically means that you will specify the name of the server in the brackets, and then what the function will do, or the function getHostByName will do, is it will retrieve the IP address of that specific name. Okay, so let's say we want to get the IP address of python.org website. We can simply do that just by specifying socket.getHostByName, and in between the brackets we will need to specify the actual server name of the Python website, or the website name, so www.python.org. Press here enter, and you will see right here this is the IP address of the python.org. Let us try with a different website, so socket.getHostByName. Let's say we want to go to twitter.com. We want to know the twitter.com's IP address, and we can see that we get the IP address 104.244.42193. Okay? Now there is also a reverse function that performs this, which is the getHostByAddress. What this function will do is it will actually perform our reverse function from the getHostByName. What you would specify in between the brackets is the IP address that you want to get the name for, and what the Python will retrieve is it will retrieve the host name for that specific IP address. So let's try with these two examples right here, since we got their IP address. And in order to do that, we'll simply specify socket.getHostByAddress, and in between the brackets you simply just specify the IP address. So let's try with the first one and see whether we will get python.org as an actual name. So specify it right here, host not found. Let us see right here, for some reason host is not found. Let's try with a different one. So socket.getHostByAddress, and we specify 04.244.42193. Press here enter. Get host by address. For some reason this doesn't want to work, but it doesn't even matter. Maybe I'm specifying something incorrectly. Maybe the syntax is actually different, but it doesn't really matter. We won't really bother with this. There are a bunch of other options in sockets as well that we can use. Basically, socket is a huge library and a huge model. It has hundreds of basically obscure socket control options, flags, and so on and so on. Many more utility functions. It also, instead of supporting just the IPv4 protocol, it also supports the IPv6 protocol. There are also other types of sockets. We also saw sock_dgram or sock_stream, but there are also different ones such as sock_raw and many more. Now, it is often unnecessary to basically directly use these sockets, but other libraries exist to simplify our usage. So for example, we know that the socket is low-level programming, low-level networking, let's say it like that, and there are basically different other modules that allow us to perform everything easily than we would do with this socket library. We will see it in the next tutorial, such as FTP, then SMTP_lib in order to send the actual emails over Python 3, then also, for example, let's say URL_lib, which is similar to the requests library. We will take a look at that as well, but more about that in the actual next tutorial. So we'll take a look at the HTTP, FTP, SMTP, and so on. So hope you enjoyed this lecture, and I hope I will see you in the next one. Bye! Hello everybody, and welcome back to this tutorial, and let us take a look at different libraries and modules that we can use in order to perform, let's say, FTP connection and file transfer, in order to send emails using the SMTP_lib library, and also take a look at the URL_lib module. Even though we took a look at before at the request module, we're also going to take a brief look at the URL_lib module right now. Okay, so basically Python has library of modules for interacting with a variety of standard internet services such as HTTP, FTP, SMTP, NNTP, and so on and so on. And right now we're going to take a look at some of them. Okay, so first of all, let us start off with the URL lib module, because that is the one that is mostly similar to the one that we already did before, which is the request module. Therefore, you really shouldn't have a problem at understanding it. Basically, a high-level module or URL lib module is a high-level module that allows clients to connect a variety of internet services such as HTTP, HTTPS, FTP, local files, and so on and so on. It works with typical URLs on the web. So let us open up our idle in order to check it out. Simply, just to import it, you would type import URL libs. Now make sure that you add double L, so URL and then lib. Press here enter and you will see that it will import it without any error. Okay, so first thing that we're going to take a look at, simply, or basically one of the only things that we're going to take a look at in the URL lib module, is opening a web page. So it is similar as in the requests. Simply all you need to do is specify, for example, u equals URL lib dot URL open, and in between the brackets you will need to specify the page that you want to open. So for example, let's say http www.python.org. Let me see right here. Module URL lib has no attribute URL open. What do you mean has no attribute URL open? Of course it does. Let me just go right here. URL lib URL open HTTP. Let's try a different website. Okay, for some reason it doesn't seem to have the actual URL open attribute. Weird, but it doesn't even matter. We will just skip over that one, as the URL lib is not even that much. So let us go on to the different thing, which would basically be the FTP protocol. Now don't worry about this URL lib, I just want to show you that it does exist. It is not really used anymore, as the request library is much more used, and we covered the request library before. Therefore, we're simply just going to skip it. You don't really need it, and for some reason I was pretty sure that this function exists, but it doesn't seem to really exist. Therefore, we're going to go on to the FTP protocol. Okay, so first of all I will restart this and we will continue with the FTP protocol. And in order to do that, you can simply just import a library called ftplib. So basically the module ftplib defines the class FTP and a few other related items, but the FTP class implements the client side of the FTP protocol. We can use Python to write programs that will perform a variety of automated FTP jobs, such as, for example, mirroring other FTP services. It is also used by the request module to handle URLs that use FTP. Okay, so let's take a look at the example of using the FTP lib module. So we can import it just like this from FTP lib import FTP. Press here enter. It will import it without any problem, and right now we can simply just connect or try to connect to a host using FTP. So in order to do that, we will use the FTP class and we will create an object which we will simply just call FTP, then call the FTP class, and the class takes one argument, and that argument is going to be the actual name of the server that we want to connect, or the host name. We can go ftp.debian.org, press here enter. Okay, so this refuses it. Let's go with my router 192.168.1.1. You can simply just use any FTP host you want. In my case, I will just use router. And then, in order to create a user anonymous and password anonymous login try, you can simply just type FTP login and open and close brackets. And basically, if it is allowed, you will be able to log in. If it is not allowed, you will get this error that I got right now. User anonymous cannot log in because the anonymous username and password are probably blocked in my router, as well as they will probably be blocked at any FTP server that basically is reconfigured and updated. Okay, so once you actually get into the FTP server, there are certain tasks that you can perform, such as, for example, ftp.cwd, which basically changes into a certain directory that you specify in between the brackets. So, for example, home directory or /home, doesn't even matter. It would change into /home directory. Okay? Now, another thing that you would be able to do once you log in into an FTP server is use a function retrieve lines basically, and in between the brackets you simply just type list, and what this will do is it will simply just list directory contents. Okay? And in order, there are a bunch of other things that you can do with the FTP module, and what you can do right after you log into the FTP server or host, which I currently don't really have. That's why I'm just showing you these functions. But more about actual FTP lib you can find online on the official Python 3 page. And in order to, let's just take a look at another function. In order to quit the FTP login session, you can simply just use ftp.quit, and it will simply just quit the FTP. Now right here in my case it says login failed because I didn't really even log into my own router, but if you were to log in, you would simply just type ftp quit, and then you would quit the actual FTP login session. Okay, let us close this, open up our idle once again. Idle. And what we will do right now is we're going to take a look at sending emails using the SMTP library. Okay? Now, first of all, what is the SMTP? Well, the SMTP is a protocol which handles sending an email and routing email between mail and servers. Basically, Python provides us with the SMTP lib module, which defines an SMTP client session object that can be used to send mails to any internet machine with an SMTP or eSMTP listener daemon. Okay, so let us take a look at the simple syntax to create one SMTP object, which we can later use to send an email. So first of all, in order to be able to do that, we can simply just import SMTP lib. This is the library that we will use in order to send the email, and right now we need to create the SMTP object, and we will simply just do that just by specifying SMTP object equals SMTP lib.smtp, oh whoops, not SMPT, SMTP, and in between the brackets you need to specify the host, the port, and the local host name. Okay? So basically the first parameter, which is the host running your SMTP server. You can specify the IP address of the host or a certain domain name. Now this is an optional argument. The next parameter, which is port, is basically if you are providing host argument, then you need to specify a port as well, which is logical. Now the port has to be the port where SMTP server is listening. Usually this port should be 25. And the third argument is the local host name. So for example, if your SMTP server is running on your local machine, then you can specify just the local host name or local host as the option. Now, an SMTP object has an instant method called sendMail, which is typically used to do the work of mailing a message. Now it takes 3 parameters. Basically, we're going to take a look at the example, don't worry, but let's first of all talk about it. So it takes 3 parameters: the sender, which is a string with the email address of the sender, which is logical. The receiver is a string list of a person that is receiving the actual message or the actual email, and the message itself, which is a message that we are going to send to our receiver. Okay, so let us take a look at the simple way to send one email using Python script. Okay, so first of all, we will import the SMTP, and then we will simply just add 2 different variables, which is going to be the sender. We can specify right here anyone@gmail.com. I'm just using made up actual emails, and the receiver will be, and we can simply just specify once again anyone@gmail.com. Doesn't even matter right here. If you want to test this out, of course, specify correct emails. Just use 2 of your emails. Try to send an email from one and then see whether you received it to another email, okay? And then the next thing that you want to actually add is the message itself. So the message, you can type anything you want. Let's use the multi-line string definition with 3 open single quotes, and then we can type right here from, and then person name. We can simply just add something like this. Whoops, wrong button. Where is my greater or lesser sign? Okay, so here it is. Once again, it took me quite a while to find it. I wanted to change my keyboard in order to not make that mistake once again. And right here, we simply just specify from who it is. So anyone@gmail.com. Then in the next line, we can specify to person at this actual email address, which is anyone@gmail.com. Okay, then you would simply just type here subject SMTP email test, and then down here you would type the message that you want to send. So this is my email message. Type here dot and then close 3 single quotes in order to define our message. Okay, so we defined 3 different variables. One of them stores the sender email, the second one stores the receiver email, and the third one is the message that we are about to send. All we are left to do right now is create the SMTP object and then send the email using the sendMail function. So let us try to do that using the try and except rule. Press here try. Let us create the SMTP object first. So SMTP object equals smtplib.smtp. In between the brackets, we'll specify localhost as our actual sender because we are simply just sending over our own PC. Press here enter, and then we need to use the sendMail function and specify our desired 3 arguments in order to send the email. So let us do that. SMTP object is going to be, we are going to call the sendMail function. And in between the brackets right here, we specify our 3 variables right here, which are the sender, receiver, and one more thing that I want to mention, if you want to send this to multiple people, you can simply just make the receiver to be equal to an actual list, which is going to contain the actual number of email addresses that you want to simply send to. So different email addresses would be stored in that list. But for now on, we'll just simply use sender, receiver, and message as a third argument. And if that works, we will simply just print successfully sent email, and then accept the SMTP exception. We'll simply just print unable to send email. Press here enter for some reason. Yeah, it is probably SMTP exception is not defined. Really? Is not defined. Let us go once again and try it. So try, or let us just go without try. Let us just go SMTP object equals SMTP lib.smtp, localhost once again. No connection could be made because the target machine actively refused it. Yeah, it could be because my firewall or something like that is refusing the connection with the SMTP, even though you specify localhost. That's why we're getting this error, but doesn't even matter. The syntax goes like that. And make sure that once you actually send the email, you send it to your own self, just so you can check out whether that exists. Now, basically right here in our example of code, you placed a basic email in message using a triple quote, taking care to format the headers correctly. Now we know that we created the email headers right here in the message itself, as we can see, from, to, and subject. And to send the email using the SMTP object to connect to the SMTP server on the local machine, we need to use the sendMail function right after it, along with the message from address and the destination address as parameters, even though the from and to addresses are within the email itself. These are not always used to route the email. Now, if you are not running an SMTP server like I am, or like I'm not running on my local machine, you can use the SMTP-lib client to communicate with a remote SMTP server. Unless you're, of course, using a webmail service such as Gmail or Yahoo, your email provider must have provided you with server details that you can supply in the SMTP-lib creation. So, for example, this right here, let me just find where did we code it. Okay, so this right here, if you have the SMTP server, you can simply just type here SMTP object is going to be equal to smtp-lib.smtp, and in between the brackets you will specify the server. For example, let's use the gmail.com, so smtp.gmail.com at the port 587, press here enter, and then you would simply just use the sendMail function in order to send the mail. So for example, it's smtp object.sendMail, and you simply specify sender, comma, receiver, comma, message. Press here enter, and you will see that this will work whether you specified everything correctly. As you can see in my case, it says sender refused, must issue a start TLS command first. Let me see right this. Let's try smtp object.start TLS. Okay, and smtp object, let us just copy this and see whether that is the problem, which I highly doubt. We simply just specified non-existent email addresses. Yeah, must issue start TLS command first, doesn't even matter. We know that it wouldn't work anyway, okay, because we simply specified the email addresses that don't really exist, and we didn't really provide the actual password or username and password for that specific email, okay? But more about that later on. For now on, we are mostly interested in sending an HTML email using Python. Let me just restart this because it looks ugly from all of these errors. Let us open up our idle, import smtp-lib, and right now, let's say you want to send a text message using Python. Well, all of the content is treated as simple text, as we saw in the previous example. Even if you include the HTML tags in a text message, it is displayed as a simple text, and HTML text or tags will not be formatted according to the HTML syntax. Now, however, the Python provides us with an option to send an HTML message as an actual HTML message. While sending an email message, you can specify a MIME version, content types, and the character set to send an HTML email. So for example, it would look something like this. You would import smtp-lib, then you would create a message variable to be equal, open 3 single quotes. You have, let's say, from and then person. I'm just showing you the format of a message that you will need to use to send to. So from @gmail.com, close the tag, then to person, and then right here you would also specify to@gmail.com. MIME version, let's say we want to specify that as well, 1.0. Content type, so content dash type text/HTML, subject SMTP HTML email test. And then right here, let's say we have a message. This is an email message test. And down here, let's say you want to implement some HTML tag, you would do it just like this. So let's say you type here, oops. This is HTML message. Oops. dot, then close the tags right here, /b, and let's use a header with the size of 1, let's say, doesn't even matter, this is just some simple HTML code, this is headline. Okay, then we close the HTML tag for the header, and down here you can close this simple message, and now all you will need to do is perform the same thing as before, so create the SMTP object equals smtplib.smtp, use your actual SMTP server to send the email, and then perform the sendMail function with specification of the sender email, receiver email, and the message itself. And basically right after that it should work and you would be able to actually send the email just like that. Okay? Now another thing that we are going to take a look at right now is sending attachments as an email. So to send an email with mixed content, it requires setting the content type header to multipart or mixed. Now we can see right here we set the content type to be equal to text/HTML. If you simply just leave it like that, sending attachments will not really work. Now the attached file should be encoded with the pack_m function to have base64 encoding before the actual transmission. Okay, so right now let us see an example of how something like that would work like, or would look like, pardon me. You would simply need to import two libraries. First of all, we need to import the SMTP_lib, of course, in order to actually send the email, and then we will import the base64 library in order to encode the data, that we want to send. So let's say you want to send some file. We know how we can open file, we know how we can read from a file, so let's combine that with the encoding of the base64 in order to get our encoded content and in order to be able to send that encoded content via email. So let's say fn is our file descriptor equals open, and right here you specify some file name, doesn't even matter, as read bytes. So you type here RB, that stands for reading bytes, you press here enter, and the next thing that we want to do is get the file content. Now we can get the file content just by using the read function, so file content equals fn.read, open and close brackets, press here enter, and we are not done yet right here. We need to also encode that content so everything can be received correctly by the actual receiver. So we'll create a variable which we will call encoded content. It will be equal to base64.b64 encode, and we'll specify the file content in between the brackets. Okay, so this is something that we're going to send. We managed to extract it using the file, reading from the file, and then encoding its content. So right now you can simply just specify the sender to be equal to anyone@gmail.com. Receiver can be equal to anyone@gmail.com. And also, in order to do this, we need to also set the marker. Now, in order to actually set the marker, you would specify marker variable to be equal, and right here, in between the double quotes, you typed AUNIQ marker. Make sure marker, let me just see right here. Okay, so it is marker. And then you create the body of the actual message or the actual email from which you are sending the attachments from. So body equals, opens 3 single quotes. This is a test email to send an attachment. Close 3 single quotes. So this is going to be the body of our email. And now we want to define our main headers. We did that also in the previous example. So let's just call it main_headers, doesn't even matter. Open 3 single quotes from, and then person from @gmail.com. Close this tag right here, to person. Now, of course, you don't type here person, you actually type the real name of the person that you're sending to, but right now we are simply just not going to get bothered by that. We'll simply just specify whatever we want right here, gmail.com. Close the tag right here. Subject is going to be equal to sending attachment, Now, of course, it doesn't have to be named like that. This is just simply the subject or the header of your email. Now, what you do need to add is, first of all, let us just type the MIME version 1.0. Now, what you do need to add is the content type to be equal to multi-part and mixed. And also add the marker right there. So content type multi-part / mixed, then dot and comma, and then boundary equals %s, next line %s, and then in the next line you simply just close 3 single quotes, and right here at the end you proceed to actually type %, and in between the brackets you type twice marker, which is stored in this variable right here that we coded. Okay? Now, the next thing that you want to define is define the message action. So the message action will be equal to 3 single quotes, content type, and here we specify text / plain, and then content in the next line, transfer dash encoding column, and then 8-bit. Then you type here at the end %s, and then in the next line %s. In the next line close the actual 3 single quotes and type %, and the first %s will be body, while as the second %s will be the marker. And the last thing that we need to define before actually sending the message is the actual attachment section. So we'll just type it attachment _ section will be equal to 3 open single quotes, and simply just type here content dash type 2 dots multi-part / mixed column, and then name equals \, oops, where is the \? Yeah, okay, so here is the \, open double quotes, %s, \ double quotes, and then in the next line content dash transfer dash encoding base 64. Make sure that the encoding is same as the encoding of the attachment that we did right here. As we can see, we use the base 64 encoding on the file content. Therefore, in the attachment section, we will specify base 64. And also another thing is the content dash disposition, the column attachment, then dot and comma, and then you simply just specify file name equals %s, and we will add it right here. First of all, we need %s right here, and then as usual %s, and then --. And then in the next line, close 3 single quotes and specify %. And now let us count how many %s's we have. We have 1, 2, 3, and 4. So we need to specify 4 things right here. The first one is going to be the file name. The second one is also going to be the file name. The third one is going to be the actual content of the file, so encoded content. And the fourth one, as usual, is going to be the marker. Okay, and this will be our entire message. All we are left to do is simply just add all of this together. So in order to add it together, you simply just type message equals, and then you simply just type here main headers plus, and then message action plus, and then the last thing, which is attachment section. Press your enter, and now you have the message, and all you would have to do right now is simply create the SMTP object, which is going to be equal to smtplib.smtp. Specify your server or local host, doesn't even matter, and then basically SMTP object dot send mail, and you simply just specify sender, receiver, and the message that you are sending. And then you basically send the message over email with the attachment from the file. So that would be about it for the sending emails. Now we took a look at quite some stuff, just sending from sending the simple email to sending the email with an attachment. Now make sure that you always change this, or just pick your own server over which you're sending the actual emails. If you simply just leave it like this, it will not work, as you saw in my previous case. So make sure that you specify that information correctly, which can be different for anyone. And hope you enjoyed this tutorial, and I hope I will see you in the next one. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And right now what we're going to do is we're going to take a look at the PDF usage in Python. So Python being a high-level language, well, PDF is one of the most important and widely used digital media, used to present and exchange documents most likely, but PDFs contain useful information, links and buttons, form fields, audio, video, and business logic. Basically, it can contain anything. Now, why should we use the Python to actually perform the PDF processing? Well, PDF processing comes under text analytics. Most of the text analytics library or framework are designed in Python only. This gives leverage on text analytics, and once you extract the useful information from PDF, you can easily use the data into any machine learning or natural language processing module. Okay, so common Python libraries that basically are used to handle PDF files. We have PDF Miner, it is a tool for extracting information from PDF documents. We have PyPDF or PyPDF2. It is a pure Python PDF library capable of splitting, merging together, cropping, and transforming the pages of PDF files. It can also add custom data viewing options and passwords to PDF files. It can retrieve text and metadata from PDFs, as well as merge entire files together. We have also some tabula.py, Slate, PDF Query, and HPDF. Now, of course, we are not going to take a look at all of them. What we are going to take a look at is the PyPDF2 library. Now, if you open up your idle and simply just type here import PyPDF2, you will see that you will get an error, no module named PyPDF2. That is because this doesn't come pre-installed in actual Python 3. Therefore, we need to open up our command prompt, navigate to our actual Python scripts directory, programs, cd Python 37, then cd scripts, and there we will just type pip install PyPDF2. Press here enter, and this should perform the installation of the library that we need in order to actually perform these different tasks using PDF files. Okay? So let us see right here, successfully installed PyPDF2. Okay, we can close this right now, and we can reopen our actual terminal, or pardon me, not terminal, idle. Now let us go right here. Let us go to our Google Chrome. Let us type .pdf. Let us go to the PDF document. Doesn't even matter. The first PDF document that we find, we will open it, and this is this document right here. So let us save it. We will save it onto our desktop right here. Save it. Let me see right here. It is right at the desktop, as we can see right here. Let us rename it. Let's call it PDF file, doesn't even matter. Just so it doesn't only be named as PDF. Now we need to, first of all, in order to actually open this PDF file, we need to navigate to this desktop directory. So import os.print working directory, or os.get cwd. Okay, So os.change directory, and we want to change directory to this part of the actual link or the actual path. Paste it right here, and also add desktop. Press here enter, and now if we get current working directory, we can see that we are onto the desktop directory where our PDF file is. Okay, so right now that we did all of that, we can simply just import PyPDF2. So import PyPDF2 as we did install it seconds ago. Now find any PDF file object and open it as a regular file. So PDF file object is going to be equal to open, and in between the brackets we'll simply specify PDF file. Let me just see whether I have two F's or one. Okay, so one F. Let us just remove this one. PDF file .pdf, and then comma read bytes. Press here enter. We open the file, and now we want to create the PDF reader object. In order to do that, we can simply just type here PDF reader equals PyPDF2 dot, and now we're going to use PDF file reader onto our PDF file object, which is basically just our file being opened for reading bytes. So right here, specify PDF file object. Press here enter, and simply you created your PDF reader. Now let's say you want to get the number of pages in PDF file that you opened. You can simply just type here print PDF reader dot num pages. Press here enter, and you will see it retrieves an integer number of 5, which means there are 5 pages onto this PDF file. So let us open it. Let's see whether our Python is correct and whether there really is 5 pages there. We can see page 1, 2, 3, 4, and 5. Okay, so it really is correct. There are 5 pages right here. And right now, if you want to, for example, get a page object in order to edit or in order to check something in on a certain page, you can simply just do it by specifying a page object. Let's type it right this. Page object equals PDF reader dot get page, which is a function that will get the page specified in the brackets, and we want to page 0, which is going to be the first page. Okay, and now if we want to, for example, extract the text from the page, which will print the text, you can also save that into a string if you want to. Now in order to just print it, you can simply just type print and then page object dot extract text. Press here enter, and you will see the text from the page that we specified in our get page function. So this is the first page, all of the text from it. And if you want to change something to this, you can. And now let us take a look at the reading the table data from PDF. Now, in order to work with the table in PDF, we can use the tabula-py, which is another actual library that doesn't come in Python 3. Therefore, we need to pip install it once again. Let me just lower this. I will open up my command prompt. I will cd to the app data, cd to local, cd to programs, cd to Python, cd to Python 37, and then cd scripts. There we will install pip install tabula-py. We will let this install. It will collect the library itself. As we can see, it is a little bit larger library than the actual PyPDF2. And I will simply just use the syntax, and I will simply just show you the syntax of using this library. So we can see right here, collecting pandas. Okay, so it's collecting another thing that it needs. It is a total of 29 megabytes, as if this is everything. Okay, so it is not everything. We also need the NumPy library that is 11 megabytes large. So let us let that download as well before we continue. Hopefully that is about it. Okay, and on one more, which was a little bit long, smaller. Another one. Okay, It installed everything, installed collected packages, and right now hopefully this download will finish. Okay, it says the script f2py.exe is installed in this path, which is not on path, which basically means we can't run it from anywhere we want. Okay, and it's performing some of the finishing of the installation itself, so let us let that finish as well before we continue. And right now I will just show you the syntax while this is downloading. As we can see, successfully installed. Okay, we can close this. And right now, in order to actually import this library, you need to type here import tabula. Press here enter. It will import the tabula library, and you can read the table data. You can use something like this, so df equals tabula.read_pdf, and then you simply just pdf. And in between the brackets, you will need to specify the name of the file that you want to read from. Let us just see right here, Java command is not found from this pipeline, so Java is installed and path is set for Java. Okay, so looks like this library actually requires Java for some reason. Therefore, we will skip it because it is not really that important. You can just use py to PDF. I just wanted to show you an actual different option that you can use in order to handle PDF files, but doesn't even matter. We'll just leave it on that. What we saw right here is how we can open the PDF file, how we can read the PDF file, get number of pages, extract text from pages. Of course, there are other functions as well. Make sure to check them out on the internet. You can just simply type pypdf2 and see what available functions are there for that library. And hope you enjoyed this tutorial, and I hope I will see you in the next one. Bye. Hello everybody, and welcome back to this tutorial. And right now, in our last section, we are going to take a look at actually interacting with images in Python 3. So in order to do that, you will need a simple library which is called the image color. So first of all, we need to actually download it. So go open up your command prompt, navigate to the scripts folder. So cd programs, cd local, cd programs, cd Python, and then Python 37, and then scripts. And there, simply just type pip install image color. Now right here you can see for me a requirement is already satisfied, but you will need to install it in order for this to work. Then as soon as you install that, let us go to our actual Google Chrome and type here image. And basically we can download any image that we want. So let's say we want to download this image, save images, and save it on our desktop. Let's call it image simply. Okay, we can close this. We can see that the image is on our desktop. If we open it, it will open the image itself. It is the JPEG. Let us see right here. Okay, so here is the image, and right now let us use the image color in order to, for example, set some different colors and in order to interact with the image itself. So close this idle, or pardon me, this command prompt first, open up your idle. And first thing we need to do in order to interact with the image itself is go to the actual desktop directory. So import OS that current working directory. Then we will copy this first part right here. And then we will use change directory in order to change our directory to the actual, oops, what is this right here? To the desktop. Yeah, I forgot to close the single quote. Let me just do it again. Oh, yeah, it is not this one. It should be up to here and not after the app data. That's why it can't really find the directory. So let us just go like this. Yeah, now it will work. And then we need to import our image color. So in order to import it, you simply just type from pil import image color. Press here enter, and simply in order to use the actual image color and the RGBA, you can simply just type image color dot get color, and in between the brackets specify the color name, which is red, and then comma, and then open and close single quotes RGBA. Press your enter, and you will see the actual RGBA value for the specific color. If you want to, for example, get the for different color, let's say you want black, so image color dot get color, and you want to get the color black or the RGB value for the color black, you will simply specify the same as in the previous example. Press your enter, and you will see the RGBA value for the color black. Now you can also specify some different colors, such as for example chocolate color, so color.get color, and you specify chocolate, comma, RGBA. You will see it gets a different value for the actual RGBA. Now let us take a look at using the coordinates and opening the image with this image color library. Okay, so simply just, if you open up a new idle, you simply just type the same import as this one, and then in order to actually import the actual image, you simply just type image equals, well, let's use img, just so we don't confuse it with the actual library itself. So img equals, and then we will specify image.open, and in between the brackets we specify the image name, which is image.jpg. I believe that is the name. Image is not defined. Oh yeah, pardon me, it is not the same import. Let me just restart this real quick. We need to import a little bit differently. So in the previous actual example, we used from pill import image color, and right now all we want to do is from pill import image. Yeah, it is from pill import image. So simply just type it like this and not image color. You only want to import image, and now you should be able to open the image itself. So image.open images, or image, let me just see how did we save it, image.jpg. Yeah, right now we need to import OS in order to navigate to actual desktop directory once again, because we did restart terminal, or pardon me, idle, not terminal. And now os.change directory, and in between the brackets we will simply just specify, I said in between the brackets, but for some reason it put it outside of the brackets. We will fix that just like this, and then to the desktop. Press your enter, and now let us try to finally open the image on our desktop. Image.jpg, press your enter, and we successfully opened the image. Okay, so the open function actually opens the image, and now right now let us see what we can do with that image. So let's say we want to, for example, get the size of that image. We can simply just do that just by specifying img, which is the object of the image itself, and then dot size. This will return the actual size in pixels, as we can see 640 or on the 400. We can also store that into two different variables, such as for example width, comma height equals img.size. Then if you want to print some statement, the image width is, and then simply just add width plus or comma, and the height is, and then once again comma height. We can see the image width is 600 and the height is 400. Okay, so simple as that. If you want to get for example the name of the image, you can simply just type image.filename. It will return the image.jpg. Now you can also try to get the format description, so image.format underscore, I believe, underscore description. Press here enter, you will see JPEG ISO 10918, and you can also save the image just by simply typing img.save and then image.jpg, or however you want to call it. You can simply just save it like that. Okay. Now, if you want to interact with the image somehow, you can simply just type. Let's say we create an IM object equals image.new, and then open and close brackets. Specify RGBA, because we're going to specify the RGBA value right here, comma, let's type 100, 200, and then let's say the color will be equal to purple. Press here enter, and then let's say you want to save that image, you simply just type im.save, and there you specify the name, let's say purple image.jpg, or let's do PNG, doesn't even matter. We'll press here enter, and now if we go into our desktop right here, we will have the purple image that we created. We can see if we open it, it will be a color purple. The actual width is 100, while as the height is 200 that we specified right here. Okay, we use the RGBA values of the purple color. So that is how you can do something like that. You can simply just do try a different color if you want to. So im2 equals image.new, in between the brackets specify RGBA once again, comma, whoops, comma, then the actual width will be, let's say, 1080, and then the 900, and then the height will be, doesn't even matter, and then we'll just simply specify blue, press here enter, and then if we just type im2.save blue image.png, press here enter, it's saved. Go right here, let's close this, and now we have the blue image as well right here. Okay, now let's say you want to crop an image. You can also do that just by using the crop function from the actual image library. Okay, so let's say we want to crop that image. We can simply just type cropped image is going to be equal to im2.crop, and you open and close two brackets, and here specify the RGBA. So for example 335, 345, 565, let's say, and 560. Press here enter, and then if you want to save the cropped image, you type cropped image.save, and let's call it crop.png. Press here enter, save the image, and you can see right here these two images are no longer different. We can see right here this is the cropped image, while as this is the original image that we created 1 minute ago. Okay, now if you want to, for example, copy paste a picture into a different picture, you can also do that. So let's say you open the, first of all, let me just restart my idle. Right here, import OS, os.get current working directory. We'll copy this as usual. os.change directory to the, and then desktop. Then we will from pl import image, and right here first of all we will open an image. So img will be equal to image.open, and we will open our downloaded image, which is image.jpg. Press here enter, and then if you want to copy that image, you can simply just type image_copy will be equal to image.copy. Press here enter, this will copy the image. If you want to crop some part of this image, we already saw how we can do that. Let me just go this to the right. Let's say we want to crop some part of this image. Let's say we crop a piece of it. We can simply just type image or cropped image once again will be equal to, let's say, image.crop, and we will specify the same numbers as before, so 365, comma 345, comma 565, comma 560. Press your enter, and this will be the cropped image of our downloaded image. And then in order to actually paste this image to a different image, we can simply just type, let's say, image_copy dot paste, and then in between the brackets we specified cropped image underscore image, and then comma, and let's type 0,0. Press your enter. Let's see if this will work, and let's try to actually save it. So image copy dot save pasted dot png. Press your enter. We can see right here it successfully did save it, and we can see right here it is cropped. We don't have anything right here. If you compare it to the regular image, we have the full image right here. Okay, so basically that would be about it for this tutorial and also for this course. Now basically this was a beginner course. I showed you some of the different modules that are used in Python 3 programming, showed you some of the most basic functions that you will use most of the time. We coded some of the actual coding projects, examples here and there. You introduce yourselves really well with the specific and basic options and things in Python 3, such as classes, functions, variables, strings, and so on and so on. We also took a look at the networking, website interaction, different files we opened in Python, time module, and all of those different kinds of stuff. Now, of course, this course will not get you to an advanced user. Of course, you will need to practice more and more, as well as learn from different courses or books or something like that. And most likely, you will need to specify at one single task in Python 3, such as, for example, data analysis, cybersecurity, networking, interacting with websites, machine learning, and so on and so on. So Python 3 is a huge language. What I showed you right here is only a little bit of Python 3. Therefore, you should continue learning it as much as you can in order to perfect your skill of being a programmer in Python 3. So basically, this was our last video. I hope you enjoyed it. I hope you did learn something new from it, and I hope you will use it for your own needs. So thank you for sticking out till the end of this course with me, and I hope I will see you in some future course. Take care and bye.